No. Okay. I think less than maybe 1% I say. Thank you. I would request all the dignitaries now to please be present on the dais. Dr. Vinay Kumar Dadwal, please. Srimati Ummi Khan. Dr. K. Ganesh Raj. Dr. Ramakrishna. Dr. A.M. Ramesh. Dr. Anand R. Karnataka Science and Technology Academy, Department of Science and Technology, Government of Karnataka, in association with National Bank for Agriculture and Rural Development, that's NABARD, and Ministry of Earth Sciences, Government of India, jointly organizing a national conference on climate resilience and sustainable development. ಹವಾಮಾನ ಸ್ಥಿತಿಸ್ಥಾಪಕತ್ವ ಮತ್ತು ಸುಸ್ಥಿರ ಅಭಿವೃದ್ಧಿಯ ಕುರಿತು ಈ ಒಂದು ರಾಷ್ಟ್ರೀಯ ಸಮ್ಮೇಳನಕ್ಕೆ ತಮಗೆಲ್ಲರಿಗೂ ಆತ್ಮೀಯವಾದ ಸ್ವಾಗತ. A very warm welcome, ladies and gentlemen, which brings, especially on this wonderful, beautiful, auspicious day, which brings together all the beautiful people like you here to make this national conference grand success for next 3 days. I welcome once again. ನಮ್ಮ ಒಂದು ವಾಡಿಕೆ ಇದೆ, ಯಾವುದೇ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಯಶಸ್ವಿಗೊಳಿಸಬೇಕಾದ್ರೆ ದೇವರನ್ನು ಸ್ತುತಿಸಿ ಆ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಪ್ರಾರಂಭಿಸಬೇಕು ಅಂತ ಹೇಳಿ. ಆದರೆ ಇಲ್ಲಿ ಕುವೆಂಪುರವರ ವಿರಚಿತ ಕನ್ನಡಕ್ಕೆ ಮೊಟ್ಟ ಮೊದಲ ಜ್ಞಾನಪೀಠ ಪ್ರಶಸ್ತಿಯನ್ನು ತಂದುಕೊಟ್ಟಂತಹ ಡಾಕ್ಟರ್ ಕೆ ವಿ ಪುಟ್ಟಪ್ಪ ಅವರ ಒಂದು ನಾಡಗೀತೆಯೊಂದಿಗೆ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ನಾವು ಪ್ರಾರಂಭಿಸೋಣ. ದಯಮಾಡಿ ಎಲ್ಲರೂ ಈ ಒಂದು ನಾಡಗೀತೆಗೆ ಎದ್ದು ಗೌರವ ಸೂಚಿಸಬೇಕು. ಆಲ್ ಲೇಡೀಸ್ ಆ್ಯಂಡ್ ಜೆಂಟಲ್ಮೆನ್, ಪ್ಲೀಸ್ ರೈಸ್ ಫಾರ್ ದಿಸ್ ನಾಡಗೀತೆ. Thank you very much. Kindly be seated. This song is followed by ಅಕಾಡೆಮಿ ಗೀತೆ. ಈ ಒಂದು ಅಕಾಡೆಮಿಯ ಒಂದು ಗೀತೆ ದಯಮಾಡಿ ಪ್ಲೇ ಮಾಡಿ. ಧನ್ಯವಾದಗಳು. ಖ್ಯಾತ ಚಿತ್ರ ಸಾಹಿತಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ದೊಡ್ಡರಂಗೇಗೌಡರು ಬಹಳ ಸುಂದರವಾಗಿ ಈ ಒಂದು ಗೀತೆಯನ್ನು ರಚನೆ ಮಾಡಿದ್ದಾರೆ. ಹಾಗೆ ಖ್ಯಾತ ಗಾಯಕಿಯಾದಂತಹ ಡಿ ಪಲ್ಲವಿರವರು ಅದ್ಭುತವಾಗಿ ಈ ಒಂದು ಹಾಡನ್ನು ಹಾಡಿದ್ದಾರೆ. ಮತ್ತೊಮ್ಮೆ ಅವ್ರನ್ನ ಇಬ್ಬರನ್ನು ಸ್ಮರಿಸ್ಕೊಂಡು ದಯಮಾಡಿ ಜೋರಾದ ಕರತಾಳಗಳ ಮೂಲಕ ಅವರನ್ನು ಗೌರವಿಸಬೇಕು. ಈಗ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಆಗಮಿಸಿರುವಂತಹ ಎಲ್ಲ ಗಣ್ಯಮಾನ್ಯರನ್ನು ಹಾಗೂ ತಮ್ಮನ್ನು ಎಲ್ಲರನ್ನು ಕುರಿತು ಸ್ವಾಗತವನ್ನು ಕೋರಬೇಕು ಅಂತ ಹೇಳಿ ನಾನು ಡಾಕ್ಟರ್ ಆರ್ ಆನಂದ್, ಸೈಂಟಿಫಿಕ್ ಆಫೀಸರ್ KST ಅವರಿಗೆ ಈ ನುಡಿಪೀಠಕ್ಕೆ ಆಹ್ವಾನಿಸ್ತಾ ಇದ್ದೇನೆ. ಬಿಕಾಸ್ ವೆಲ್ಕಮ್ ಇಸ್ ಟು ಶೋ ಆನರ್ ಆ್ಯಂಡ್ ವೆಲ್ಕಮ್ ಇಸ್ ಟು ಶೋ ಇಂಟಿಗ್ರಿಟಿ. ಸೊ ಡಾಕ್ಟರ್ ಆನಂದ್ ಸರ್, ಪ್ಲೀಸ್.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. We are all here for inauguration of 3-day National Conference on Climate Resilience and Sustainable Development. We have with us Dr. Vinay Kumar Dadwal, Indira Gandhi Chair, Professor of Environmental Science, School of Natural Sciences and Engineering, NIAS, and former Director, IIST, ISRO. Dr. Vijay Kumar Dadwal has worked extensively in the field of remote sensing and contributed to the development of remote sensing applications in agriculture, including crop forecasting and irrigation management. Sir has received his bachelor's degree in Botany from Hansraj College, New Delhi, and Master's degree from Indian Agriculture Research Institute, New Delhi. He received his PhD in plant physiology from Indian Agriculture Research Institute. He joined ISRO's Space Applications Center, Ahmedabad, in the year 1983, where he served as head crop inventory and modeling division during 1998 and 2000, up to 2004. From 2004 to 2010, he served as dean at Indian Institute of Remote Sensing, Dehradun. In 2010, Dadwal sir has joined National Remote Sensing Center, Hyderabad, as the associate director and went on to become the director and served until 2016. Dr. Dadwal is science panel member of Terrestrial Carbon Observation of Food and Agriculture Organization, Rome. He is the recipient of several awards, including Indian National Remote Sensing Award in 1999, Dr. Vikram Sarabhai Award in 1999, ISRO Astronautical Society of India Award 2005, and ISRO Merit Award in 2006. With this brief background, I welcome Dr. Vinay Kumar Dadwal on behalf of KSTA and on behalf of all the delegates of this conference. We have with us former Director, Zoological Society of India, Government of India, and esteemed fellow of KSTA, Dr. Ramakrishna. Dr. Ramakrishna has done post-graduation from Mysore University and PhD from Pune University. He joined Zoological Survey of India as zoologist after teaching for 6 years at Bangalore University. He served as the Director of Zoological Survey of India. He has been awarded the degree of Doctor of Science from Mangalore University for his contribution to the writing a 3,000-page book on bioresources of Karnataka. He has guided 6 PhD students, author and co-authors for 53 books, 201 research publications, including 58 chapters, edited 98 publications, introduces 2 species to the science, 428 new animal species to the country, contributed significantly for the compilation of bioresources of Karnataka as a member of Karnataka Biodiversity Board. Presently, he is the member of Research Advisory Committee, Zoological Survey of India, board member and member of Governing Council of Wildlife Institute of India, chairman Madhya Pradesh Biodiversity Board, member ABS Committee of National Biodiversity Authority. Major recognitions include 6 species of insects have been named after Dr. Ramakrishna, received Janaki Ammal National Award for popularization of taxonomy in the country from President of India, Professor APJ Abdul Kalam, Gold Medal, Odum Memorial Award for Ecological Work, Fellow Zoological Society for contribution in marine science, Fellow Indian Association of Freshwater Biology for freshwater research, Honorary Scientist at University of Agriculture Sciences, Resource Person for conducting training for graduate, postgraduate and research scholars by National Academy of Sciences, Bangalore, Delhi and Ahmedabad. With this big background, I welcome Dr. Ramakrishna on behalf of KSTA and on behalf of all the participants. We have with us Dr. Ganesh Raj, former General Manager, Regional Remote Sensing Science Center, Bengaluru. I welcome you, sir. We also have Srimati Mummi Kund, Manager, National Bank of Agriculture and Rural Development, Bangalore. I welcome you, madam. On behalf of participants of this program and on my personal behalf, I welcome our beloved CEO, Dr. M. Ramesh, who is supporting, guiding and encouraging us in all the KSTA programs. We have many dignitaries among us gathering. We are thankful to Professor Katre Shakuntala Madam for her gracious presence in this program. We also have Professor K.S. Nataraj, former Honorable Member of KSTA and Director B.V. Jagdish Science Center. I welcome you, sir. We have Dr. Prabhakar Sangurmat, former Executive Director, Hatti Gold Mines Limited. We welcome you, sir. Likewise, we have Dr. Prabhuraj, Director, KSRHCC, Bangalore. I welcome you, sir. Dr. Uday Shankar Puranik, sir, I welcome you, sir. Dr. B.R. Guru Prasad, Director, Jawaharlal Nehru Planetarium, Bangalore, I welcome you, sir. Dr. P.P. Nageshwar Rao, former Director, RRSSC, I welcome you, sir. Dr. Swami, Dean, Horticulture College, Bangalore, I welcome you, sir. Shri Deepak, Manager, SBI, I welcome you, sir. ಇಂದಿನ ಈ ಉದ್ಘಾಟನಾ ಸಮಾರಂಭಕ್ಕೆ ಸನ್ಮಾನ್ಯ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಹಾಗೂ ಸಣ್ಣ ನೀರಾವರಿ ಸಚಿವರು ತುರ್ತಾದ ಸರ್ಕಾರಿ ಕೆಲಸ ಕಾರ್ಯಗಳಿರುವುದರಿಂದ ಭಾಗವಹಿಸಲು ಸಾಧ್ಯವಾಗಿರುವುದಿಲ್ಲ. ಅವರು ಈ ಸಮ್ಮೇಳನಕ್ಕೆ ಶುಭ ಹಾರೈಸಿದ್ದಾರೆ. ಅವರ ಪರವಾಗಿ ನಮ್ಮೊಂದಿಗೆ ಮಾನ್ಯ ಸಚಿವರ ಆಪ್ತ ಕಾರ್ಯದರ್ಶಿಗಳಾದ ವೀರಭದ್ರಪ್ಪ ಹಂಚಿನಾಳರವರು ಭಾಗವಹಿಸಿದ್ದಾರೆ. ಅವರಿಗೆ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಹಾಗೂ ಮಾನ್ಯ ಸಚಿವರ ವಿಶೇಷ ಸಮನ್ವಯಾಧಿಕಾರಿ ಹಾಗೂ ಸಾರ್ವಜನಿಕ ಸಂಪರ್ಕಾಧಿಕಾರಿಗಳಾದ ಶ್ರೀ ರುದ್ರೇಶ್ ರವರು ಭಾಗವಹಿಸಿದ್ದಾರೆ. ಅವರಿಗೆ ತಮ್ಮೆಲ್ಲ ಪರವಾಗಿ ಹಾಗೂ ವೈಯಕ್ತಿಕವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. I welcome all the dignitaries, professors and teachers who have participated in this program. I also welcome all my colleagues and all those who are directly or indirectly involved in this program. I extend a very welcome to print and visual media for this program. I welcome all the dignitaries, participants and those witnessing this program through social media platform for this inaugural function. Welcome one and all.
I also welcome Dr. R. Anand, Senior Scientific Officer, KSTA, on behalf of all the dignitaries and also the audience. ಈ ಪರಿಸರ ಸಂರಕ್ಷಣೆ ನಮ್ಮೆಲ್ಲರ ಹೊಣೆ ಅಂತ ಹೇಳಿ ಒಂದು ನಾಣ್ಣುಡಿ ಇದೆ. ಪರಿಸರ ಸಂರಕ್ಷಣೆ ಅನ್ನೋದು ಒಂದು ಮಾನವ ಮತ್ತು ಭೂಮಿಯ ನಡುವಿನ ಒಂದು ಸಾಮರಸ್ಯದ ಸ್ಥಿತಿ. ಅದು ಆ ಸ್ಥಿತಿ ಸರಿಯಾಗಿದ್ದಿದ್ರೆ ಪ್ರಾಯಶಃ ಇವತ್ತು ನಾವಿಲ್ಲಿ ಸ್ಥಿತಿಸ್ಥಾಪಕತ್ವ ಅನ್ನೋದು ಏನು ನಾವು ಇಲ್ಲಿ ಚರ್ಚೆ ಮಾಡ್ತಿದ್ದೀವಿ ಅದನ್ನು ಅದು ಮಾಡೋದಾಗ ಅವಶ್ಯಕತೆನೇ ಇರಲಿಲ್ಲ ಅಂತ ಅನಿಸುತ್ತೆ ನನಗೆ. ಬಟ್ ಎನಿವೆ, ಯಾಕೆಂದರೆ ಇನ್ನೊಬ್ಬರು ಒಂದು ಮಾತು ಹೇಳ್ತಾರೆ, ಮಾನವನು ನೀಡುವ ದಿನನಿತ್ಯ ನೀಡುವ ಒಂದೊಂದು ಹೊಡೆತವು ಪರಿಸರಕ್ಕೆ ಅದು ಆ ಪ್ರಕೃತಿಯನ್ನು ಸಹಿಸಿಕೊಳ್ತಾ ಬಂದಿದೆ. ಆದರೆ ಆ ಒಂದು ಸಹಿಷ್ಣುತೆ ಈಗ ಆ ಸಹಿಷ್ಣುತೆಯ ಮಿತಿ ಏನಿದೆ ಈಗ ಅದು ಮುಗಿತಾ ಬಂದಿದೆ. ಸೊ ಹಾಗಾಗಿ ಇಂಥ ಒಂದು ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ನಾವು ನ್ಯಾಷನಲ್ ಕಾನ್ಫರೆನ್ಸ್ಗಳನ್ನೆಲ್ಲ ನಾವು ಮಾಡಬೇಕಾಗಿದೆ. ಈ ಮಾತನ್ನು ಡಾಕ್ಟರ್ ಎಮ್ ಮೊಸೋಸ್ಕೋ ಅನ್ನುವ ಒಬ್ಬ ವ್ಯಕ್ತಿ ಹೇಳಿರೋದು. ಸೊ ಈ ನಿಟ್ಟಿನಲ್ಲಿ ನಾವು ಐ ವಿಲ್ ರಿಕ್ವೆಸ್ಟ್ ಡಾಕ್ಟರ್ ಎ ಎಮ್ ರಮೇಶ್, ಚೀಫ್ ಎಕ್ಸಿಕ್ಯೂಟಿವ್ ಆಫೀಸರ್, ಕರ್ನಾಟಕ ಸೈನ್ಸ್ ಆ್ಯಂಡ್ ಟೆಕ್ನಾಲಜಿ ಅಕಾಡೆಮಿ, ಫಾರ್ ದಿ ಓಪನಿಂಗ್ ರಿಮಾರ್ಕ್ಸ್. ಸರ್.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಮೊದಲನೇದಾಗಿ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ಪರವಾಗಿ ತಮಗೆಲ್ಲರಿಗೂ ಈ ಒಂದು ಸಮಾರಂಭಕ್ಕೆ ಹಾರ್ದಿಕ ಸ್ವಾಗತ. Respected dignitaries on the dais, half the dais, delegates from different universities and colleges across Karnataka. We have with us very distinguished space scientist. Sir has occupied most of the positions in ISRO. When I requested him, he immediately agreed. Sir, on behalf of KSTA, once again welcome to you, Dr. Vinay Kumar Dadwal, sir. We have with us Dr. Ramkrishna, eminent zoologist, Dr. K. Ganesh Raj, eminent space scientist, Miss Mammi Kaund, she is the manager, NABARD, Shri Veerabhadrappa Hanchinal, PS to our Honorable Minister, Mr. Rudresh, Special Officer to our Honorable Minister, Dr. Prabharaj sir, Dr. Katre Shakuntala madam, Dr. K.S. Nataraj sir, Dr. Swami sir. In fact, we are grateful to Horticulture College for giving us entrance space. We welcome you, sir, to this function. Our new director of JNP, I take this opportunity to congratulate you, sir. Recently, sir has taken over as the director of JNP. Our advisory board members, Dr. Shripad, Dr. Karthik, Dr. Sangur Mat, Shri Prakash, and our generous manager from SBI, who has sponsored bags to this conference, has also come. Welcome to you, Deepak sir. Our eminent space scientist, and in fact, our guru also, Dr. PPN is here. Welcome to you, sir. Dr. Gangadhar is with us, and all the eminent personalities who are present here and delegates. At the outset, once again, welcome to you all. In fact, Karnataka Science and Technology Academy was started in the year 2005. It was started because eminent writer S.L. Sheshagiri Rao, professor, had mentioned in one of the Kannada conferences that Karnataka should have an academy for science and technology to popularize science in Kannada. That's why KSTA was started in 2005 to popularize science and technology across the state. Academy has organized many programs, right from high school to the university level. We have organized a host of programs for the benefit of school children. Now we are developing DVDs and distributing to schools across Karnataka, especially in the backward regions. So far we have developed some 30 talks and distributed to 400 schools across the state. And the second program is for PU students. In fact, there is less interest to pursue science as a career. So KSTA, in association with our own sister organization K-Steps, we have been organizing regular online talks. We have organized more than 350 talks so far in the last 3 years to reach out to the students. And we used to give, distribute notes also from experts who gave talk. Now this year, we have taken a new step of developing question banks for the benefit of government college college PU students, because as you can see, CET, they score very well in PU but fail in CET. So in order to bridge the gap, we are developing question banks in physics, chemistry, biology, and mathematics. Most probably we'll be distributing the books by December 15th. Apart from this, KST organizes many special talks for UG and PG students and many competitions, including quiz, essay, debate, elocution, science drama at the district level, then regional level, and at the state level. For the last 2 years, we have not been able to organize as much as we wish to because of disruption caused by COVID. And next year, we would like to step up this program because there has been overwhelming response from students across the state for these programs. And conferences, it is not new to KSTA. Since 2007 till date, we have organized more than 32 conferences across the state. Only 8 of them in Bangalore, 6 in Gulbarga, 2 in Raichur, 2 in Vijaypur, 2 in Bagalkot, 2 in Koppal. Like that, we have organized many programs across the state. And more than 300 training programs we have organized, and 300 online. Even in COVID time, KSTA did not keep quiet. Even during lockout, we were organizing online programs regularly. And KSTA has been publishing Vijnanaloka bi-monthly magazine very regularly since 2007, and 2,000 copies are being printed and distributed, mostly free of cost. Now we have put some minimum subscription fee. And we had a program called Kutuhali, in association with Vigyan Prasar for the last 3 years, and we were publishing Kutuhali magazine every month. That was also a online magazine, and many science communication programs we have organized with the help of Department of Science and Technology, Government of India, for students and public. In fact, one of the very good example is student, public and scientist interaction program. One Saturday in a month, an eminent scientist would come to Mysore and deliver a talk, and right from 5 years to 70 years, all public would join, and even small child would also ask question, including Dr. K. Vijayaraghavan, who was the scientific advisor to the Government of India. He also had given the talk. So we would like to extend this program to other places as well. And KSTA would like to many programs across to benefit students and teaching faculty. We organize regularly workshops and conferences like this. And 2 future programs that we envisage with the help of the government is setting up of a virtual lab in our own premises for the benefit of students. They could access the lab facility virtually from anywhere in the state. We have a proposal for that. And also a OTT science channel. Government of India has started. Vigyan Prasad was looking after. In fact, Vigyan Prasad is being closed. So there is no OTT channel as such. In Karnataka, we would like to start a OTT channel. And as Walt Disney had said, if you can dream it, you can do it. Certainly we have dreamt, and possibly we will realize these 2 dreams. And as Paulo Coelho has said, when you want something good to happen, all the universe conspires to help. Let all those who are connected with science and technology help these 2 dream projects come true, so that students across the state will be benefited. Our Anchana Sahab is there, and Rudresh is also there. I request their help in this regard. In pursuit of our dream, we are already working. And this conference titled Climate Resilience and Sustainable Development is being organized in association with Ministry of Earth Sciences, NABARD, State Remote Sensing Center, SBI, and Prakash Industries Limited. And as we know, this conference underscores the urgency and gravity of the challenges posed by climate change and the imperative for sustainable development. Climate change, as we know, it transcends border and affects entire globe. Because of climate change, we see a lot of disruption in livelihood, threat to food security and nutritional security, deteriorating human and animal health, loss of biodiversity and ecosystem services, jeopardizing social well-being of billions of people across the globe, and carbon dioxide concentration, pre-industrial phase, it was only 280 ppm. Now, till November 20th, 2023, it had gone up to 421.01 ppm. In fact, manifold increase. The annual increase of this carbon dioxide has been very steady, and because of that, we have seen a lot of disruption in our own activities, disasters, and in fact, Conference of Parties 28 will be held shortly in Dubai from November 30th to 12th December, and to take review of carbon dioxide situation in the globe. And among 17 sustainable development goals that was started in 2015, which will go up to 2030, in only about 12% it seems are currently on track, and others are not. So with this background, this conference on climate resilience and sustainable development was planned, and we have 10 expert talks by eminent scientists, right from climate smart agriculture to carbon capture and utilization, use of cutting edge technologies like remote sensing, drone technology, etc. For 3 days, certainly you will have a good take-home message from this conference. We also have had the opportunity for youngsters to present papers, and we have prizes for the best papers as well. And some have exhibited the scientific models that they have developed. In fact, not only academics, education, research, we too have entertainment at the end of the day. Today we'll be having cultural program. A renowned singer, Mr. Ashok, will be here to enthrall all of us. All of you kindly join. With this, I wish you would have a very fruitful 3 days in KSTA. I'm sure all of you will enjoy KSTA hospitality. Those who can stay here will also get dinner also. So those who are coming from distant places can stay in KSTA guest house. I take this opportunity also to welcome my friend Dr. Puranik. Welcome to you, Dr. Sir. So with this, thank you very much.
ಧನ್ಯವಾದಗಳು ರಮೇಶ್ ಸರ್, ನಿಮ್ಮ ಒಂದು ಪ್ರಾಸ್ತಾವಿಕ ನುಡಿಗಳಿಗೆ. ನೋಡಿದ್ರಲ್ಲ ಸ್ನೇಹಿತರೆ, ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ನಾನು ನೋಡಿರೋ ಹಾಗೆ ಪ್ರತಿದಿನ ಏನಾದರೂ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಇದ್ದೇ ಇರುತ್ತೆ. ಇಫ್ ಯು ಗೋ ಟು ಫೇಸ್ಬುಕ್ ಆರ್ ವಿಚ್ ಎವರ್ ಮೀಡಿಯಾ, ಸೋಷಿಯಲ್ ಮೀಡಿಯಾ ಇಟ್ ಈಸ್, ಏನಾದರೂ ಒಂದು ಕಾರ್ಯಕ್ರಮ ವಿಜ್ಞಾನದ ಬಗ್ಗೆ ಅಥವಾ ಪರಿಸರದ ಬಗ್ಗೆ ಅಥವಾ ಕೃಷಿಯ ಬಗ್ಗೆ, ಈ ಪ್ರಾಣಿ ಪಕ್ಷಿ ಸಂಕುಲದ ಬಗ್ಗೆ ಆಗಿರ್ಬೋದು, ಏನಾದರೂ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಯಾವಾಗಲೂ ಇದ್ದೇ ಇರುತ್ತೆ. ಅಂತಹ ಒಂದು ಸಾಧನೆಯನ್ನು ಗೈದಿರುವ ಈ ಒಂದು ಕರ್ನಾಟಕ ಸೈನ್ಸ್ ಆ್ಯಂಡ್ ಟೆಕ್ನಾಲಜಿ ಅಕಾಡೆಮಿಗೆ ಮತ್ತೊಮ್ಮೆ ಧನ್ಯವಾದಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ, ಸಾಧನೆ ಇಲ್ಲದೆ ಸತ್ತರೆ ಸಾವಿಗೆ ಅವಮಾನ, ಸಾಧನೆ ಇಲ್ಲದೆ ಸತ್ತರೆ ಸಾವಿಗೆ ಅವಮಾನ, ಆದರೆ ಆದರ್ಶ ಇಲ್ಲದೆ ಬದುಕಿದರೆ ಬದುಕಿಗೂ ಅವಮಾನ. ಇಲ್ಲಿ ನಮ್ಮೊಡನೆ ಭಾಳಷ್ಟು ಮಂದಿ ಸಾಧನೆ ಮಾಡಿರೋರಿದ್ದಾರೆ, ನಿಮ್ಮಲ್ಲೂ ಇದ್ದೀರಾ. ಸೊ ಹಾಗೆ ಅವರು ನಮ್ಮೆಲ್ಲರಿಗೂ ಸ್ಫೂರ್ತಿಯಾಗಿದ್ದಾರೆ. ನಾವು ಕೈಲಾದಷ್ಟು ಏನಾದರೂ ಸಾಧನೆ ಮಾಡುವ ಅಂತ ಹೇಳ್ಕೊಳ್ತಾ, ಈಗ ಈ ಒಂದು ಸಮ್ಮೇಳನದ, ರಾಷ್ಟ್ರೀಯ ಸಮ್ಮೇಳನದ ಉದ್ಘಾಟನೆ ಡಾಕ್ಟರ್ ವಿನಯ್ ಕುಮಾರ್ ದದ್ವಾಲ್ ಅವರ ಒಂದು ನೇತೃತ್ವದಲ್ಲಿ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟನೆಯನ್ನು ನೆರವೇರಿಸಿಕೊಳ್ಳುವಂತ ನಾನು ಕೇಳ್ಕೊಳ್ತೇನೆ. ಡಾಕ್ಟರ್ ವಿನಯ್ ಕುಮಾರ್ ದದ್ವಾಲ್ ಸರ್, ಐ ವುಡ್ ರಿಕ್ವೆಸ್ಟ್ ಆಲ್ ದಿ ಡಿಗ್ನಿಟರೀಸ್ ಪ್ಲೀಸ್ ಜಾಯಿನ್ ಟು ಡಾಕ್ಟರ್ ವಿನಯ್ ಕುಮಾರ್ ದದ್ವಾಲ್. ಗಿಡಕ್ಕೆ ನೀರೆರೆಯುವ ಮೂಲಕ ಬಹಳ ಒಂದು ಸುಂದರವಾದ ನಮ್ಮ ಒಂದು ಪ್ರಕೃತಿ ಸಂಸ್ಕೃತಿ ಇದು. ಪ್ಲೀಸ್. Very meaningful inauguration for the climate resilience and sustainable development. Thank you one and all, sir. So with this, we have a abstract of Compendium 2023 of this climate resilience and sustainable development, a book release, that is the compendium. I would request all the dignitaries please to release this, unveil this compendium, please. Thank you, all the dignitaries. Now I would request Srimati Mummi Khaunt, Manager, National Bank for Agriculture and Rural Development, to the dais to share your few words, madam, please.
Respected dignitaries on the dais, respected delegates from various institutions, and my dear participants of this conference. I'm happy to be present here today in this National Conference on Climate Resilience and Sustainable Development. I have also done my post-graduation from environmental science and also started studying PhD also in environmental science. So this is very much relevant to me and I really like this subject. As we already know, climate change is inevitable and that's happening each and every part of this country, not only this country, all over the world. So we just have to look back to our native places, weather of these native places when we were a child or during our childhood and the weather of our native places at present. We can see the difference, it's happening everywhere. But to what extent it's happening? That is the most important things to discuss. In our sixth assessment report, IPCC has reported that and they have placed a red flag on the global climate change. They have projected that 1.5 degrees centigrade increase in global temperature is inevitable and this is going to happen at the best case scenario. So this is the need of the hour to discuss and act upon these topics. And this increase in temperature will also bring various natural calamities like flood, severe drought, heavy rainfall, precipitations, cyclones, etc. to all of us. We are going to affect with this severe natural calamities in near futures, and this is happening also. So climate finance is a very important part. It is a critical thing to discuss. To reduce or to invest in the various technologies or renewable resources in the sectors which is heavily contributing towards the emissions of the greenhouse gases. And as a developmental bank of the nations, NABARD is supporting various government institutions, state governments or executing entities to provide financial status from the different global, international and national funds. And we have supported these state government agencies to formulate projects, to conceptualize projects, to implement the projects, to disburse the funds, to monitor and evaluate these projects. So far, around 40 projects has been supported by NABARD with various, with total grant support of around 1,800 crores. From the various international funds like Green Climate Fund, Adaptation Fund, and our own national funds, that is National Fund for National Fund for Adaptation and Climate Change, which is a Government of India's funds, throughout across this country. So not only this outside funds, NABARD has also established its own fund, that is Climate Change Fund, with an initial corpus of 5 crores, and now it has been enhanced to 20 crores, and we are supporting various adaptation projects, mitigation projects, awareness creation projects, and then knowledge sharing platform like this with our own funds. As a development institution, as a financial institution, as an educational institution, it is our utmost duty and importance to not only to talk about the climate change, but also to act on it at the right moment, which is now. We have to act on this. And India is already committed to achieve the net zero by 2070. And I'm very much thankful to Karnataka Science and Technology Institution to make us a part of this conference on climate resilience and sustainable development to achieve a sustainable futures for our next generation as well as for us. So I am thankful to you, sir, to make us a part of this conference, and I wish a very impactful outcome from this program. Thank you all.
Earth provides enough to satisfy every man's need, but not every man's greed. This is a quote said by M.K. Gandhi, Mohandas Karamchand Gandhi. Very nice talk, the presentation from the NABARD. I'm very happy, actually, your contribution towards this climate resilience and then sustainable development. Thank you once again. Now I request Dr. Ganesh Raj, former General Manager, RRSC, ISRO, Bengaluru, sir.
Good morning, all participants. Respected Dadwalji, Dr. Ramakrishna, and Mummy Count, Ramesh, Dr. Nageshwar Rao, Guru Prasad, and many other eminent dignitaries, fellows of the Academy, Dr. Prabhuraj, students and participants. Really, it is a very nice opportunity and to share my few thoughts. Of course, Dadwalji will give a very detailed talk. So what happens is, Earth is the only living planet. As far as our knowledge goes now, we don't have any other living planet. With the large portion is only water. Land is so less. And where people live is still less. Still, man is impacting the climate change. Climate change is happening. It will happen. It is going to happen. It may be natural. It may be man-made. But our focus right now mainly on man-made. How much carbon or carbon dioxide is coming. A lot of studies are done. But I sometimes get doubt, are we really assessing properly? Changes were happening earlier also. Paleoclimatic changes, if we take, Earth age 4.5 billion years, things have changed dramatically. Glaciations were there 1 million years back, entire Earth was covered with ice. It is natural. We had Carboniferous area, glaciation was there. We have continental drift, plate tectonics. It goes in a different dimension. But what I find, the last maybe 100 years, due to industrial revolution and our lifestyle change, and more so last 3 decades, we contribute significantly in accelerating change, which is directly affecting us. Extreme weather events, increase in temperature, sometimes decrease in temperature also, and a lot of deaths. Best example now, air quality of Delhi or North India. We talk only Delhi, it is entire North India. By man's efforts, increase in air quality. And today I was reading newspaper, even in Bangalore, after Ganesha festival, 30 lakes were studied by Pollution Control Board. All parameters double, triple, TDS, heavy metals, everything. Recent study by MP shown that vegetables sold in Bangalore as heavy metals. Certainly it is not natural. It is man-made. So how we can control it? How we can manage it? I don't know, resilience is there or not, I don't know. But how at least we can cope up with that. That is what we really should think. Only way I feel is change in lifestyle. If you change your lifestyle, you can contribute better to manage it. It is not only you do whatever you do, then you tell it is affecting us. Carbon credit, we speak a lot of things, but we do a lot of less things to manage it. In this direction, the KST effort, at least to create awareness in the young minds regarding how we can manage, how we can control, or at least some extent create awareness, what are the dangerous impacts of this climate change, is a very worth praising one. And a lot of areas are there. In all area, agriculture, water resources, all areas, it affects and how we can manage. I compliment Dr. Ramesh and his team for organizing this team. They need a big hand, please, for organizing this event. I really, one of the best effort by the KST, because as told by him, they're doing a lot of good work to create awareness about science and technology in the state. Really, they have a long way to go because Karnataka has a large number of schools. What we reached is very less actually. We have thousands of schools and thousands of this one. It needs to be propagated. Once society or students are aware, I'm confident they'll contribute better for managing it a sustainable climate or a livelihood itself. Thank you. Thank you for giving this opportunity.
Thank you very much, Dr. Ganesh Raj sir, for your valuable words. We should all inculcate, so whatever this sir actually has said now. Now, may I call upon Dr. Ramakrishna sir, former Director, Zoological Survey of India, Government of India, and member, RAMC and ZSI, Bengaluru, sir, please.
ಶ್ರೀ ಗುರುಭ್ಯೋ ನಮಃ ಹರಿ ಓಂ. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. Good morning to all of you. It's indeed a pleasure to be with you all on an occasion like this, and a symposium especially pertinent to the present day situation, namely the climate resilience and sustainable development. Honorable Chairman sir, on the dais, respected members on the dais, respected dignitaries, invited dignitaries, my dear young members. Well, I thought I should speak on the theme of the subject, namely the climate resilience and the sustainable development. This is particularly very important because this is a year of an international day for eradication of poverty. The most important thing that we need to look into is the eradication of the poverty in the entire scenario of the world. So I thought it is pertinent for me to speak on how climate change can eradicate the poverty in the years to come. Sir, let us look at the scenario of the world. According to UNICEF, 1 billion children are extremely high risk of severe and destructive climate hazards. This is the scenario that what we have got today. In addition to that one, we have Intergovernmental Panel of Climate Change, IPCC, which normally reports, and last year when the Honorable Prime Minister visited and has given us a guideline for us how to change the climate change. So the most important is on the impact, the adaptability, and the vulnerability. These are the three important factors that we need to look into when we speak about the climate change. The report, what has come out in the IPCC 2022 on the climate change, on the vulnerabilities, including the capacities and limits of the natural world and the human societies to adapt to the climate change. So we need to adapt to the climate change. The IPCC also reports the global warming. One of the most important is the global warming, which combined with the habitat destruction, we have got habitat destruction. One of the major crises that we are facing today is the habitat destruction. And the growing urbanization, this is one of the other important aspects that we are looking at it, has already caused a widespread disruption to the nature. And about half of the world's marine species are migrating poleward. This is the migration that we are seeing. Many of the species are going upwards to the Himalayan regions. Many of the species are migrating towards the polar region because there is a change in the climate, or the climate change, or the warm scenario that we are coming across. So we have already noticed the shifts in the timings of the annual spring bloom that we have noticed. So as a result of the change in the bloom, so butterflies are facing difficulty. Birds are facing difficulty in coping up with this change in the scenario. So that is, in addition to that one, if you look at the marine scenario, there are a lot of phytoplankton, the small organisms that are present in the marine ocean. So they have changed in the marine ocean phytoplankton, as a result of which fishes are moving away from it, and our fishermen are facing very difficulty in getting a huge haul of fishes in their net. So these are some of the important points that we are looking at it. So ocean is warming, ocean is acidification, have adversely affected the food production from the fisheries, and some of the oceanic regions, and forecast levels of the climate change plus the habitat destruction will lead to the loss of much of the world's coral reefs. We have got one of the best coral reefs in India at Andaman and Nicobar, the Lakshadweep. So we are facing the bleaching. The bleaching is mainly because of the carbon dioxide. The carbon dioxide mingles with the water, it becomes a carbonic acid. When once it becomes a carbonic acid, H and HCO3 is separated, and that makes the entire scenario of the coral reef into a white structure. That is what we call the coral bleaching. So this is one of the things that we are looking at it in the form of the climate change, the impact of climate change. So there is a rapidly closing window of the opportunity, both to reduce the greenhouse, this is one of the important aspects that we are looking at it, to reduce the greenhouse effect emissions and develop climate resilient adaptation measures by conserving, protecting, and restoring. These are the three important: the conservation, the protection, and the restoration of both marine and the terrestrial ecosystems. So we have got the global climate index has been given. The global climate index has been given, and according to that one global climate index, risk index, that it was 7th, the India stands 7th in the seniority. Is due to the climate change. As per the state of India's environment figures of 22, India was reported as the 280 heat waves we have faced in the last 2019 and 22. And this is the reason why we need to look into about the climate change. So there are some important or interesting facts about that one. The last decade was the hottest in 1,25,000 years. The last decade was 1,25,000. The ocean absorbs a lot of carbon dioxide and heat that is produced by the entire scenario of the world. The carbon dioxide has increased in last 200 million years. This is the highest that what we can see in 200 million years. The carbon dioxide has increased to such an extent. We are about losing 1.2 trillion tons of ice in our polar region. This is what has happened in the scenario of the climate change. And the global warming is affecting our biodiversity. And we have lost as much as 302.4 billion work hours in 2019 because of the climate change. This is what is happening, and that is the reason why we need to have what we call it as the symposium awareness programs to understand the climate change and the resilience that we have developed over the years. So we have developed what we call the sustainable development policy. I will not go into the detail because it takes a lot of time for me. I will have a lecture in the afternoon for me to have an impact of climate change on the marine ecosystem. I will just cut short my what is known as this. Within 10 minutes, I will complete my program. So we have got sustainable development policies. Way back in 2010, when you look at it, there is a Millennium Development Project, 2000. We were supposed to achieve by 2015, reducing all the climate scenario, but we could not able to do it. In 2015, then there was a development, what is known as the Sustainable Development Policies have been developed. And these Sustainable Development Policies have got 17 parameters. 17 important things. The first one is the elimination of poverty. The most important thing that we look at it is the elimination of poverty. Erase hunger. These are the 17 sustainable developmental goals that has been United Nations has achieved as well as has given us the guidelines, and provide quality education. And improve clean water and sanitation. Grow affordable clean energy. Create decent work and economic growth. Increase industry, innovation, infrastructure, reduce inequality, mobilize sustainable cities and communities, influence responsibilities and consumption production, organize climate action, develop the life below water, advance life on land, guarantee peace, justice, and strong institutions, and build partnership goals. These are the sustainable developmental goals that has been given by none other than United Nations, 17. And climate change is one among them, is the sustainable development goal. So what we have got is the government has to protect the health and safety. The government has to prepare the children and young people to live in a climate changed world. The government, business, and decisions makers to prioritize the children and young people in the climate funding and resources. The government, business, and decision makers are to prevent the worst scenario of the climate crisis by supercharging the efforts close to the emissions gap and accelerate the transition from the fossil fuel to the renewable energy. These are some of these one. In 2020 is supposed to be the year by which developed countries, and that's what you call the parties, who are to fulfill the goal jointly mobilizing about $100 billion for a climate finance. This we could not able to achieve, and so that's why the NABARD and other things have come into force for giving lot of funding to the international climate change scenario. So, United Nations education programs, environmental programs, there is a emission report is also released only yesterday, and there it shows the world is off the track to reduce emissions in the line with the Paris Agreement. We have in 2005 Paris Agreement or Kyoto Protocol, and wherein we need to keep our climate with below 2005, that is level 1.5 degrees centigrade. So we are not unable to do that one, and we need to look into that one about the Paris Protocol or what you call the Kyoto Protocol. So there is a climate emergency, and this direct consequence of the carbon, heavy land use, and agriculture, transport, buildings, industrial process, polluting energy sources. So with these profound changes, these sectors have a drastic cut in the carbon footprints and that little hope of protecting the planet from devastating effects. So what is the climate change index in India in 2023? If you look at it, in 2023, India ranks 8th position. India ranks 8th position compared to the 2022, which has ranked the 10th position. So we have improved in our carbon footprint also in the years, 1 year itself. So the government of India is doing a lot of things on the climate change. I will just go through that one. Government of India, the action plan on climate change, that is on 13 June 2008 itself it has forum. One is the National Solar Mission, the National Mission for Enhanced Energy Efficiency, National Mission for Sustainable Habitat, National Water Mission, National Mission for Sustaining Himalayan Ecosystem, National Mission for Green India, National Mission for Sustainable Agriculture, National Mission for Strategic Knowledge and for Climate Change. These are some of the things that have been introduced recently by the Government of India, and two important ones are National Mission for Sustainable Himalayan Ecosystem, because one of the important things that is Himalayan is the youngest chain of mountain, which is about 10 million years ago it has formed. So it is not completely sustainable. So we are facing a lot of problem in the Himalayan ecosystem. So that is one of the important aspects that we are looking at it in the Himalayan ecosystem. And second one is strategic knowledge of the climate change. These are some of the important, and in which the formation of knowledge network among the existing knowledge of institutions engaged in research and development related to climate change and facilitate data sharing and exchange through suitable policy framework and institutional support. So this is how the entire thing has come into this one. So in this National Mission for Strategic Knowledge and Climate Change, which are having, so they have developed what we call as centers of excellence. If, for example, Indian Institute of Science, there are centers of excellence in which they work upon the climate change. State climate change centers, national network programs, major R&D programs, human capacity building. These are some of the initiatives that has been taken by the Government of India regarding the climate change. Then human capacity building, global technology watch groups, vulnerability assessments, international collaboration. This is yet another important international collaboration. These are some of the important things that we are looking at it. So with these few words, I take it, convey my sincere thanks to Dr. Ramesh and all the people from Karnataka State Science and Technology Academy for giving me an opportunity to speak on an occasion like this one, because the climate change is something not new. If you look at the history of the entire world scenario, 4.6 billion years is the history of the entire world when it was in a molten state. From the molten state, it has solidified. So there was a climate change at one time. If you look at from 3.5 million years to the present day, there are extinctions, the loss of life, the loss of animals, loss of plants. There are 5 extinctions. So 5 extinctions have taken place. For example, all of us know about the loss of what we call it as the dinosaurs. The loss of dinosaurs is one of this one. This has been believed to be mainly because of the climate change. So what we are now is in the 6th extinction. So there is rate of extinction is highest during the 6th extinction, and we need to look into what we call the climate resilience and sustainable development. So with these few words, I convey my sincere thanks to all the organizers, and thank you all. Thank you.
ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಡಾಕ್ಟರ್ ರಾಮಕೃಷ್ಣ ಸರ್. ನೋಡಿದ್ರಲ್ಲ ಸ್ನೇಹಿತರೆ, ಎಸ್ಪೆಷಲಿ there is a lot of responsibilities on the shoulders of young generations to save our nature, to save our livelihoods. ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂತಂದರೆ, ನಮಗೆ ಯಾವ ಕೆಲಸ ನಾವು ಆಸಕ್ತಿ ತೋರಿಸ್ತೀವಿ ಅಂದರೆ, ನಾವೇನಾದ್ರು ಕೆಲಸ ಮಾಡಿದ್ರೆ ನಮಗೆ ದುಡ್ಡು ಬರಬೇಕು ಅಥವಾ ಇನ್ನೊಂದು ಏನಾದ್ರು ಸಿಗಬೇಕು ಅನ್ನೋದು ಕೆಲಸ ಅಥವಾ ಯಾವುದೇ ಒಂದು ಫಲಾಪೇಕ್ಷೆಯನ್ನು ಬಯಸಬಾರ್ದು ನಾವು. ಐ ಥಿಂಕ್ ಐ ಶುಡ್ ಸೇ ಹಿಯರ್, ಭಗವದ್ಗೀತೆಯ ಒಂದು 2ನೇ ಅಧ್ಯಾಯದ ಒಂದು 47ನೇ ಒಂದು ಶ್ಲೋಕ ಇದೆಯಲ್ಲ, ಕರ್ಮಣ್ಯೇವಾಧಿಕಾರಸ್ಥೆ ಮಾ ಫಲೇಶು ಕದಾಚನ ಮಾ ಕರ್ಮಫಲ ಹೇತುರ್ಭೂಮಾತೆ ಸಂಗೋಸ್ತ್ವ ಕರ್ಮಣಿ ಅಂತ. ಸೊ ಅಲ್ಲಿ ಏನು ಹೇಳ್ತೆ ಅಂತಂದರೆ ಭಗವದ್ಗೀತೆ, ನೀನು ಯಾವುದೇ ಫಲವನ್ನು ಅಪೇಕ್ಷಿಸದೆ ನಿತ್ಯ ನಿನ್ನ ಕಾಯಕದಲ್ಲಿ ತೊಡಗಿಕೊ ಅಂತ ಹೇಳುತ್ತೆ. ಸೊ ಅದೇ ರೀತಿ ಡಾಕ್ಟರ್ ಅಬ್ದುಲ್ ಕಲಾಂ ಅವರ ಒಂದು ನುಡಿ ನೆನಪುತ್ತೆ ನನಗಿಲ್ಲಿ, ನೀನು ನಿನ್ನ ಭವಿಷ್ಯವನ್ನು ರೂಪಿಸಿಕೊಳ್ಳಬೇಡ, ನಿತ್ಯ ನಿನ್ನ ಕಾಯಕದಲ್ಲಿ ತೊಡಗಿಕೋ, ಅದು ನಿನ್ನ ಭವಿಷ್ಯವನ್ನು ರೂಪಿಸುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ ಅವರು. ಸೊ ಹಾಗೆ ನಾವು ನಮ್ಮ ಒಂದು ಕೆಲಸ ಕಾರ್ಯಗಳನ್ನು ನಾವು ಮಾಡ್ಕೋಬೇಕು. ಬಹಳ ಅದ್ಭುತವಾದಂತಹ ಒಂದು ಟೆಕ್ನಿಕಲ್ ಸೆಷನ್ನೇ ಒಂದು ಶಾರ್ಟ್ ಟೈಮಲ್ಲಿ ಒಂದು ಅಷ್ಟು ಅದ್ಭುತವಾದಂತಹ ಒಂದು ಮಾಹಿತಿ ನೀಡಿದ್ದಾರೆ. ಥ್ಯಾಂಕ್ ಯು ಒನ್ಸ್ ಅಗೇನ್ ಡಾಕ್ಟರ್ ರಾಮಕೃಷ್ಣ ಸರ್. ಈಗ ಕಾರ್ಯಕ್ರಮದ ಕೊನೆಯ ಹಂತಕ್ಕೆ ಬರ್ತಾ ಇದ್ದೀವಿ. ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟನೆ ಮಾಡಿ ಮತ್ತು ಒಂದು ಅಧ್ಯಕ್ಷೀಯ ನುಡಿಗಳನ್ನು ಸಹ ಅದನ್ನು ಎರಡನ್ನೂ ಒಗ್ಗೂಡಿಸಿ ಡಾಕ್ಟರ್ ವಿನಯ್ ಕುಮಾರ್ ದದ್ವಾಲ್, ಇಂದಿರಾ ಗಾಂಧಿ ಚೀಫ್ ಪ್ರೊಫೆಸರ್ ಆ್ಯಂಡ್ ಎನ್ವೈರ್ಮೆಂಟಲ್ ಸೈನ್ಸ್, ಸ್ಕೂಲ್ ಆಫ್ ನ್ಯಾಚುರಲ್ ಸೈನ್ಸಸ್ ಆ್ಯಂಡ್ ಇಂಜಿನಿಯರಿಂಗ್, NIAS ಆ್ಯಂಡ್ ಫಾರ್ಮರ್ ಡೈರೆಕ್ಟರ್ IST ISRO. Now I call to the dais, sir, to share your opening, the inaugural and also the presidential remarks, sir, please.
Thank you. Good morning, all the distinguished participants. Good morning, Dr. Ramesh, the CEO, Professor Ramakrishna, Dr. Ganesh Raj, Srimati Mumi Khond, and of course I see my ISRO and remote sensing community people, Dr. Nageshwar Rao Guru Prasad, also here, and Prabhu Raj. Let me begin by saying that I deem it an honor and distinct privilege to stand before you for the inauguration of this very important and aptly titled National Conference, Climate Resilience and Sustainable Development. So my all experience and contribution in this area is very, very limited to the use of space-based observations. I'll come to that slightly later. Let me also, I had the chance to look into a document which we released, the proceedings. It has 10 expert talks and more than 55 research contributions by the youngsters who are sitting here. So I will like to bring to your attention some cross-cutting and common issues while you are touching on some specific areas. One is like development we understand and climate we understand, right? Metaphorically, climate is just average of weather over 30 years as per that. So now why the climate should have so many prefix and suffix? Change, resilience, that is very important. As Professor Ramakrishna pointed out, climate has been changing and will continue to change. So what has changed in this change is the natural evolution, and the Earth's balance is altered by human activities. And we have accelerated this change. That is what the IPC says. There is now unambiguous evidence. So much so that whatever you have read your geological era, now many scientists say the current era should be called Anthropocene. Anthropocene means it is all controlled by human activities. Why human activities should be able to control such a large, earth which is so complicated? Generally, the balance between the physical system, chemical system and biological system is maintained, but then we have done couple of things. One is the carbon dioxide, what has been talked of, right? The carbon cycle is truly composed of two cycles. A geologic cycle which runs into millions of years, and a very fast cycle which has the half-life of between 7 to 12 years, which is the biosphere to atmosphere and the absorption. In fact, we forget many times that it is the disruption of the geological carbon cycle which is the mining of the fossil fuel and its release at a very rapid rate, which currently is of the order of 7 petagram. Peta is 10 raised to power 15 gram carbon, which actually creates the largest thing. And it was Arrhenius in 1905 who showed if the CO2 were to increase in the atmosphere, the outgoing infrared waves will be absorbed, and it will lead to heating of the lower atmosphere, cooling of the upper atmosphere, and warming of the earth. So after living through all this exercise, 3 more things have happened. One is the deforestation and land use change, which basically not only releases some amount of carbon, but changes the albedo. And what this albedo, brighter albedo, means is more radiation actually is getting reflected. Also, the water which was locally cycled due to forest, if you remove the forest, that all water leads to only runoff and soil erosion, which is another problem. Third is a very simple process called Haber and Bosch. So what the entire natural nitrogen fixation does, our factories, right? Our factories reduce more nitrogen than the entire global nitrogen fixation, which basically people would like to sort of look at it and come back with various strategies. But there is always a flip side. What the youngsters have to understand, why are we here and what happened then, is just not to be understand only one side. We are able to feed the entire population only because of this nitrogen fertilizer. Otherwise, crop productivities would not have risen. If you look at the data between 1880 and 1930, population growth was very, very less. 3 factors: wars, famine, right? Plus, there was not enough protection, in the sense the communities were not from slavery to whatnot. There were various social structures which are there. So the post-Second World War, what we have tried to look at is develop. Now, development is itself a very loaded word. Everybody looks at development from his starting point to what his aspirations are. So for everybody, the development is different. And in a world which is so unequal, right? And there are so many disadvantaged communities, so there are 1,000 or I would say billion development goals. So why this resilience and sustainable comes? Let me point out that the IPCC 6th assessment report, it defines climatic resilience as, resilience is defined as a capacity of social, economic, and ecosystems to cope with hazardous events or trends or disturbances and respond or reorganize in ways that maintain their essential function, identity, structure, biodiversity, while maintaining the capacity for adaptation, learning, and transformation. A lot of words have gone into this IPCC definition. I just want you to reflect on one. I believe we are mostly here science and technology. That is obvious because this is a KSTA program. But most interestingly, on the dais, we have a banker, or let us call economist, although by training, he may represent the science and technology. The definition clearly says the resilience is also social and economic. So the first thing which I would suggest to all youngsters is to talk to your social science, economics, sociology, humanities friend and learn their tools, their language, and how social systems and societies and economies evolve. Because scientists sometimes tend to feel development of a method itself is the development of human being, which never happens. Second, resilience in a climatic context is a very useful concept, because resilience encompasses socially inclusive and transformative, which was there in the definition. So, which means the ability of all to mitigate vulnerability. Resilience will not come till the vulnerability is mitigated, and there are more vulnerable people, there are more vulnerable infrastructure, right? Vulnerability itself varies across the scale. So what it means is resilience is used as a socially inclusive concept, transformative, mitigating vulnerability, and you adapt to what? Climatic hazards, variability. Why this is useful? One, it is across the sectors. So we are not talking of urban area or agriculture or rural. We are not biased towards it. So resilience means every sector, all encompassing, development. Second is, it is also open to interpretation. So resilience itself can have many definitions. So what I hope you will see is many people will present resilience and development from a very, very narrow point. Understand that point and assimilate with your own discipline to convert it into a larger concept. That is my suggestion. But in contrast to resilience, the sustainability has been in much, much longer use. Around 1950s, the first conference on human activities and Earth happened. By 1972, we really were talking of the sustainable development, right? And there were very, very famous reports from Brundtland Commission to the small is beautiful. But the sustainability is actually there in scientific, technological, economic, social, and political discourse. Sustainability is not pure only science. Science sustainability may mean enough water or rainfall available for crop, or the soil to have that nutrient over multiple generations of planting, or the forest to recover after a fire or any such disturbance. But the sustainability is even a larger concept than. So once you hyphenate sustainability with development, and development, as we said, has a billion perspective, you really end up into a very, very complicated world. The good point about this complicated world is that we are committed. That is why we are here, to see a better world, to make a better world, right? That is why we are here. So the current phase, globally, let us say, Professor Ramakrishna already mentioned, so I won't repeat those 17 SDG, National Sustainable Development Goal. But let me tell you, in June this year, the United Nations, the SDG Secretariat, it released its report called June 2023 Status. And they found almost every parameter, all across the nation, we are lagging behind. We are just halfway through and just 7 years to reach that place. So unless we really pull up the socks, we won't reach there. So when this report was presented, Antonio Guterres, the Secretary General, said, unless we act now, the 2030 agenda will become an epitaph for a world that might have been. Right? So just there are concerns that even similar to the Millennium Development Goals of 2015, similar to Kyoto Protocols, similar to what was the Paris Agreement, even SDG, we will miss the bus. Okay? This is a very. So they have proposed many things. I will just read out amongst the 5 key points. One of the key points, the government should advance concrete, integrated, targeted policies and actions to eradicate poverty, reduce inequality, and end the war on nature, with a focus on advancing the rights of women, girls, and empowering the most vulnerable. This actually summarizes where we are lacking maximum globally. I will not go more except to say that report also says that there is a large gap and we really need to work on climate resilience. Why the gap is there? Either the resources are not there, people don't have access to technologies. Those issues, I think, are all there. We will come to it. Let us for a moment shift to India. Generally, let us say about 80% of the districts, there are climate-induced disasters, rising temperature, changing rainfall pattern, declining groundwater, retreating glaciers, intense cyclones, sea level rise, right? So what all these things do? One, they create a crisis of livelihood, they create a crisis of food security, and they also create a crisis of economy. The people who suffer, actually, they also lose sometimes their source of income. So they really go down the poverty and take a lot of time to come back. And in the urban areas, this can be even more intense because you have more people concentrated, and there are large pockets of urban areas which don't really have the facilities which are generally associated with urban. So this is, you can have in, let us say, which we call squatter settlements, you can have intense disease, very risk of exposed to heat waves, and a large number of other even floods, etc. Their whole house can get washed away. It is estimated in the last decade, the number of extreme events have doubled. I think that's why if you just look at the newspaper. And it is likely that this increase will continue. Generally, if you remember your statistical normal distribution curve, right? So the climate change is not that the bell-shaped curve has slightly shifted to warmer. Actually, the climate change is that the bell-shaped curve, the size of the bell at the bottom, has become very large. So both sides of extreme is more likely to occur. This is in addition to the air quality issue, I think Dr. Ganesh Raj was talking about. So what do we need? How do we really build climate resilient world? A lot of activities were there. I think Professor Ramakrishna, so I will not cover the national mission, I'll skip them, but let us talk some of the projects. So one of the aim of climate resilience is to lower the carbon footprint. How do you lower the carbon footprint, right? Like one way is to have a odd and even numbers on the road like Delhi wanted to do for pollution. The other is to, people say, please do carpooling, but for the infrastructure and development, what we require are greener modes of transport, like let us say Bangalore Metro. A metro will replace, so many automobiles. The national dedicated freight corridor, east and west freight corridor, use of waterways, right? The Waterways Authority of India and waterways to do. So like one train can replace more than 100 trucks. So if you really have trains continuously running for transporting all from our, Amazon and what we order vis-a-vis the food and other petrol which gets transferred, we need to do. Secondly, we need to reduce fossil consumption and emission through improved logistics. But more importantly, I think we also need to develop a sustainable transport system. That is a public transport system. This human-oriented car, when good, we will shift from our, first we had petrol cars, then we thought because of policy diesel is cheaper, then we started purchasing diesel car, so that policy was an issue. Now we are buying hybrid cars, slowly we will buy more electric cars, and we will find that there is no lithium on the battery, then we will replace the lithium by another material. Even that material will be mined, and then what we will do? We will have technologies, people say, we will mine moon, we will mine asteroid, right? So somewhere this has to stop. Most important part is restoring the dwindling forest cover. Forests do a lot of ecosystem services. They have biodiversity. They actually maintain the water cycle, right? They have so many organisms. Don't use forest only to take out wood. Of course, poor people also depend it for firewood. That is another area. Now, promoting resilient agriculture is very much there, but the issue with the resilient agriculture is you have so many variants, right? You will have zero tillage, you have organic agriculture, you would have other type of thing. But then if you really want to feed that many people, would that much productivity be sustained? There is not enough evidence. So it can't be single objective based. Also now there is a talk of having climate smart agriculture. I saw a paper also, one of the authors is contributing. So there the idea is, how do you maximally and most intelligently use the climate to your benefit. I'll just give you one example how it can work in the reverse way. In the north, because mention was made, you have first rice, right? And when you take rice and the basmati, because the price of basmati is so high, and even government said, okay, you can export. Basically, when you export basmati, you are exporting your minerals and water, right? But farmers, for them it is their income and livelihood. Then the wheat season starts, and in between the time is so less that the farmer finds it economic to burn. If he was to water and plow, the duration and the wheat sowing will be delayed. Actually, so he is actually adapted. He's a smart person, but he's actually creating pollution in Delhi, because Delhi is like a plate, a bowl, and when this transition from this autumn to winter happens, there are no winds. So what happens, this pollution settles over this entire northwest, and in the day the boundary layer comes up, it goes up, and in the night it again comes down. It doesn't go anywhere for 15 days. It just stays there. So what is the policy? We were once discussing the policy could be instead of summer vacation, have vacation. Because what COVID showed us was, if you stop all the transport, stop movement of people, air quality improves. I don't know. You have to think of what should be the policy action. I'll come to it. The other is, we have in India one of the largest, after the irrigated area, also the dams. There are 5,700 dams, huge dams. In fact, dams store water, they also produce electricity, and they also irrigate crop and allow the agriculture to happen. Now, dams were constructed with a particular design, with particular water flow, and dams have collapsed also in recent years. So is this infrastructure climate resilient? We may have to really look and re-engineer the strength of our dam. Other is the groundwater. We are pumping out groundwater at such a rate that water which actually takes thousands of years to infiltrate 700 to 900 feet, right? The infiltration rate per year of the order of centimeters per year. Not the upper perched groundwater, the really deep water. And when we take it out, in fact, more than 1 feet per year is the depletion in Northwest. Then urban. In addition to urban, let us talk of coastal first. A huge number of population lives in the coast. And what the tsunami did to the districts which were exposed and had less mangrove. So the mangrove and shelter belt and really building the resilience of the coastal communities is another issue, making the flood prone areas safe. We are having a lot of fascination of the solar power, but the point is solar power, all the PVCs are actually coming from China, and they have a life, and then we need water to clean them. Also they are occupying now, let us say the largest one occupied almost like 2,800 hectares, right? So it actually is, at the moment it is land, so it almost like so many square kilometers. There is a smart way which people thought, the big Narmada canal, so on the canal water they put also the thing. Now this solar power supply is out of phase with this energy electricity demand, which happens in night. So how do you store this excess solar power, right? If you do battery, you have an issue. If you use it pump to take the water up, then you have a recovery issue. So you please learn these technologies. And now we talk of green hydrogen. Hydrogen plants, actually, the mitochondria and chlorophyll are the best, most efficient biological system as they have evolved over billions of years. What exactly they do is they use a membrane and a small electron to transfer proton on one side and electron on one side. And then they use this catalytic thing which has a very, very small delta energy. But whatever way we will produce, we will consume lot of energy to really extract hydrogen. India has now recently approved 7,500 crore hydrogen, national hydrogen mission, right? We also have made lot of things on entire development, I think economy development. We also need to safeguard future health. So the COVID showed to us one virus, the diameter is only 90 nanometer, the COVID, and it brought the entire world to standstill. So we need to, this climate resilience and the health, we really need to work on it. I will touch upon this space, why space comes, and I hope perhaps that is the reason. We have looking at through the gravity measure, if the gravity goes down, static gravity, you can actually measure the water withdrawal over large area. You actually can see the poles and the increase and decrease in the snow extent. You can mount lidars and check whether at the polar the ice sheet is thinning. You can really have a hyperspectral sensor and see whether in the north and the south pole the ozone hole size is increasing or decreasing. Incidentally, the only success which the human society had was the Montreal Protocol of banning the ozone depleting substances. Other than that, very, very few things have done. We do forest cover monitoring, right? We do agricultural, mapping soil moisture. And in all, in fact, the satellites allow us better weather prediction and better cyclone warning. Weather prediction allows agriculture and all us to move, and cyclone warning prevents deaths. You may not know, because you are younger, the Odisha super cyclone killed thousands, 10,000 plus, as late as 1998, 99. And now the similar cyclones have deaths almost like 1 dozen, 2 dozen, that too because of the simple flooding, some people. It is not, scientists should not claim that it is because of the prediction alone. It is because of the government readiness, a government which can shift 800,000 people in 24 hours and then bring them back and keep them away from cyclone for 3 days. So it is actually the governance structure, community action and preparedness which is very, very critical. So as students of future, we are having a seminar. I'm sure you will also have a training program. But I just want to flag 2 issues. How many of you actually have learned the integrated modeling, in the sense not your own one particular area, but having a different system of, let us say, vegetation growth or a soil moisture or an atmosphere model, link it to a societal thing. All these issues what we are talking actually require integrated modeling. They do not require one theme modeling. The flip side of this modeling is models are nothing but a simplification of the word. They only allow us to, mathematically check the interaction. So do not believe that model is the God which gives the correct answer. No. You have to understand, models themselves have huge, huge errors. But then, when you do science, I think this was also mentioned, you are able to do science, as the very famous quote is on the science is that if I have looked further, it is standing on the shoulder of giants, right? So science depends upon the previous generation which has handed over this. So I suggest to you, in the modern era of data science, AI, machine learning, whatever you observe, whatever you measure, learn to make it open and share. Unless we rapidly adopt this culture of open science and open sharing, I think we will be doing, again and again trying to do the same thing. And since I mentioned the policies, like MNREGA is a very good policy. It allows people to at least have food guaranteed for 100 days, but it allows the infrastructure, plantation, grassland, so many things that it improves the environment of a very small local place. We need such policies, but the policies have to be data and evidence based. They can't be just based on some off the axis idea. And then it also means you have to bring in social sciences, humanities and economics. I wish you luck. I wish you will learn and develop the appreciation of the complexity involved in this title of climate resilience and sustainable development. More than that, I suggest that you interact with all your friends, especially those who have come from different disciplines. Learn to have this conversation and develop collaboration. And I am more than happy and grateful for the KSTA and Dr. Ramesh to have asked me to come and spend this forenoon with you. Thank you very much, and good luck to all of you.
Thank you very much, Dr. Vinay Kumar Dadwal sir, for your highly informative talk. So, way back to 1869, Charles Darwin, who wrote in The Origin of Species, one of his tenets actually I can remember here, so-called survival of the fittest. That's due to the natural selection. Probably at that time it was okay. Now, especially after the COVID, for any small change in the nature, probably with any small change in the natural pressure, we cannot sustain. So that is the status now. Okay. ಆದರೂ ನಾವು ಏನು ಮಾಡಬೇಕು ಅದನ್ನು ಮಾಡ್ತಾ ಇರಬೇಕು. ನೀನೊಲಿದರೆ ಕೊರಡು ಕೊನರುವುದಯ್ಯ, ನೀನೊಲಿದರೆ ಬರಡು ಹಯನುವುದಯ್ಯ, ನೀನೊಲಿದರೆ ಸಕಲ ಪಡಿ ಪದಾರ್ಥ ಇದರಲ್ಲಿಪ್ಪವು ಕೂಡಲ ಸಂಗಮ ದೇವ. ನಾವೇನು ಮಾಡಬೇಕು ಸಾಧಿಸಬೇಕು ಅಂತ ಇದೀವೋ ಅದನ್ನು ಸಾಧಿಸ್ತೀವಿ. ಸೊ ಇಲ್ಲಿಗೆ ಈ ಒಂದು ಇದು ಮುಕ್ತಾಯ ಆಗ್ತಾ ಇದೆ. ಕೊನೆಗೆ ವಂದನೆಗಳು. ವೋಟ್ ಆಫ್ ಥ್ಯಾಂಕ್ಸ್ ಬೈ ಶ್ರೀ ವಿ ಕೆ ಶ್ರೀನಿವಾಸು, ಸೈಂಟಿಫಿಕ್ ಆಫೀಸರ್, KSTA, ಪ್ಲೀಸ್.
ಎಲ್ಲರಿಗೂ ನನ್ನ ನಮಸ್ಕಾರಗಳು. ವೆರಿ ಗುಡ್ ಆಫ್ಟರ್ನೂನ್ ಟು ಒನ್ ಆ್ಯಂಡ್ ಆಲ್ ಪ್ರೆಸೆಂಟ್ ಹಿಯರ್, ರೆಸ್ಪೆಕ್ಟೆಡ್ dignitaries on the dais, respected dignitaries of the dais, dear delegates, colleagues from KSRSAC, and dear friends and my colleagues and ladies and gentlemen. It is my honor and privilege to propose vote of thanks in this August gathering. On behalf of participants of this program, on my personal behalf, I extend a very hearty thanks to keynote speaker of this inaugural function, Dr. Vinay Kumar Dadwal sir, Indira Gandhi Chair Professor of Environmental Science, School of Natural Sciences and Engineering, NIAS, and former Director, Indian Institute of Space Science and Technology, ISRO, for accepting our request to gracing this occasion and delivering an insightful address. Thank you very much, sir. I request our CEO, Dr. M. Ramesh sir, to please present a plant as a token of our respect. Also, immense thanks to Dr. Ramakrishna sir, former Director, Geological Survey of India, Government, Geological Survey of India, Fellow of KSTA, for gracing this inaugural function. Thank you very much, sir. I also immense thanks to Dr. Ganesh Raj sir for accepting our invitation to grace this occasion. Thank you very much, sir. Hearty thanks to Srimati Mummy Kaun from NABARD for gracing this occasion. Thank you very much, madam. And also for sponsoring for this program.
We require more sponsors.
Immense thanks to the main man, the inspiration for all of us, Dr. M. Ramesh sir, CEO of KSTA, for supporting us and encouraging us for organizing this program. And we have also Shri Veerbhadra Anchinala sir, Senior KS Officer and also Provide Secretary to Honorable Minister for Science and Technology, Government of Karnataka, for gracing this occasion and also being part of this occasion. I also hearty thanks to Rudresh. Is a science coordinator in the Honorable Minister's Office, Science and Technology Department. Thank you very much, sir, Rudresh ji, for being part of this program. Heartfelt gratitude to our sponsors for this program, Minister for Science, Government of India, Kstacademy, Department of Science and Technology, Government of Karnataka, and Dynamic Director, Dr. Prabhuraj sir, Director for Karnataka State Remote Sensing Application Center for sponsoring and also gracing this occasion, being part of this program. Heartfelt gratitude to Deepak sir, Manager, SBI, for sponsoring this program, Vidya Renapura branch. Thank you very much, sir, for gracing this occasion. Heartfelt gratitude to Power and Sponge Corporation for supporting us, organizing this program, and also Turbo Steel. And we have Professor Nageshwar Rao sir for being part of this occasion. Thank you very much, sir. And Professor Sangur Mat sir is always supporting us and coordinating with us for organizing this program. Thank you very much, sir. And also I thank Uday Shankar Puranik sir, Professor Natraj sir, Sripada sir, and Professor Kstacademy madam, former dean and also former member of KSTA. Madam was a former dean, Faculty of Science, Bangalore University, and Department of Geology. Thank you very much, madam. Always you are supporting us for organizing this program. Also, I must thank all the KSTA and KSRSAC team, scientists also presenting this occasion. I must thank Professor Swami sir, Dean, College of Horticulture, and Professor Gangadhar sir for being part of this program. I must thank organizing and advisory committee members, my fisheries fraternity, Dr. Lingdal sir, my teacher, for being part of this program, Dr. S. Vijay Kumar sir, Head KVK at Vijaypura, for being this program, and Prakash sir from Echo Mold, founder and director. Thank you very much, sir, for advising and coordinating this program, and Dr. Vijay Kumar, ME, scientist at SIFRI, is also helping us for organizing this program, and Manjappa, he is head at Esaragatta KV FSU. Thank you, Manjappa sir. And also thank all the delegates and my colleagues for helping us to organize this program, and media people and those who have helped us indirectly or directly. And Professor Balkrishna sir also is here. Thank you very much, sir. You are always supporting us and encouraging us. And thank you one and all present in this August gathering once again. Thank you all. And thank you very much, Noor Samad sir, for wonderful anchoring of this program. Thank you, sir.
Thank you very much, Shri V.K. Srinivasu.
I thank Karthik sir, he is co-chair for today's technical session, and I thank all the resource experts for this program, and chairs and co-chairs and all the sponsors once again. Thank you one and all once again.
Thank you very much, Shri V.K. Srinivasu, Scientific Officer, KSTA. Now, with this, we conclude this beautiful inaugural ceremony. We will break for the tea now for the 10 minutes, and we will reassemble here for the next technical sessions. Please. Thank you one and all.
He published a book on evapotranspiration, and he published several research articles both in national and international journals of reviews, and presently is guiding two PhD scholars. With this his background, I request Dr. Karthik B.S. to please introduce today's chair, Professor Kstacademy madam.
So good afternoon, everyone. So first of all, I'll thank you, KSTA for giving this opportunity. And it is very difficult to introduce Madam Dr. Shakuntala Katre, because Madam is from 5 minutes telling that we need to make it as brief, but it is very difficult. But I'll give a few highlights of Madam achievements. Dr. Shakuntala Katre is a first class and gold medalist post-graduation from Bangalore University. She was the recipient of prestigious Atomic Energy Commission scholarship for both PG studies and research. And she is widely traveled and served as Bangalore University in various capacities: Chairman of Department of Zoology, Dean of Science, Member of Syndicate, Senate and Academic Council, Director of Planning, Monitoring and Evaluation Board, Registrar. And after her supervision from the Bangalore University, she served as a National Assessment and Accreditation Council, Bangalore, as a senior academic consultant, and was involved in designing, development and implementation of methodology of assessment and accreditation that was operational during 2007 to 2012. She has co-authored many NAAC publications related to the methodology, process, accessory handbooks, as well as analysis of assessment and accreditation report of a few states, and has participated in some training workshop as a resource person. Now she is serving as a government council management committee of many prestigious institutions of higher learning and involved in counseling institution of science education, educational quality assessment and enhancement endeavors. She is also involved in design, development and implementation of institute specific quality assurance training program and faculty development programs. So I am cut-shorting many achievements of Madam, and she is such a renowned person in the field of research. So I welcome Madam for this session, Madam. Thank you very much.
ಕೂತ್ಕೊಳ್ಳಿ ಫಸ್ಟ್ ಕೂತ್ಕೊಳ್ಳಿ ಇಲ್ಲ ಓದಲ್ಲ ಪ್ಲೀಸ್ ಐಪನ್ ಐ ವಾಂಟ್ ಯು ಟು ಸಿಟ್ ಡೌನ್. A very good afternoon to all the dignitaries of the dais. Particularly people who are on the dais, Dr. Ayyappan and Dr. Karthik. At the outset, I wish to thank Dr. Ramesh and his colleagues of the KSTA for inviting me to be here today with such an elite gathering of renowned scientists, experts, teachers and research scholars to participate in this workshop on the very important aspect of climate resilience and sustainable development. We do know that long-term changes in the climate, essentially due to human activities, cannot be bargained with and are known to profoundly affect the balance of life in the ecosystem. And then with the two erudite speakers in the inaugural session, we do know that whatever changes in warming up of the climate, the planet, or variations in the water conservation and things like that, and invasive crops and pests, we do know that there are frequent weather-related events. And unfortunately, Indian agriculture being a gamble of monsoons, we have problems of crop yields which continue to be climate sensitive, and the fluctuations in temperatures and rainfall patterns affect them in many ways. This session's speaker, Dr. S. Ayyappan, I do not know how to actually introduce him,
because...
No, please, madam, thank you. My request, thank you.
No. No, I personally believe that he is a hardcore scientist and a recent Padma Shri awardee, and to take us through the... to take us through the nuances of a very important aspect of what he is going to speak on climate smart agriculture as related to Indian agriculture. I don't know who else could give us a better insight into what we all should know about it. I'm sure his talk is going to be so profound that all of us will be left spellbound with his erudite expose on the issues, and we will have a lot of takeaways from his talk. I invite Ayyappan, and I think we'll have a little more discussion after that. I have a 4-page biodata of Ayyappan. I do not want to read it because I think all of us know him as probably the most contributing scientist, especially in the agricultural field in the country, and then I don't think there can be any parallel to what he has contributed. Ayyappan?
Thank you so much, madam. Thank you very much. Thank you. Thank you so much, madam. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇವತ್ತಿನ 3 ದಿನದ ಕಾರ್ಯಾಗಾರಕ್ಕೆ ನಾನು ಈಗ KST ಇಲ್ಲದಿದ್ದರೂ ಕೂಡ ನಮ್ಮ KST ಫ್ಯಾಮಿಲಿ ಪರವಾಗಿ ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಮತ್ತೊಮ್ಮೆ ಸ್ವಾಗತ ಕೊಡ್ತೀನಿ. ಮತ್ತು ಇಟ್ಸ್ ಎ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ವರ್ಕ್ಶಾಪ್. At the outset, the esteemed chairperson, Professor Shakuntala Madam, Professor Dr. Karthik, and we have an array of distinguished scientists amidst us, Dr. Nageshwar Rao, Dr. Ramkrishna, Dr. Prabhuraj, Dr. Ganesh Raj, we have Dr. Natraj sir, Shripad, all of you, and then many colleagues who have worked in the field, from ISRO, from universities, agriculture universities, institutions. So several of you are already here, plus students, from different colleges, universities. And my colleague, Dr. M. Ramesh, the CEO of the KSTA, colleague Dr. Anand, Srinivas, and Mr. Umesh. To all of you, warm, I should not say warm, it's already quite warm in Bangalore. It is not the usual November, so but a warm welcome and thanks. At the outset, I'd like to, yes, there are stars in this room, and also the ones who left, Dr. Dadwal and others. But he said agriculture should speak, so I thought I would share a few slides. But otherwise, so very grateful to Dr. Ramesh and team. Or illa ansade, Dr. Ramesh illa alla roomali Srinivas. Okay, so thanks to him, immense thanks to you, kindly convey. And then Madam and the co-chair, thank you very much for this opportunity. Now, so much has been, I think, already talked about. I think you started about 10:30 or so, last 2 hours at least, a lot of discussion. And then climate change is one thing, it's become a buzzword. And you speak to anybody today, even an ice cream vendor on the street, understands what is climate change. Because it's very important for him, that cool chamber, is so very critical for his livelihood. So you can imagine from where it starts, and then it cuts across. And then so we were also thinking what to do. 20 years back, you're all aware that this climate change, these two words started picking up. Initially people were not sure, so they said it's happening. And many arguments, I think by now thousands of seminars, workshops, projects across the globe. And people are still arguing is it happening, or was it a bandwagon, or is it all these kinds of things. But then now people are at least are convinced that there has been a frequent occurrence of natural disasters which we had not seen earlier. That is a simple measure of whether there is real climate change or it's all academic. So that was one point. Second point was people asked, after all, human species is so resilient, so adaptive, and why are we so much worried? Millions of years we have survived. Won't we survive this? And recently, last 3 years, another argument, COVID we survived, and what is the climate change? Every time you bring up these kinds of discussions. But then we also measured, and I'm sure the colleagues would agree, when we measure the temperature rise, because weather in the common parlance is only temperature. The rest of the things, humidity, wind current, all that rain comes later. First is the temperature. So what did not happen in 150 years? People showed us the proof that that much change has happened in 15 years. Now that was one proof that governments were convinced, and everybody agreed that they should start spending in investing on climate resilience, some kind of a adaptation, mitigation, reduction, resilience, whatever you call it. So people, governments across the world agreed. Now the COP28 is coming very soon in Egypt, and then every time the COP meets, the Conference of Parties, you are aware of it, the United Nations one, people discuss, and they are measuring. There have been very clear, significant increments in temperature, of course, very infrequent rainfall patterns. Dr. Dadwal might have told you the total quantity of precipitation has not changed, because Madam Chair mentioned that when it comes to agriculture, we are very much worried. Even this time, the state of Karnataka, you must be knowing, there is a clear deficit of 40%. I don't know, Dr. Prabhuraj also might agree a few figures here and there. And overall, there are at least 18%, that kind of a rainfall deficit. And then somehow we are saying that we will be able to manage, and then we are quite, we have been used to it, and that kind of a thing. But then rainfall also has not changed, the volume has not changed, but the frequency. What would happen in June has shifted to July, August, and the rainfall that would occur over a period of 1 month would happen in 5 days' time. Now, this is what calls for a preparedness and that kind of readiness to accept these changes and change our, whatever practices. And then the question is, with so much of discussions, the questions very clearly the governments are posing to the researchers or academicians or people working in climate changes. All right, we have invested. Now, at least 15 years now, this country also has invested very clearly in climate change, whatever. Now, you saw the Ministry of Environment, Forests, 2 words were added to it. It became Ministry of Environment, Forests and Climate Change. Very clear, specific schemes, focused investments, all this happened. But what have you given us back? Except, the proceedings and so this is what have been very specific questions, both from the central government and the state governments. So we thought better we have something in place to tell, what has happened, instead of only discussing what has happened, what is happening, what would happen. Can we come out with some recipes, some solutions? This was the discussion. Fortunately, the government of India approved a national scheme on climate resilient agriculture. It was called a National Initiative on Climate Resilient Agriculture in the year 2011. And the countrywide participation of several agencies, colleagues from different departments, scientists, of course, and then universities, and including international cooperation. So I thought in this presentation today, I thought I would share some of those, and these are largely the work of several teams that were engaged. Because every time we talk of a satellite, we talk of many missions. We know that sir, you are here, and then the agriculture, the canvas is also similar. It could be thousands of researchers and easily crores of farmers, that's the canvas. And that's where the difficulty also is to implement the recommendations and suggestions. People say that, for example, stubble burning. Every year you are hearing, come Diwali, huge furor, what happens in Delhi. It becomes a gas chamber virtually. Schools are closed, offices are, all kinds of things. So then when people look at it, are there no solutions? Is something being done? Have we got into that kind of carbon credits really, or it's still a discussion? So these kinds of questions, I thought we'll have a few slides brought before you, mainly for discussion, for thinking, nothing in terms of final recipes. Now, I hope all of us agree on this. Ee lights are off ಮಾಡ್ತೀರಾ ಶ್ರೀನಿವಾಸ್, ಈ front light. So all of us agree on this, or any hands would say no to it, because we have been discussing on this, and I think this is well addressed. And when we talk of agriculture, particularly for many years now, particularly after September 28th, you all know that Professor Swaminathan passed away on the 28th of September 2023 at the age of 98. And then we also know that what he did for this country with Dr. Naman Borlaug, a Nobel laureate, almost the only Nobel laureate in agriculture. And then further, Professor Swaminathan in 1965, to be specific, when he got the Mexican wheat, dwarf wheat seeds to this country. So when we hear some of those friends, you would not believe. Of course, the front two rows, all of us know, what difficulties we have gone through when it comes to food. But others, when we have this, KFCs and burgers going around, nobody would, would even appreciate that there could have been times when we ate only red rice, we were dependent on PL 480, we got everything from, it was ship to mouth existence, those were the specific words in the 1960s, and then came this wheat, the dwarf wheat, and then within 3 years' time, 65 to 68, the wheat production that was only 3 to 4 million tons went to 18 million tons. Of course, today is a different story. We are at 105 million tons of wheat every year. But then that 15 million tons made a big splash. And India, it's not the food, but it's the confidence. That's what, when Professor Swaminathan spoke of food in this country, he did not speak of food. He said every Indian to live with dignity, because food brings that kind of confidence and dignity. These were his words, and we lost him, but he laid a firm framework and canvas for all of us to work. Colleagues, I'm sure all of us would agree with regard to what's happening in the recent times, the pandemic that we went through, and today 800 crore people on the planet Earth. Last November, it's almost 1 year now, we became 800 crores. Now 10 more crores would have been added. This to the planet. I'm talking to the entire planet. Then health and food, these two have assumed a huge significance in the whole of the world. Every government, of course there are wars going on, whatever, but still health and food production focus is there. We must also appreciate a lot of transformation that have gone in the area of food production. It's not just agriculture, food production, both terrestrial and aquatic, urbanization, and then migration is another thing that we have been talking of. Migration, why we bring in is the rural youth moving away. It's not just the youth moving away from villages, but the loss of skills. Now everywhere skill missions going around. So that's what is happening in this country. Northeast, for example, we see Northeastern boys and girls all over the cities working in petrol pumps and security agencies and so on. What's happening is when they move away, the whole skill sets are lost in agriculture. To reskill them is so difficult. So this is what is happening repeatedly, and we are aware of these aspects. Today's ಇವತ್ತಿನ ಕಾರ್ಯಾಗಾರದ ಹೆಸರು ಕೂಡ ನಾನು ಭಾಳ ಸಲ ಓದಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೆ. ಅದು ಕನ್ನಡದಲ್ಲಿ ಭಾಳ ಕ್ಲಿಷ್ಟವಾಗಿ ಬರೆದಿದೆ. Because it's mainly with regard to climate resilience and sustainable, whatever goals that we are targeting. So 7 of those goals clearly targeted around, they work around agriculture, food, water, climate, and so on. Then this, we must appreciate, because the agricultural imperative with the kind of population growth that's happening and the loss of land, natural resource degradation, climate change, not the least, it's huge challenge, that we continue with this kind of food production systems and see that, we can produce anything else, but then having basic food requirements domestically, we require that every country is self-sufficient. And that's where we are worried about the climate. The global climate index is, we are at the 7th position, and the index is as high as 16.7. That shows the precariousness of what climate could do. As was mentioned, we are mainly rain-fed agriculture. 60% of agriculture in this country is still rain-fed. ಮಳೆ ಬಂದರೆ ಉಂಟು, ಅಂದರೆ ನಮ್ಮ ಎಷ್ಟೊಂದು ಜನ ಹಳ್ಳಿ ಕಡೆಯಿಂದ ಬಂದಿರ್ಬೋದು. So we can understand. So we don't get that kind of a water, soil moisture. That's important. And this is the global picture. Even today, nearly a billion. We are talking of today 8 billion people on planet Earth, a billion at least still facing challenge of hunger, and then it goes on, and I don't want to, you can read some of them. The point is the Asian continent is all the time focused, Sub-Saharan Africa and South Asia. These two are all the time talked about when it comes to hunger and malnutrition. South Asia is mainly India, Nepal, Bhutan, Sri Lanka, Bangladesh, and so on. Now, this is what we would like to call it as footprints. Every time we talk of footprints, it's starting from Norman Borlaug, as I mentioned, Professor Swaminathan, that Korean. Again, if we are talking of dairy and milk with confidence, it is this person. And when it comes to fish, it is one Dr. Chowdhury who bred the fish, when it comes to breeding of fish, inland, freshwater. I understand many of us are from engineering colleges, but here in this auditorium, but then the point is we have to know something basics about food, and food is everybody's business. And that's where I'm bringing out this. Dr. Chowdhury bred the fish in ponds, and that led to many other things. Colleagues, not to overemphasize, this country is only about 4% of water, 4.5%. Similarly, 2.5% of land of the entire planet Earth. But we are sustaining 18% of human population, 143 crores today, and then 15% of the livestock. And 1/3 of the country is cultivable. Rest of it, for many other uses as is required. And even today, 44% are into primary agriculture. So 44% means it's something like 60 crore people in agriculture. And of course, the GDP contribution about 18% and so on. And in Karnataka also, it's very important to note this. We have as many as, how are we, people keep asking, how are we comfortable then? How are we not worried? How is it that we don't have the kind of famines that we had in the Bengal famine, That's because of two things. Dr. Ramakrishna might have spoken to you about biodiversity. Madam also all the time emphasizes on the ecological balance and so on. That is one thing. And then the second thing is this kind of agro-ecosystems. Throughout the country, more than 127 agro-ecosystems. This state also has 10, whether it's Coorg, the hilly, or the coastal areas, or the plains, or the northern Karnataka. Now, if one area fails, other areas produce food. That's how we are able to manage this kind of food balance. Otherwise, many countries are with monotonous crops. Maybe just in many European countries, it's only wheat. In US, it's only soybean, corn, and wheat, and nothing else. That's the kind of agriculture. But in India, it's such varied diversity that has been put to agriculture, 58 commercial crops clearly. So this is what is taking us through this huge country. And similarly, when it comes to Karnataka, it's 5% to the country's food basket, and 50% people in Karnataka are absolutely into agriculture. I won't go into these details, but then just to tell you that food production has been continuously increasing. So what is it broadly? Today we have something like 33 crore tons of food grains. It's in million tons, 332 million tons of food grains. Very important. Always we talk of food production, that's rice, wheat, maize, some pulses, but that's not all. The fruits and vegetables, which please appreciate, the younger generation again would not even know that we never got apples when we were young. It used to be largely bananas and maybe some guava and so on. Now that kind of a huge production and countrywide, pan-India availability of the kind of fruits and vegetables is again a huge revolution. Dairy, we are the largest producer of milk, meat, fish, egg. So I always say this, all put together, it's about 1 billion tons of food. It's not just the food grains. And that's what is carrying us through. Other details I won't read, you can make out from there. Now what is the new agriculture? As we go further, it's becoming very clear that we have to produce more from less for more. And a kind of shift has to be brought in. COVID period, 3 years, really clearly brought out this requirement of more protein. And then now it's stress agriculture. That's where we are talking of value addition, specialty agriculture, a continuum from agriculture to food, to nutrition, to health, to environment and employment. Because the main concern today of the youth is with regard to gainful employment, remunerative occupation. That's where the agriculture has to be made more attractive. And that's where I said, the confidence of this country is, fortunately, the biodiversity, more than 10%, whether it's terrestrial or aquatic, but the natural resource base, kindly see, we don't have more than 0.1 hectare per Indian as per capita land availability. Whereas in US, it could be 10 times more, because that country also, given the land area and population, they are just 1/3 when it comes to population densities. So when people compare countries like US, Brazil, China with India, the comparisons have to be comparable. So that's where we bring in some of these, these aspects. And again, the food diversity in India. Please appreciate this another aspect. The culinary diversity is so wide. There are 17,000 primary recipes. For example, dosa andre doseಯಲ್ಲಿ ಒಂದು 100 ಥರ ದೋಸೆ ಮಾಡ್ತಾರೆ. But dosa is only one recipe. ಅದನ್ನು ತಗೊಂಡ್ರು ಕೂಡ it's something like 17,000 recipes. Why I am bringing up all this is each of these is being impacted by climate nowadays. When people take their food, they compare, with regard to one is the food, the edible portion is one thing, but the taste, organoleptic qualities, the nutrition qualities, each of these are all the time discussed. Now, what is the future? What are we to do as we go further? It's just not the food grains, it's so much of other things. Other aspects of agriculture could be dairying, fisheries, livestock, field crops, and agroforestry, and so on. Now, another aspect is how to make the farmers into agripreneurs. Now, you are aware, people are giving up farming. There's so much of drudgery there, labor costs, there are attendant, many other issues. So now, if people stop producing food, many other social schemes and other things, we'll not discuss that here. But the point is, this is what is the requirement. And in the meantime, we have been talking of how to enhance the farmers' income so that they stay with agriculture. When we compare other incomes of other occasions, service sector, for example, today, that's the maximum, and the industry and agriculture. So how can we make ourselves comparable? That's the question. So how do we add value to agriculture? And for this, many kind of recipes have been brought out, but the challenges are also increasing. For example, the climate change. And the way we produced food, when we were independent, when we became independent, we were only 35 crore people, and the food production was 50 million tons. And that's where we had started importing. Today we are 143 crore people, and our food production is food grain to 300 million tons. But the point is, every time we are asked to have a tag of how much energy and how much water. Water, energy footprints have become very important. Whatever we do, it has become important to account some of these. So in this context, we have to produce food that is competitive globally. If I produce more food, just that's not enough. Because tomorrow, for example, in case of pulses, countries like Tanzania, Myanmar, Canada, they're all waiting to export their pulses to India. Now, if we simply produce pulse, it's not enough. It has to be at competitive rates globally. And that's where we keep, for example, this time, the World Food Day last month that we organized, here the basic question was, everything else would be available, but it's the water, the criticality of water as an input. And these pictures are very common, I believe. It's available everywhere. And that's where I just mentioned how extreme weather and agricultural productivity have been going on. Now, on one hand, we have to continuously enhance the productivity. Productivity is kg per square meter or tons per hectare or whatever you call. Now, that is the productivity. We have to keep on increasing, and it is happening. Otherwise, we wouldn't have been able to bring the food production from 50 to 300 million tons. On the other hand, there is so much of drag from other aspects like stresses, abiotic, biotic, natural resource degradation, and now the climate change. So now this is how it happens. Every time we try to bring in new varieties, new components, new practices, there is also a resistance occurring naturally. Now we all keep hearing about this. This time what happened, people have been explaining the Pacific Ocean, surface water temperature, and how it's affecting the, all the other continents, including the Indian continent and so on. So I'm sure Dr. Redwall might have spoken to you about it. Now we are mainly concerned with the water availability, and when it comes to the country, this country, something like 4,000 billion cubic meter available, was that much of water, fresh water. Now of that fresh water, the demand from different sectors, also had to be factored in, the industry sector and agriculture. Earlier, 50 years back, agriculture was the primary user of water. Nobody asked us how much water do you use. But now things are different. There is a competing demand for water. So this is how we have been kind of mapping what could be the projections as we go along in the next 25 years with regard to industry. And so I see the industrial requirements will be huge. They will increase. The energy requirements, again, even in spite of thermal, maybe nuclear as we go along, but still, there is still a hydel power requirement for when it comes to water resource. Now, domestic water use, other human consumption, then comes the irrigation. Now, this is what we have been trying to project, that we would bring in smart measures. So, we would bring in smart agriculture. So, the water would not, continue in the same breath. And if it continues, the people will not also appreciate, and that water would not be available. So we have to factor in this, and that's how the climate resilient practices are being worked out. I would not again go into details. I'll show in bigger pictures. Again, state-wise, commodity-wise, we have been working out how much water is used for product producing, for example, a ton of paddy, rice, or a ton of wheat, pulse, and so on. So these are being worked out. This is what I would bring the broader pictures also. Now this is to be absolutely remembered, kept in mind. This country, more than 50% is the water's availability, severity is so high. And it's almost that we are taken for granted, and we go the way as we were, the business as usual, as they say, without making any changes in our practices, our life patterns, and so on. Now that's where we keep again looking at how much water was being used earlier, how much can it be brought down. Again, these are some of the things that have been clearly quantified. And the point is, we have to project water maps, water requirements, water budgets. It cannot be in silos, it cannot be in isolation, it has to be with other sectors of economy. That's what is being done. Again, in the same breath, the gas emissions have also come into discussion. And this is where now these have been brought out. For example, pre-industrial, how much was the carbon dioxide, the current one, and what could be as we go along. So it could be methane, nitrous oxide. Now these are being worked out, both South Asia as a whole and Indian subcontinent. So in South Asia, for example, this is what is happening when it comes to rice cultivation in different countries, and the livestock and nitrogen fertilizer and so on. Now nitrogen also, when we apply urea, for example, you all know urea is a very common fertilizer applied. Only 44% of it is utilized by the crops, rest of it gets into aquifers, and that creates problems. Now this is where the livestock sector again, we also have that kind of a, because it's our tradition. The Asian tradition is that kind of livestock with the human population. Now this is what are the pictures, and this is where we look at now agriculture sector, for example. Again, don't worry about too much of statistics, but then this is what is something like 14% of the emissions in India are from agriculture, because usually people say that it's so high, much higher, but then these have been quantified. So in that enteric, that means from the livestock, hasu, emme, puri, and the ruminants, adrinda about 55%. Rice, the paddy, because rice is also very important for us. We produce something like 100 plus million tons of rice. So from that, about 18%. And what fertilizer we apply? Now this is important, because with great cost we apply fertilizers, and it should not be excess, and that it would create problems. So like this, it goes on. Now the straw burning, for example, in northern India, a ton of rice residue burning, this kind of a picture, 60 kg of carbon monoxide, a ton of carbon dioxide, and so on. So 23 million tons of rice, that is straw that is burned, it is something like 9 million tons of equivalent carbon dioxide. That is where is the problem in Delhi and around Haryana, Punjab, and so on. Now, these kinds of things, again, now alikallu anta karitivalla, the hailstones, when we are young, we have all the, picked them up, 2 grams, 5 grams, 10 grams of that kind of thing. Now we have seen the hailstorms, you would happen normally in northern, in Uttarakhand, but these are the pictures from Maharashtra, right in southern Maharashtra. These kind of hailstorms, hailstones, maybe even up to 2 kilograms of hailstones, physical damages to vehicles. Now these are things, these are the aspects of climate change that is worrying agriculture. Otherwise people will say that nothing is happening, it's all gradual, why are you so much worried? But then these kinds of happenings which we had never come across, and including physical damages are what are worrisome. So this is in this context we keep analyzing, projecting, and so on. Now what would be the projected impact at global scale if we don't do anything? Easily 10% of the crops will be lost, 10% of food production will be lost. So that's where people have been working on the adaptation, mitigation. These are all IPCC. Again, I'm sure Dr. Ramakrishna and others would have dealt with them, International Panel on Climate Change. And then this is where we brought in a national scheme in India, national project, national program on climate resilient agriculture. That's what I mentioned. It was a large network program, and initially we didn't even have infrastructure for analyzing climate change. That kind of chambers, initially increasing the temperature, altering humidity, then the light variation, so on. So it all calls for a huge amount of infrastructure that we were able to establish in the beginning across the country. And then these are different pictures for different crops and commodities. And this next few slides are with regard to what did we do with this in the last decade or so, what has actually happened, so that brings confidence to this country. We can do things. It's not so desperate a picture, because we come across several reports, global, national, and so on, governmental, NGO, several of them. So they keep, you keep projections on GDPs. For example, last few days, it's been a discussion on whether we are at $4 trillion or not, whether we are 2.8, and so on. So now we also will need to have ground data. In that context, the drought monitor, again, lot of collaboration with the ISRO with regard to these aspects. In fact, Dr. Kiran Kumar, when he was the chairman, we worked a great deal in some of these aspects. Now, dryland farming, for example, Karnataka is basically 60% is into dryland farming. The kind of crops, pulses, maize, and so on. Now that's where the different kinds of varieties, water-saving technologies, leveling of the fields. Many of them, as you go to the villages, it's that kind of a terrain, where there could be puddles, there could be elevations, and so on. So even just leveling with a laser, enhance the water use efficiency by more than 30%. And that's where we are talking about water-saving technology. It could be laser leveling, it could be pipe networking. Instead of every farming, every holding having a borewell, can we talk of a community borewell program, irrigation program? It did really work near Hyderabad. 100 farmers came together. Otherwise, it's very common in the state that we have borewell across. Now, these were recent missions that we are talking of, as every drop should yield us a little more. In that context, it could be trenching, it could be terracing, these kind of modifications. Now, there are many things, maybe we won't go into those details, but the point is the water holding structures which could be multi-purpose in different ways. And then this is where I'd like to drive a kind of attention. We are asked to have budgeting. How much water? A ton of paddy, as I mentioned. Can you believe a kilogram of paddy? Paddy is, paddy to rice is only 2/3. We get only 2/3 rice from a kilogram of paddy. Even for a kilogram of paddy, we require 1,600 liters of water. 1,600 liters of water, 1 kilogram of paddy. You can imagine. That's where, we keep talking about whether it's due to transpiration, evaporation, seepage, and the plant consumption, all put together, it's 1,600 liter water per kg of paddy. At the cost of repetition, I'm mentioning this. Similarly, these have been worked out for all these. And why these disputes, river disputes, you can very well imagine, that's the kind of water guzzling crops these are. Paddy, sugarcane, banana, and so on. So this is called as water footprint. And then this have been worked out, not going into details for each of the crops. By now, they have been worked out. And now the question is, are we providing more water than required? That's what is happening. Wherever water is available, you can see the paddy fields flooded. And because of the flooding, the methane emission increases, the unnecessary water, and water, as the water quantity increases, a lot of salinization happens. In this country, the whole of, you start from Haryana up to Maharashtra, where several inland soils have gone alkaline and saline because of excess water. So that's where we are having these kinds of practices and awareness programs brought in. So in this context, several natural resource management includes whether we can manage the gas emissions, and then crop residue burning, what could we be doing about it, precision farming, then water demand, and then some kind of a rationing, and then nutrients also. Sometimes it's mostly low nutrient application, but whatever we apply, it's not in balanced ratio. Now NPK, for example, all of you might be hearing about it, nitrogen, phosphorus, and potassium, 4:1 ratio. But what we do is always apply nitrogen and forget about the other two. And that's what is leading to several other issues and problems. Now this, for example, genomics, all of you must be familiar, a lot of things are happening. We have been sequencing genomes of several plants and animals and so on. Now this is with regard to phenomics. How does the exterior look, and how can we match them? So these were facilities that were not available, and today it's available for the young researchers across the country, at least in 6 locations. Now these are the innovations. Do not happen always only in research institutes. It could happen anywhere across the country. So from northeast to western Ghats, people make their own arrangements. For example, this is for water management. Or next is the wastewater use. The green water, blue water, gray water that you keep hearing about. Can we recycle? That's the next question. And a lot of efforts have already happened in this regard. For example, the rice fish culture, which could be done in deep trenches, and a possibility. And what happened was, this led to integrated nutrient management also. In just paddy, what we would do, have an excess dose of fertilizer or pesticide, but when there is another component of fish, we would be very careful. Now that's what helped in the process. Or the integrated farming. For example, again to come to cost, when you grow rice, it is just about 2 rupees that you gain from a cubic meter of water. But when you integrate, have fish and other components, it could be as much as 14 rupees per cubic meter. This convinced people when it came to remunerative farming. Now these are again, for example, innovations. Again, we talk of science, technology. Nowadays, it's the innovations, how people customize, when there is a need, it's not in the kind of highly innovative practices that we keep collecting. These are the kind of mulching and soil conservation that's happening. In the meantime, can we be, in order to address this kind of excess fertilizer use and creating problems and environmental concerns, can we have some other alternative? Nano fertilizers have come in a big way, and for example, 100 kg of urea could be, or it's 100 kg of nitrogen, that's 112 kg of urea, can be brought to just about 8 kilograms of nano urea. That's the economics. And then this, for example, I just mentioned, because we have labor issues when it comes to paddy and wheat, and this is possible when it comes to stubble burning, and the kind of smoke that emanates have been worked out per hectare. I mean, I'm leaving it that. Those interested can get into some of these. We also encourage youngsters to get into some of these areas. I must also mention several solutions are now coming from engineering colleges. The kind of projects they take, they try to address the local issues and they come out with clear solutions. And because of that, in this state, at present, there are about 100 agri startups who are doing some of these. Across the country, there are about 700 agri startups. In this state, about 100 startups have taken to some, not stubble burning, but many other aspects of agriculture they have taken to. And the solutions have come from engineering colleges. Now, this is, for example, the Institute Incorporation of Residues. So we have got business models for some of these. And agroforestry is another thing, for resilience. Now, this, of course, we had all that kind of problems. Now, afforestation is talked of, and our colleagues, Dr. Sangrurmat is not here, he left. Now, again, the kind of afforestation that's happening with a single species or two species without a scientific, a kind of background there. When you visit forests in the recent past, the kind of, again, they all have become kind of monoplantation. Now, these are the discussions that are happening, and again, agroforestry, several business models have been brought out. Now, integrated watersheds in very important interventions. I must emphasize again, it's engineering and agriculture. It's not just agriculture. We are basically biologists, but the engineering interventions have been very, very important. Now, in resource management, for example, it could be direct seeded rice. It's available. It's happening now. And then nano-urea, I just mentioned. Micro-irrigation, people know drip is a very common word everywhere. Now, there are several variants of drip irrigation. And then further, for example, neem-coated urea, a slow release of nitrogen so that it doesn't get released in one stroke and create problems in the soil water bodies. And then when it comes to, these were with regard to natural resources. When it comes to crops, I must mention a lot of basic research from several universities have greatly helped in terms of sourcing genes, whether it's for salinity tolerance and many other aspects, abiotic and biotic stresses. And I must also mention this, we have deposited our seed in the, in Norway, near Trondheim, there's a global seed grid. So if something happens, not to worry, the Indian seeds are all safe and they are being continuously deposited. These are global agreements. And that's where we talk of when it comes to field crops are rice, wheat, maize, pulses, all that kind. So please be assured that there are a number of varieties available, and varieties also don't stay for a long time. Because of the climate change, earlier a variety would rule, use the word rule, they would rule for 30 years. Today what we are noticing is in 10 years time, they lose their use. They can't be used. Because that kind of again, that's very critical for us. Similarly in horticulture. Now, we have been again assessing what would it mean again when it comes to this country. Wheat, for example, will go down by 10%. 10% is huge. Please imagine 100 million tons. Recently, kindly be aware, 3 months back, India stopped all the rice export. You must have heard about it. Except basmati, all the rice export was stopped. And you must have seen from the news the kind of furor in whether it's for United States or in Middle East, because we are the major rice exporters. The countries like Thailand, Indonesia, Malaysia, they export palm oil, but they do not part with rice. That's so very important. So 10% means it's 10 million tons gone. So these have been worked out what would be the clear impact of climate change. Similarly, other crops that have been looked at. And I won't again go into these details, but these are the kind of detailed pictures that have been brought about, where it is irrigated rice. That means where water availability is all the time there, or it's rain-fed. Only when it rains, you have water availability. So this has been worked out. And a good amount of biotech interventions that have helped us in hastening the breeding and the selection and breeding process is another important intervention. And fortunately, these tools are being deployed very strongly in agriculture. I already mentioned about nano fertilizers. Along with that also the probes that are very helpful for us in disease diagnosis and so on. And right now, very clearly, we are worried about heat stress, wheat heat stress. In the month of February, when the wheat harvest will be at its peak, 1 degree Celsius rise in temperature, what the estimate is 5 million tons of wheat will be gone, just 1 degree. So you can imagine that's the That's why people are so worried for early wheat sowing in the month of October. And that's where, we don't have gap between paddy harvest and wheat sowing. And that's where all this, the paddy straw burning is happening. So very clearly we have today wheat heat stress tolerant varieties, rice submergence, nitrogen use efficiency, maize, so some of these. So the point is, this country can be not complacent, but can be confident, that there are material available. We would not go hungry, immediately. That's the point, because many countries are struggling today. Now, this again a picture of what kind of varieties and what are their traits for which these varieties have been produced. And only issue is they have to be scaled up. The breeders would produce maybe a ton, but then you need 100 tons, 200 tons for seed, and that's the scaling up issue. That's where the enterprises and startups are coming in. Again, the resilient genetic material. I would go fast on some of these slides. Then this is what is remunerative cropping. You travel 20 kilometers from here towards Dodbalapur and whatever. You can see several people taking to it. Very intercropping, and there are very interesting examples of startups, where they have given our, the flats, the kind of people, software people live there. They have taken on lease 5 meter by 5 meters plots, and the farmers take care of that, and they ask them to grow a specific type of crop, and they grow, and every weekend they go and visit. I mean, these kind of very innovative models have come up even around Bangalore. And this is, for example, very quickly, the different kinds of systems, rice, wheat, pulses, and so on. Then the future crops. Illi ragi yavalu ellaru ragi tinoru. Iga amele nowadays ella ittu. Ella hotoitu ivaga tirga. Last year, for example, this whole year is the International Year of Millets. Elli nodadu millets, the health foods and millets and organic foods in Bangalore. Every street has a organic food outlet, but we definitely know that much organic food cannot be produced, is not produced. They're all simply being labeled and sold. That's what is happening here, because people can afford to pay. Now, when it comes to these millets or some of the other crops, these are the future. We call them as they were called as anatha belegalu anta, orphan crops. But then we are trying to bring them as the kind of future crops. And this is what is happening around urban areas. The nutri-farms, this is what I mentioned. You indent a crop, and the farmer would grow that, and he can harvest, take home, and then you would pay for the plot. This is the urban and peri-urban farming. Similarly, protected cultivation. Several things are happening, but not viable for every crop. They have to be high-value crops. For example, around Sarjapur and other people grew capsicum. Protected polyhouse nalli, they grew capsicum. So in an acre, they earned more than 18 lakh rupees. But then, so crops have to be that kind. Otherwise, simply growing ragi and rice would not be helpful in protected cultivation. Hydroponics, aeroponics is another thing, sometimes viable, and many places not viable, but then these are possible interventions where you can use wastewater recycled in different forms. It could be floating horticulture, where we don't use a soilless culture, and vertical farming is another possibility. And now another issue that has come up is, again, Dr. Ramakrishna and others would be familiar with this, the whole pest behavior, the emerging pests, new pests that are coming in. For example, in this state, 3 years back, the whole maize on the army fall worm, people did not know about it, and that damaged everything. And this time again, for example, in sericulture, silk, for example, they have got into these issues of non-spinning. I mean, these are actually local ground level problems, and some people, the scientists know something. Many times they also have to learn. It's not that they know everything. So it's become that kind of challenge. So these are happening due to this kind of severe climate change. We may not appreciate, but if we are in that particular profession, it's such a huge shock to the entire family, and it goes on like that. Then in this context, what's being done is the integrated pest management. In different forms, can we look at them, and many models have worked out very well. And horticulture, again, I must mention, there are, for example, mango. Mango seasons have changed. Flowering agate, fruiting agadilla. We see a lot of flowers, but amele yavadu baradilla. the good yielding tree, next time they would all end up with small fruits. I must mention also here Dr. Onkar from the Indian Institute of Science. He is a specialist in imaging. He has brought out some tools of mapping the mango trees. He is able to tell which tree you can harvest in this week and which you have to wait for. And it's very amazing. It's a lot of ground truthing that was done, and his spatial image matched. So the point is, these are the intervention points even for engineering students, and it's being received very well. We require that kind of new interventions. And so this is where we are talking of climate smart integrated farming systems, depending on water availability, temperature, and so on. Now the problem is there are models available. There are some standardized technologies. I won't say everything, but the problem is with regard to scaling up. Kindly appreciate the canvas of agriculture is very huge. Small, it's not just the districts, towns, small taluks, villages, you can imagine. So this intricate intervention required is very difficult, and that's what people keep on asking, why is it not happening? You can imagine the flow down, the absorption of new technologies takes time, and then the wherewithal to adopt them takes time. So this is where things are getting delayed. Otherwise, with regard to the agricultural research, knowledge, the kind of technologies, recipes, they are continuously being addressed and evolved. Now that's where this question was brought out, that it's not possible just by whatever a few governmental departments or agencies. There have to be a lot of village institutions, whether it comes to farmers in the villages or it's a lot of, for example, the women self-help groups, women who are in the villages all the time, or the coastal villages where the women are there, largely in the village. They don't go fishing, for example. Now they have taken to some of these, receiving information, converting them into local, usable, recipes, advices, and so on. So that's where we bring all these. That's what we call them as climate smart farming. Again, ರೈತರುಗಳು ಕೂಡ ಕೇಳ್ತಾರೆ, ನೀವೆಲ್ಲ ಸ್ಮಾರ್ಟ್ ಫೋನ್ ಇಟ್ಕೊಂಡು ಬರ್ತೀರಿ, ಎಲ್ಲ ಸಿಟಿ ಎಲ್ಲ ಸ್ಮಾರ್ಟ್, ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಬಿಕಮಿಂಗ್ ಸ್ಮಾರ್ಟ್, ಓನ್ಲಿ ವಿ ಆರ್ ನಾಟ್ ಸ್ಮಾರ್ಟ್ ಅಂತ. So then we tell them, no, we can become smart. How do we become smart? They have to be water smart, energy smart, input smart. That's what is being addressed now. Now when it comes to livestock, maybe a few minutes more, madam. So now it's again a very, this is important, because when it comes to cattle, about 20 crores in this country, hasugulu, MA about 10 crores. Goats about 14 crores. Of course, goats disappear. Every time, all these, I don't know what to say. But then the country's asset with regard to livestock is this. Very few countries, let me tell you, is, for example, Brazil, is comparable. And in fact, Brazilians have taken our breeds. For example, Mura, they have taken our breeds. And when we went there and we saw the way they have improved those breeds is amazing. That one intervention we did not do here. So they have remained that way. For example, this is the kind of availability of products. Now, if you look at the country's breeds, very prestigious breeds, can be proud of them. Only thing is, what's not available is the fodder. So the corresponding fodder, ದೊಡ್ಡ ಹಸು ಇದ್ದಷ್ಟು ದೊಡ್ಡ ಮೇವು ಕೂಡ ಹಾಕಬೇಕು. But what's not available is this kind of a, one is the food and the health interventions to keep them very healthy and make them yield much higher. But in this context, what's happening, the climate change is playing, these are again some of these breeds. Now the problem is with regard to, whenever it comes to emissions, there are the global, the international panels who keep charging the Asian countries with regard to emissions from the livestock, enteric emissions. For example, a liter emission, given these aspects, these have been worked out very clearly. I won't again go into detail, these are too much. But then point is, for each animal at different stages, with different feeding strategies, we have worked out what could be the emission per animal. Per liter of milk, how much it could be. This kind of budgeting has been done. For example, this is state-wise. When it comes to some of these states, animal component, for example, 60% come from the cattle and buffalo population. that are about 330 crore. So these are required because when we have to defend ourselves, because you know the issue of subsidy and so on, when we have to defend ourselves in the global fora, these statistics are required because it could be vehicular traffic, it could be industrial emissions, it could be the developed countries who do not pay penalty or who do not invest enough in climate resilience. And fortunately, we must be assured Indian government is very, very well versed and very keen on some of these investments and management. And these, for example, hotspots, which are the hotspots in this country? Again, you can see this. These are the central India, for example, is mainly with regard to the entry emission. So the mitigation strategies have been worked out, what feed formulations can be adopted, what kind of a, some kind of a moisture maintenance in the sheds and so on. Now again, the impact of diet, I just mentioned. There are clear formulations, additives available along with the fodder or feed ratio that would reduce methane content in the emissions. Now when it comes to fish, very quickly, very important, 1% to the GDP of this country. This state also, you are aware, 300 kilometers of coastline. Yesterday was the World Fisheries Day. A lot of things were discussed in Bangalore. And then we are second largest producer of fish after China. So these go on, but what's important is the aquaculture, the fish culture is also growing so fast. But what's happening is 2004 was the first major incident, the tsunami, which we had never ever had experienced earlier. It's about 20 years back now. The tsunami that hit the eastern coast and to partly west coast also, this created so much damage. At the same time, the awareness to keep track of these, not only cyclones, and at the same time manage them. For example, sea surface temperature is very clear increase is happening. Very clear means it's not in units of 1 and 2, it's 0.1, 0.05 and so on. But our problem is the fish stocks. For example, these are very classical sardine, a pelagic, the pelagic fish called sardine. The stocks that were available only in the southern part of the Indian Ocean. Today they are available in the northern, that means to the coast of Andhra Pradesh, Gujarat and so on. That is worrisome. Similarly, the sea level rise, when it comes to Bangladesh, this is being discussed every time, a centimeter rise in a year, and it's not small. So here also the island systems and coastal systems are threatened, and that's where we are looking at livelihoods, what is lost and how it could be rehabilitated. And for example, mangroves that we have lost considerably, how they could be afforested, or some mitigation measures of how to hold soil conservation in coastal areas with some of these interventions. And the climate resilient food crops also are being discussed, and like these workshops, we continuously hold along the 8,000 kilometers of coastline of this country in small colleges and schools. Workshops are arranged to teach about the climate resilience, or otherwise the countries like Maldives are so much into threat. Now here we also look at the carbon footprints, and then what is the emission from ponds for every ton of fish, how much could be the emission. That's being worked out, because otherwise exports are not accepted. Earlier the exports were mainly with regard to residues, antibiotics and so on. Now it's also with regard to green labeling, how much of carbon dioxide, what is the carbon footprint that you are leaving in some of these. So we are trying to project what is the sequestration, how much carbon dioxide is absorbed by the terrestrial system, terrestrial food production systems and the aquatic ones. At the same time, the seas, many places, they are getting acidified, the coral threats, coral reefs getting threatened. These are also another part of the observation with regard to climate change. Now, interesting thing is with regard to inland fisheries. The Ganges, river Ganges flows from Gangotri to the end is in the last portion of West Bengal. And to that extent, we have been looking at the fish availability, major fish, a group called carps, major carps. No, they were not available beyond Allahabad earlier. Now, even up to Haridwar, we see the same species. That shows the gradual rise in water temperature in the riverine systems. Again a big concern. So in this regard, I heard some people are from JS also. You can look at the canvas is so huge for research. Please get into some of these. These are pristine areas. You can contribute a great deal. And this way we are looking at electronic atlases, water bodies for better management. And I already have mentioned this with regard to water budgeting. I won't take more time. But then even for fish, I mean, of course, we say fish does not really consume water in that way, but then evaporation, the fecal matter, and all that, it requires an amount of water. We also are looking at the reproductive capacities with regard to fish. Yet somewhere at many places, there is a change in the breeding season of the fish. What used to breed in July, a little advancement. So the point is we can't change much. But then can we adapt it? Can we adapt our practices? Can we start culture a little early? These are being standardized. Now, I won't take much time here just to say that these are absolutely in place. So finally, what we want to do with all this is a kind of a recipe for the farmers to be confident. People who are not farmers means not just farming. Anybody who is concerned with food production, that it's a good profession, good vocation, and there is so much science that would enable him or her to go further. Now, UN COP6 and 26 we have talked of, and then finally India took call on 5 points. Again, you must be knowing about it with regard to fossil energy. Then we said that 50% of energy requirements from renewable energy, and we said that we'll reduce the carbon emissions by 1 billion ton by 2030. And then we also said that the carbon intensity to be by more than 45%. And we said by 2070, well, it's easy to promise many of these, but then everywhere, please be assured, there are mechanisms being put in. SDG 2030, for example, only 7 years left, and we have been told that we have covered only about 46%. In the last, it started in 2015 after the MDG. So in the last 8 years or so, we have crossed only about 46%. And this is where we think by 2030, this country, the small marginal farmers will be more than 90%. Now, this is another very, very important factor. In no other, except China, in no other country, the small and marginal farmers are this high. In the next 10 years, we are going to be 90%. The farmers are going to be small holders. That means less than 2 acres. And they have to produce 75% of the food. And each of them has to be enabled, facilitated with all the tools, and not only with regard to inputs, but with regard to managing the vagaries of weather and climate. So finally, what we think is the agri-diversification would do a great deal of good. A wide variety of healthy diets, climate-smart food systems. It could be biofortification. You must have heard about fortification already. Salt, iodine fortification was a very old thing. But now there are clearly biofortification happening in fruits, for example, and vegetables. Then early warning systems, IoT in a big way, high applications that we have been discussing with the interfacing engineers with the ITs with agricultural researchers, high possibility of IT interventions. Then finally, innovation systems. It could be risk management, crop insurance that's coming up, and then safe food, healthy and safe food. So many, many things. But for example, microplastics is today a big concern. It was antibiotic residues, now came the antimicrobial resistance, now the microplastics. So like this, the challenges keep adding up every time. So it's not just the quantity, but the quality of food. And climate, I must mention, not to overemphasize, it's absolutely playing a role, impacting us every day, and people are worried about the next 25 years what would happen. But then these scientific tools, I'm sure is bringing so much confidence to everyone. So that's where we are talking of a secondary agriculture, and as I said, biofortification, a food health connect, a fusion of technologies. Any number of technologies would be helpful, and these are actually being, for example, drones. Just an example. So we are able to kind of map the crop areas, but then also the disease incidence. That's very important, and that's where the bio incubators and startups coming in a big way. innovations across, youngsters taking to several kinds of innovations. I'm just going fast in this. It could be any of these in different forms. So that's where we talk of spatial applications in, and geoinformatics in agriculture, and digital agriculture is another thing that's being talked of, again to bring in more resilience. And each one can contribute to this. For example, in some schools, kitchen garden is, I know, was already there, but in some schools this has been provided for to complete the complete crop season, and then students working on farms. So what we think is, with all this, already projections are for 2047, centenary of the Indian independence. So the hope that's required, the strength that is required will come only through food production. And I would like to acknowledge a large number of my colleagues who have contributed to this. Finally, agriculture we think is everybody's business. It's not a few farmers, it's not farmers and some researchers. So thank you very much for your kind attention.
Systems. That is an excellent idea, because IFS brings diversity to agriculture. Similarly, the other ecosystem, we are talking about agro-ecosystem and forest ecosystem. In the forest ecosystems also, those forests, evergreens, semi-evergreens, where the diversity is more, they are more resilient to climate change. Here also in agriculture also, the integrated farming systems, because there also diversity is so much within the IFS that we practice. I mean, you as Director General must have propagated a lot about it. So IFS in agriculture, maintaining diversity in the forest ecosystems, is going to give us a lot more resilience to climate change. That's one thing. And climate change, the trigger point or the identifiable point of climate change is rising temperatures. Rising temperatures would always result in increasing the potential for transpiration. PET will increase, which means the demand component is increasing. As a result of which, the crop growing periods, the length of crop growing periods change across agro-ecosystems. An emphasis on finding out, calculating the LGP or CGP for each of the gram panchayat, or a mandal, or what should I say, hobli. At hobli level, at GP level, how much change is happening in the lengthening or shortening of the CGP has to be done. And then recommend a cropping system with a diversity to suit that CGP. If this is not done, agro-ecosystems cannot have resilience. If we don't maintain the diversity in forest ecosystems, they also will be vulnerable. So therefore, the key point to take home is biodiversity has to be maintained at all levels of economic activity. Why I said this is, my mother, we had only 2.5, 3 acres of land. My father, we had to sustain 4 children. 1966 and 65 and 66 were the worst drought years. When I was about 10 or 11-year-old boy, my mother used to sell only eggs and milk and ghee and butter, because crops in that 3-acre land had totally failed. Not for 1 year, for 3 consecutive years. So therefore, as I mentioned, I'm repeating only, that integrated farming systems, where all 4 components are part of it, would give resilience to whatever climate change that could happen.
Absolutely.
Thank you very much.
You said it, and that's the resilience. Thank you.
If anybody else, yeah, please.
No, no.
In our UG time, we used to write Ayappan sir, Ayappan sir.
No, please, thank you.
And it's really an honor to be here listening to you. You took a whole tour of BS Agriculture, MS Agriculture in your presentation. Thank you for briefing. I think it's beyond that.
No, thank you.
Sure. Sir, my question is that we have good technologies in the universities and also from the IITs or from the companies, but there is a huge gap between the lab to land, and it is very difficult to convince the farmer. So, because I have conducted research in aerobic rice, it's difficult for me to convince my own father to go for aerobic rice rather than puddling condition. He just says water is available, it is easy, and weed problem is major in aerobic rice, but that can be solved by using puddling. So, how can we bridge this difference is my first question. The second one is it a time for us to go for resurrection plants rather than just going for under potential crops or just going for millets? Because millets are very good, but they cannot bring us food security. So can we go for resurrection plants is my question.
Thank you very much. Very briefly, see, one is, we have a lot of models available in the universities, in the research institutes, everything, it's fine. So, but please appreciate, any of us, would take time to change. I know when we have been, because agriculture, as you said, people say that, for example, my father was doing differently, my grandfather was doing earlier. He was, so what is new in agriculture? So that's the normal perception. So when we try to, for example, she talked of aerobic rice. That's where you don't need so much water. There are many advantages. Now, another question is, what is available? Why are we preventing? These kinds of, so it depends on the situation. And then there are so many models available. At the same time, this country, as I said, has so much of variation. In a village, there is not even in a small village, it's not single crop. In a way, it's good because the diversity is maintained. Otherwise, pests would have taken on the whole thing. In fact, where people tell us, two brothers do not plant the same crop. Many times we say it's good. He does it. Otherwise, we have seen people in China, 500 acres, it's only a single paddy. If one pest comes, the whole thing is there. So that's the diversity that we have. So when we standardize the technology, we do it for a particular single crop, single situation, not. So which has to be scaled up much. Now scaling up is not with research institutes or the universities do not have that capacity to scale up. People, ask us, all these, fine farm demonstrations, show us in 1,000 acres how it can be done. Then we'll all take to it. Now, that's where is the gap. That's what we have been telling the government, that we do not have that capacity as researchers. But from development, can you join hands? So once people see in 1,000 acres, anybody would take it. Okay. Second thing is, these orphan crops, sometimes we also, of course, I know this is being recorded, I have been told already. But the point is, millet's good, everything is good. But, there is a balance in any crop, cultivation. It cannot be, however good it is, it cannot be single crop. It has to be, because our basic food is from rice, wheat, bulk, maize and so on. So we cannot ignore it. So this has to be, I won't say much in this because, okay, thank you very much.
So, sir is our former chairman. So we have worked under with sir, and we are really proud of you, sir. So having this much, sir was ICR DG and presently chairman for NABL, National Accreditation Board of Laboratories. Sir is a simple person, he won't accept. all those things. That's what we actually made him to occupy the chair for this session. Thank you very much, sir, your inspiring talk. And I request Madam to present certificate of appreciation for this wonderful talk. We thank Professor Kstacademy Madam. Madam was also a former member of KSTA. I request Ramesh sir to present a plant and certificate of appreciation as token of our respect. Thank you very much, Madam, for chairing this session. And I request Ramesh sir to present a plant and also a certificate of appreciation to Dr. Karthik B.S. for co-chairing this session. Now we have 40 minutes. I request all of you please assemble back 30 minutes lunch break and assemble back, and those who wanted to register for the paper presentation, so please register in the reception counter, and I request all of you please assemble back at 2:40. Sir.
Most of the work which I will be presenting, it is not a work done by me, honestly speaking. Basically, a drone is an evolving field. I have collected a lot of materials in the internet, and I am presenting you before that. There are a lot of copyrights involved, so I would like to emphasize here that, again, it's a collection of materials from various sources in order to popularize the drone. With that intention, I have taken all these materials from the various sources. So, you are aware, 1972, July was the beginning of the era, wherein almost from 700 to 800 kilometers, you are able to observe the Earth without touching the object. That was the starting point, 1972, wherein the USA launched their first satellite called as Landsat-1. And during that time, the spatial resolution of the satellite was something like 80 meters. That means any object which are bigger than 80 meters can be seen from the camera which are put on the satellite about 800 kilometers. Today, the same technology, you are able to get 25 centimeters. Imagine the kind of a drastic changes in the technology which has happened from 1972 as on maybe 2023. Maybe even the previous year itself, it was 25 centimeters. Okay? Of course, the satellite gave a big boost for mapping of the entire state, entire country, the entire world. And today, satellite forms one of the most important components for monitoring of our natural resources in terms of the climate change, climate monitoring, the climate management, and so on. In between, of course, the aerial photography, of course, it has been used from the World War I, but for really observing the Earth, it was used from 1950 onwards. But using the aerial photography, both high altitude or a low altitude, certainly for a specific area, it was very good. But unfortunately, there were a lot of regulations were involved. That is the reason only for few cities the aerial mapping was done, and maybe some other priority areas. But the technology is today, along with the remote sensing, let me tell you, along with the remote sensing, the drone is going to play a major role. It's a nascent field. I'm sure in the years to come, the drones are going to play an important role in various applications. It could be the climate change, it could be the monitoring of various climate, the causes which happens actually on the earth, or monitoring of our natural resources, or the urban areas, or for the environment, you name anything. The imaginations are the limitations in the application of drone today, along with the, the remote sensing. Only we need to prioritize which one to be used, which I will come to that later actually. What is drone? You may ask me. Drone, everybody talks actually. What is drone? Anybody can answer without seeing this? That's why I said without seeing this. Yeah. The most important thing is actually drone is basically an abbreviation. In fact, really it is called actually unmanned aerial vehicle or unmanned aerial systems. Okay, but usually from 1940 onwards, it is being said actually the drone, and they've also coined it's a dynamic remotely operated navigation equipment. That is the drone. But in real term, scientific term, it is the UAV, UAS, truly speaking, unmanned aerial systems, because it is not just only the vehicle, it has got several integrated components. That is why it is called as UAS, not UAS, America. This is unmanned aerial systems. Okay? So it's basically a robot, a flying miniature robot you can call it actually. Or it can be also called as an automatic pilot aircraft. But all that today is being promoted as unmanned aerial systems. Okay? And the technology is growing. Why the drone, although it was popularized from 1940 onward, it has not grown because there are a lot of regulations. Because the drone also occupies the aerospace, aircraft space. So there are a lot of restrictions. Fortunately, from 2021 onwards, the government of India through DGCA, they have liberalized the policy. 90% today, it is open for flying the drone up to an height of 400 feet, 120 meters, in the green zone. Again, they have classified into three major areas: the red zone, the air, wherever actually our airports, or strategic points, military establishment. Except that they are within 5 kilometers, it is called the red zone. There also it can be flown, but with the approval of the government. Then the second is called the yellow zone, from 5 to 12 kilometers. There also there are a lot of restrictions. It has to be flown only with the approval of Government of India. The third category is called the green zone. 90% of the area falls under the green zone, where you can fly the drone up to 400 feet, not beyond that. So from 2021 onwards, the drones, the use of drones for different applications have taken up. But still, we are still young in this field. Although the applications are many and diverse, and it has been proved beyond doubt, but the use of drone till today in India is in a nascent stage, unlike in many other countries. Now slowly, India is picking up. The Honorable Prime Minister is giving a lot of importance for the drone. In fact, it has been forecasted that by 2025, India will be the important global market for drone, going to be third largest market for drone in India. And by 2030, it has been emphasized that actually, we are going to be the global drone hub in India for the world. Okay, that is the kind of vision it is being expected for the drone. Okay, so with this actually, I see this, no doubt, as I said, the flying high in the sky, similar to the the satellite operates anywhere between 600 to 800 kilometers, while the drone maybe around, it can be from 5 feet right up to the 400 feet. Imagine the kind of variability you can have in the drone. Okay? Like a satellite, it has various components for flying. It is like an aircraft. It's a miniature aircraft. That's why it is called actually unmanned aerial system or unmanned aircraft system. It will have most of the structures and the principle of the aerodynamics, which I will not get into that because I have to come to the climate change. Okay? See, the satellite and the drones have to be used in conjunction because it has certain capability, while this also has a certain capability. Depending on the intended applications, we can always choose whether we can go for drone or for the satellite or in conjunction with the both, because the drone provides like a what you see through your eyes. It's a ground observation it can give you, while the satellite, since it is orbiting at 600 to 700 kilometers, there could be some variation. There could be earth curvature effect and so on, while in the drone such things you don't see it. That's the reason actually, see, the flexibility is high in drone. Whenever you want, you can fly the drone. The satellite is not like that. You have flown once, it will have a lifespan of 3 to 5 years or 6 years, depending on it has been manufactured by the respective space agency. So we don't have the flexibility in case of satellite, while the drone you can have the flexibility. Cloud dependence. When there is a cloud, you can still fly the drone. But satellite, of course, it observes the earth, but due to the cloud, you will not able to see the information on the earth. So if it is too rainy or windy, even the drone cannot be operated. Okay? Then it also depends on various other conditions. In the drone, basically you require an operator. Pilotless. On the vehicle it's a pilotless, but on the ground you need to have a pilot. Payload, you can always change whichever the payload you would like to have on the drone. While in the satellite, once it has launched, there's launch. We cannot change the payload. Legislation, highly restrictive for the drone. While the satellite can cover the entire world, there is no restriction actually. And data update, constantly you can keep on doing it with the drone. This all depends on you, how frequently you want to fly the area. And working time is very short in case of drone, because the battery today, it can only come for about 10 to 15 minutes for a bigger one, and maybe for the better one actually it may come to about 1 hour or so. While the satellite, it is not like that. It will work for until it has a lifespan of say whichever the years actually it has. Now, as I said, the drone is almost like an aircraft, but pilotless. But the pilot will be working from the ground control station, and it will be linked to the drone through Wi-Fi or through other wireless mechanism. We can always transmit to the drone. We can manually control the drone or automatic. Today, AI is revolutionizing the drone applications. You can really plan in all respects through the AI. In fact, you can also count number of pomegranates using the drone. And even the status of the pomegranate can be assessed through the use of AI. And the drone can do itself the entire planning. Once if you give the 4 coordinates on all the 4 sides, it automatically does the entire planning and covers the entire area, based on the battery life. So, in a way, I say it's an aircraft which is there. You are, the pilots, and then with the ground control, we need to control through the ground, and we may have to make the analysis in the wherever it is required. Of course, drone also there are many types actually. In fact, some people say it only works for 10 minutes. No, some actually work for 10 to 15 minutes, some will work for 1 hour and all, that depending on the type of drone. Like it's a fixed wing, it can even go for one hour. It is very useful for studying the various applications, particularly for the climate change, for the surveillance, for the environmental monitoring, which I will come to that later. The rotary wing, again here actually there will be 4 arms. It could be 4, it could be 6, it could be 8, depending on the weight of the payload. And there is also the third category called hybrid. Hybrid is actually, it will have both of these. This requires some kind of a ground for flying, like a landing space actually for the aircraft. Similarly, like this actually, it requires some kind of a runway, small runway. While this actually can vertically take off and, and land also. Vertically take off and vertically land. This hybrid, it acts like both fixed wing as well as the rotary wing, so that it can vertically take off and horizontally go like a fixed wing. It has both advantages, and that is going to be the future in the coming years, particularly if you want to transport the medicines, or if you want to really land in some place where it has been flooded due to the climate effect. And in fact, NAL is working on this. Very soon I think they will be successful. Even the very fixed wing also, NAL has recently successfully launched it. Of course, our company is also quite very good in developing the rotary wing, Kstacopter or Kstacopter, all that actually our multiplex is developing. So drone applications, as I said, our imagination are the limitations in the drone applications. It could be used in many applications, particularly in the field of agriculture, which I will come to that later actually. Because today the climate is influencing largely on the agriculture. That's why I want to focus on the agriculture rather than other many things. Then environmental conservation. Then disaster management. Particularly in the disaster management, you would have seen actually 2 years back or 3 years back, there was a heavy floods, landslides, where the drone was used extensively in Karnataka and Kerala for mapping the affected areas. Very conveniently and real time, near real time. Real time or near real time. Bangalore, yes. Thermal imaging was used actually for the drone based. So in this way, it could be used in many aspects, even the healthcare, transport of medicine, spraying of infection, the disinfections. Even during the COVID time in Bangalore, the drone was used for disinfection. And geospatial mapping. As I said, the remote sensing, if you want to use for a wider area, maybe the first class you can go for the satellite data. Wherever there are hot spots, you can always go with the drone, so that you get a more detail. The drone is like what you are seeing. It's a ground observation almost. In fact, the entire country, the government of India, under a program called Swamitva, they are going to distribute the property IDs for all the villages. Now the few villages have already started, few states have already started. In fact, Karnataka is also included in that. They are using the drone for providing the property ID card. Of course, for all that, not only property ID card, that data could be used for multi-purpose. The same data could be used for your planning, your water lines, the sewage line, electrical line, telephone line, all that for entire network it could be used actually. The biggest advantage of this data is that actually the same data could be used for multiple applications. Okay? A typical drone image. Look at this, like what you see through your eyes. The same way you could able to see this. In fact, as I said, I have taken from the internet. It is not my work actually. Okay? Look at you can get exactly 3 dimensions with centimeter accuracy with the drone, using the different kinds of payloads. Whatever the kinds of payloads you use in satellite, it's also possible to use except the passive remote sensing sensors. Because passive remote sensing sensors, they provide a wide actually the spatial resolutions. So look at how nicely the coastal area could be mapped. So the biggest advantage of drones, I'm sure you will be able to tell now actually. Okay, one is the cheap and cost effective. Drone, you know, depending on the type of drone, it may cost anywhere between 4 to 6 or 10 lakhs. Even each farmer can afford today if he has a large chunk of land. Okay. Second, high spatial resolution. In terms of centimeter, one can able to get from the drone. 5 centimeter, 4 centimeter, 10 centimeter, depending on your requirement, depending on the height of flying the drone. As I said, you can fly from, say, just 3 feet to maybe around 400 feet as per the law. Okay? Easier to deploy. You know, the drone pilots, just maybe about a week training is enough, as per the government regulations section. You can able to fly. A lot of people, they take the drone for, you know, just for enjoyment. Marriage. Precision, ease, and flexibility is extremely good. And no hindrance from clouds. As I said, even without clouds, if you want to do the crop spraying, if there are diseases to the crop, you can still do it. Only thing is, it's not be too windy. A great tool for surveillance. In fact, you can do the surveillance anywhere. Even a danger area, yes, you can use the drone. Volcanoes, you can use. If it's a dirty area, you know, the sewage related things, or the waste, the Bangalore waste, if you want to really dump in some place, even the identification of the area, transportation of that, all that could be done actually. And geofencing, if you say the drone should not enter into towards the Vidhan Saudha area, it will not enter it. Today, that is the level of AI, artificial intelligence, could be used for defining. There is what is called flight control inside the drone. It is like an art in case of drone. You can always define what Ashok Reddy wants, that it should not enter to my feet. Yes, you can do the geofencing. Or Ashok Reddy feels that a lot of animals enter into the field. You can always, you know, identify even the animals. As Dr. Ganesh said actually, like, you know, animals could be identified, human beings could be identified, of course using a different spectral band, which I have an image, I'll show it to you, which again I have copied from somewhere. So the impact of climate change on agriculture. Today, you are aware the global warming is happening. You are aware of the decline in productivity. See, today, actually, like in Mandya, Mysore, Bellary, there is a lot of decline in productivity. Or, you know, my father used to grow 100 tons of sugarcane. Today, it is difficult to get to 40 to 50 tons of sugarcane. Paddy, the same thing. The degradation of the land, loss of natural resources. Slowly, we are losing a lot of natural resources. Decline of biodiversity, the deforestation, forest fires, pests and diseases are increasing. Today, a lot of crops, pests and diseases are increasing every day. With year after year, there are new, you know, pests, new diseases are coming up. So, there are many problems today. In fact, today, India is the largest country in terms of global population. We have already reached 144 crores actually, out of 808.4 crores as on today's statistics. Nearly 17.6% of the population lives in our own country. We need food. Although we have achieved a good success in terms of agriculture, 330 million tons of production, but still by 2050, our population is going to be almost 167 to 180, 168 crores, which requires additional food of nearly 250 million tons. This requires, I'm sure our horticulture person will agree, that, you know, we need to really see that actually our agriculture is being protected, and that requires the study of the climate. And whatever the effect of climate which is happening on the agriculture, we need to tackle it. That's where a lot of mechanization is required. Drone is one part. There are many other things, mechanizations are involved. Even the government of India has given a lot of subsidy for these areas, for the mechanization of various equipments, technologies, and so on. So one of the things which could be addressed in the agriculture field is the use of drone for addressing our agriculture production, the reduction in diseases, increasing the yield, the water management, the percolation of the chemicals into the ground, and so on. So today, as I said, drone, we can use all kinds of sensors which we have been using it onto the satellite, except the passive sensors. That means beyond actually the microwave related things. And I will not get into the electromagnetic spectrum. I'm sure some of you may be aware, or somebody else might cover on that. So a camera, in fact, camera is the best one, so that what you see can be seen on the field. But for identification of the different crops, and also identification of the health of the crop, and also the water status, it is always better to go for the multispectral band. And through the fixed wing flying drones, you can map almost 1 hour continuously. In fact, the government of India, now they want to use the drone for assessing the crop status across the country. In fact, very recently the expression of interest was called by the Ministry of Agriculture and Farmers Welfare. I think tomorrow, as I said, the drone has a wonderful application, but the usage of drone for our application still is in a nascent phase. Only from the last 2-3 years we have been working on this, and the next coming years, I'm sure there is going to be a big revolution in the application, big revolution in data analysis, big revolution in the improvement of the sensors and the technology, particularly the artificial intelligence, the other kind of ML and so on actually. So even the thermosensor, the invisible thing can be seen, visible thing can be made through these thermal sensors. So basically here we define what I want. If there is a due to climate change is related to what, whether it's agriculture, whether it's related to pollution, whether it's a degradation of forest, or forest fire, or drought, flood. So depending on the kind of application, we can define what is that I want the use case in drone. And accordingly, the drone technology could be redesigned, reshaped, and we do a lot of processing. In fact, the data processing about 3 years back was an Herculean task, was really an Herculean task. Today, a lot of simplifications have been made, a lot of softwares have been developed, which can be done on board. Forget about actually on the lab. On board can be done actually, even the data stitching can be done, mosaicing can be done, and to some extent maybe the analysis of course which maybe has to be done on the field, which requires some kind of a human intervention, because human cannot be removed at any stage. Ultimately, our brain is also equally important in all our technological developments. Okay, there are many softwares are available, but depending on the kind of the application you are trying to use, particularly for the climate change, if you want to study the environmental aspect, you need to have a different kind of the softwares. So what basically we do for the climate change or for any of the applications, of course, one application really complements the other application in terms of deriving the information. Like you acquire the images from the satellite, from the drone, feature registration, it can be done there itself. In fact, with RTK kind of a GPS, you can get a centimeter accuracy from this. Centimeter. That's why actually they can able to give the property IDs in the villages using the drone, and transfer estimation, blending of the image composition, and do the panorama and for the entire area which you did, because while taking the photograph, it takes n number of photographs. All that has to be stitched. It is not just simple. Hundreds, thousands of photographs are being taken. That has to be stitched. That's why actually, in a drone, you have to take almost 60 to 70% overlap. Side overlap, front overlap, depending on the type of applications. Okay. See, for example, agriculture. As I said, the crop health, how do we manage it? Measure that using the sensors, using the drone and satellite data. For example, if you want to do it for a very larger area, I don't recommend the drone. For a smaller area, you can always use the drone for understanding how much area of crop is being grown, what is the status of crop in terms of the water stress, in terms of pests and diseases, in terms of weeds, in terms of lack of micronutrients, or in terms of high temperature. Because today the climate change is more affecting on our food and the agriculture, which is the backbone of our country. That's where we need to give a lot of importance for that. See, one of the techniques is called actually normalized difference vegetation index. There are many, many things. There are many vegetation indices are available. Red vegetation indices. There are at least 6-7 vegetation indices actually which I have the record with me. So with that actually we can assess what is the status of crop. How much area is being covered? How much area has been stressed out, either due to the lack of micronutrients, the water, and so on, because the reflection of the light which is coming from the sun depends on the health of the crop, that is basically the chlorophyll. And particularly the two reasons, red and infrared, plays an important role. It's only for the vegetation. For water, it may be different. Okay? So there are, as I said, there are many, many indices are available, which I don't want to get into that. But what I would like to say that today, there are many, many techniques are available to assess the crop health, crop status. In that way, how much would be productivity? Well in advance, you can be able to tell even the yield. Of course, with some ground verifications. Some crop cutting experiments still required actually for assessing the field. Okay, see the cut. See, it is a healthy crop. It looks green. See, this is actually stressed crop. You can see this. Unhealthy crop, the red one. Bare soil, exposed soil, pure red. See, this all comes with a few ground truth, survey, which we feed into the AI-based kind of a software. AI-based, basically what it does is basically on the data. It classifies. Larger the data, accuracy is better. The similar concept is also applied here, I think. See, in fact, one of the biggest applications of drone in India is the crop spraying. Today, our crops are affected due to the lot of climatic variations. The pests and diseases are increasing, pathogens, weeds. There are so many other issues. Okay, you can use the drone. You can spray the say pesticides, herbicides, insecticides, micronutrients, and all that using a separate payload in it, which is not possible from the satellite. As Dr. Ganesh Raj was telling me earlier, they used to use the helicopter. Helicopter also was from a very height. This is actually from a low height, 6 to 7 feet. In fact, today is one of the major work which is happening in the country, because due to climate change, there are a lot of diseases, pest attacks are happening, particularly even in Karnataka, Rajasthan, and so many other places. And here actually, you don't require anybody to be there. A pilot will be at the distance. He can, autonomously control the entire operations, so that you are not exposed directly into the pesticide. It doesn't affect you, and it can cover within 7 minutes. You can cover 1 acre. And since it is spraying from 6 feet, because of the vibration, the molecules will enter inside. and both on the top as well as to the inside to the vegetations. That's why it is more effective. And you can do uniform crop spraying, or rate of variability is also possible with a large chunk of area. The diseases are actually depends on moderate, the more effect or the less effect, depending on that. We can even identify. Of course, we have not done the work, but today globally there are a lot of work is happening which can be done. I'm sure India also will take up this work in the coming years. See, even if it is a different topography, then drone can adjust depending on the topography and go on its changing its height. Correct? If there is an obstacle, it stops. It doesn't move. So that the danger of obstacle also can be avoided. There are different sensors are available for that. See, for example, weeds. You have shown the crop in a row wise. In between, there are a lot of weeds which have come up. You can identify. Even if it is a stressed crop, you can identify through this. So the crop spraying, as I said, it is one of the important aspects, particularly for agriculture. And simple reason is that the climate change is bringing undesirable changes in terms of various diseases, the floods, the droughts, and many other aspects, which can be, monitored through this. In fact, I just show you an image. Now, which multiplex is doing it actually. This is the crop spraying for field crops, orchards, for many of the crops. We can use this. There are a lot of effort is going on standardization of this, the spreading of this pesticide and insecticides and all that. The government of India has already brought out a broader guidelines on the standard operating procedures. I'm very happy to mention that many of the agriculture universities, including our own agriculture universities in Bangalore, they are working on for different crops. What should be the height of spraying? What should be the concentration? Because here a lot of saving can be made even in use of the chemicals. You don't have to, you use a big amount of chemicals here. Water can be saved. Maybe 1 to 9% actually is quite enough. Okay, you can go back to the other one. So this is our multiplex, which is a company which is situated in Bangalore. Multiplex is actually a fertilizer company. It's a very big company. They have a presence across the country. Of course, even in the some of the South Asian countries, they have a presence actually, and they have taken up this drone. And so far, they have built already 300 drones. And there is a requirement actually in the country for another 500,000 drones. In fact, many countries they will ask, provide us the drones. There's going to be a big market. In fact, just about recently it was only about 30-40 crores for the drone sale, but we expect almost 1 billion in next 3 to 4 years. If you look at the drone industry, in 2022, it was $22 billion. By 2030, it is going to be $77 billion industry in the coming years. That is the level of, the market you are going to have it and the impact you are going to have. Even the people are using this drone even for identification of the biodiversity. The whales in the ocean, they can be mapped using this because the whales population due to the climatic factors are changing. You can even study the biology of the whales through the whales, the volcanoes, the Antarctic glaciers. All that could be done in order to understand the various climatic impacts on our resources. Okay, I will not get into that. Okay, this is, for example, flooding. You know, Kurg, you would have somebody from Kurg. You know, the drone was the best technology to be used during the flooding. In fact, a lot of people, before the government approached, they published actually, these are the areas affected. The landslides, the drought. In fact, I was given an assignment about in 2018 to find out actually how many drones are required for mapping the area being cropped actually in the state. That is even the Jnana Ayoga has recommended the use of drone in Karnataka, and the government of India, immense importance is given to the use of drone. You will come to know in another few years the kind of application in conjunction with satellite data, how we are going to use this for our monitoring of our natural resources, the climate, and various other, even the urban studies and so on. Of course, as I said, see, none of it belongs to my proprietary images. It's all I have collected from the internet. I'm stressing that once again, the forest fire. You know, again, you have seen very recently, they all attribute to the climate change. Even in US, the entire city was wiped, entire village was wiped out. Australia, yes. Even our own, you know, our Western Ghats, they experience actually the forest fire, particularly. In fact, this year we should be very, very careful after February, because very less rainfall, even our Western Ghats. And of course, human intervention also is there actually. Spark. See, what Dr. Ganesh was mentioning, the invisible thing can be made to see visible through these thermal sensors. Like you can identify the people, if it is a, you know, if it is a heavy floods, people are, you know, somewhere actually in the in an isolated place. Safety, how do you identify them? Because the thermal temperature can able to give the, you know, the identification of maybe an animal like the tiger, or it could be anything actually, or even the man, human being, and even the animal. So if the animals are approaching appropriately farmed, all that could be identified from this. And of course, you can also use actually what is another called LiDAR, light detection and ranging, which can give you the accurate height information, the height of the building, actual shape of the building. Even not only that, even our topography can be seen very nicely with the LiDAR. Three-dimensional view can be seen. Okay, of course, this technology is still in a initial stage, nascent stage. I'm sure a lot of research is happening, little costly, but certainly these are the future technologies. See how the deforestation is better. Many of the climate change are attributed because of the human intervention. Of course, we are overpopulated. Our economy depends on our natural resources. Yeah? This may be very basic. I mean, I said actually, I have taken mining. Of course, right, once again. See, of course, this also is some other country. You know, the actual virgin forest could be mapped. The mangroves could be mapped. Actual coastal shoreline could be mapped. Because today, one of the important impact of the climate change is the effect on the shoreline. There is an increase of the sea level rise due to the increase in temperature and melting of the sea ice in the Arctic and Antarctic ice, which needs the expansion, large amount of water being flown, and those which are in low-lying areas, particularly in the coastal area, again, they are going to face a lot of problems, particularly the low-lying countries. Even transportation. Today, for example, Bangalore, from one place to another place, you require 1 to 2 hours. You want to go to my office, I have an urgent work, I may require another 1.5 hours to go there actually. See, so much pollution, which is again adding to the climate change, the carbon dioxide emission. And that's where this drone in the coming years, now today we don't have a permission, but US is working out. When Amazon actually was really, you know, at some point of a time they were taken up, but now it has been stopped actually. The transportation of the goat in terms of the carbon emission can be reduced with this kind of facilities. In fact, in the drone also there are different kinds of a drone. It's called nano drone, micro small, medium, yes, swarming, bigger ones, swarm drones, lighting drones, you know, many. I am not touching all those things because of lack of time. And since I am also concentrating on climatic change, you can even assess the air pollution. Not the systematic entire view. The samples could be taken from different places and analyzed. Even the water samples could be analyzed using, because all the dangerous area where we cannot go, the drone can go. That's where actually the drone is revolutionizing, particularly the local applications. Regional, of course, regional and for a global, still I feel the satellite is the only best technology today is available for us. So today, I don't foresee, but tomorrow and day after tomorrow, not maybe 1 or 2 years actually afterwards, like a cell phone, like a computer, the drone is going to play in all our daily activities. That is the kind of a future vision which we are expecting from this. With this, in fact, I just want to say, since my company, I represent a company, M-Drone, Multiplex Drone is one of the largest fertilizer company. Now they're also manufacturing the drone and also involved in cross spraying. Nearly more than 20,000 acres are being covered in the last 2 years. Okay, and also ours is a certified BGC certified training center, which is there in Nelamangala, which falls in the yellow zone. Okay. So I'm very thankful to my company, Multiplex Drone Private Limited, and also I'm very thankful to Dr. Ramesh, and I've given an opportunity to present before Ganesh Raj. He was my good colleague, and also I learned remote sensing from him, because when I entered the ISRO, I had no background in remote sensing, because ISRO never asked for whether you know remote sensing, but what they want actually, how much you are good in your own subject, so that they will teach us how your subject could be used using remote sensing applications. That's what happened, and I learned from him. And one more, Mr. Manabalan, who was also the senior scientist, and also Dr. Ashok Reddy, my colleague, and Al Medingdal was my colleague, and all of them. I'm very thankful to all the Karnataka Science and Technology Academy, Srinivas, Anand, and for all of them. And also thank the chairman and the co-chairman. Very nice. If you have any few questions, about 3-4 questions actually, you can ask me, because I'm also in a hurry. There's a lot of calls, a few calls were coming.
Thank you, Dr. Gaurani, for a very nice presentation. And if you have any quick questions, you can ask, so we can clarify.
Limitations, actually our limitations, we have to know about how to use the drone, number one. Number two, still today, even now actually, the drone application for a smaller area is little expensive. I must accept that. Small area will cover very large area. See, if you want to know the forest cover of Karnataka, you can use. You want to know, I want to know more details in a particular area. Yes. Hotspot area. If there is a flood, there is no other go, because the satellite you may not get the satellite data because of the cloud cover, or it may not be in your vicinity.
It is like more like ground truth.
Ground truth.
The satellite data will be more detailed about the specific area. This drone is ground truth. Any other question?
Yeah. Training actually, see, this is the biggest thing. Most of the training centers, there are 68 pilot training centers in India. They charge anywhere between 25,000 to 50,000 rupees. For students also, they give concession, somewhere about 30,000 rupees. This is one aspect. The second aspect is that today in the country, we have several skill development councils, like Agriculture Skill Council. Today they have identified Kisan drone as one of the important things, because the Honorable Prime Minister has announced to provide 15,000 drones in the next 2.5 years for 15,000 women help groups in the country, self-help groups. And for operating a drone, you require 2 people. That's basically about 30,000 drones. And tomorrow we expect that immediately in another 2 years, 1 lakh pilots. And in the next 2 to 3 years, maybe even 5 lakh pilots. Because the demand is going up. Since I am in the field, I know that. Just about a year, 6 months back, yes, there was not much. Today, the government of India is giving a lot of emphasis for the drone, and the Prime Minister envisaged that he would like to see the drone on every farm by 2030. That is the kind of vision they have actually in the government of India.
Any other question? Very good. Free of cost, no?
In fact, actually, I tell you, today the pilots actually, just SLC pass or PUC pass enough or diploma, they get 25,000 rupees easily to start with that. See, even today computer engineers may not get 25,000. You see, some of them, not all of them. So there is a good demand, and once if the pilot becomes actually, if he trained well, and if he has been successful, see the industry particularly, unlike government where we worry about education, we worry about the protocols and all that. See, companies are not like that. If he is a diploma holder, he can become the chairman of a big IT company. There is nothing wrong with that. PhDs is only for a namesake we have. Huh?
Skill is important. That's
Skill is more important rather than anything. That's why the skill councils of the Agricultural Skill Council of India, they have worked out the Kisan drone free of cost. They are going to do it for, it's going to be 2 months training program. Theory and lot of importance for the practical. Even the Electronic Skill Council of India, they are also the drone service technicians. They are again is a 500 hours program. That also they are going to planning, and also the drone manufacturing and service. There is also a sector skill council of electronics. They are planning. In fact, actually, I am in the negotiation with them. But sometimes the government you give very less money, which is difficult to run through the government. Yeah.
your question, yeah, please.
Huh? Weight of the drone. See, I said actually I did not get into that. So 250 gram to 2 kg, 2 kg to 25 kg, 25 kg to 50 kg, 50 kg to 150 kg, depending on the weight. They are called nano, micro, small, medium, and large. And beyond that, of course, today the DGCA is silent on that, Civil Aviation Ministry. Tomorrow the passenger drone also might come actually. Plans are there. Vertical landing. Yeah, what they are planning. But it's not interfere in the airspace. See, this is where actually height has been fixed actually. Okay? Like for example, if you are for R&D, you don't have to take any permission. You can do it actually up to 50 meters. If it is for a commercial purpose, you can maximum go up to 400 feet. And that too, there's a larger drone, I said actually. The smaller drone may be 50 feet, 100 feet. No, it's not allowed. See, because illegal.
No, they were not knowing. There are many people. What it becomes available easily everybody. What question is
no, that's why actually in the drone there is a component called geofencing, where it has been through software we can do it actually, where it's not supposed to cross the boundaries which are strategically marked. See, it is like this. Like your question is that in Vidhan Sabha scene means actually it is illegal. I said up to 400 feet, na? Recurrent and all three. There's nobody permission. That's why I said in the green zone, you don't require any permission. In fact, actually, I said, na, my company has covered almost 22,000 crops spraying, including the arecanut. Arecanut is the tallest, 30 feet, 35 feet actually, coconut, orchards. Okay, and field crops like actually paddy, all that actually, just 6 feet to 7 feet is fine.
Yeah, that's not a problem at all.
regulation, that's why I said, see, the drone till 2021, it was just impossible to get the permission so easily. You know, in 2018-19, I was given the responsibility to the crop mapping in Averi Taluk. We wrote to everybody, yeah, even from the highest authority, nobody replied. That means, so you refer the DGCA rule 2021, okay? You will get all that. In fact, Dr. Ramesh said actually he is going to organize that, where actually I will be talking on the DGCA rules. Like for example, yes. In fact, that was not allowed earlier. See, even the DC, even the Chief Secretary was not allowed to give the permission. That's what I said in 2018 when we wanted to do it in Averi. Even the Chief Secretary was not supposed to permit. It is only by the DGCA. It is the federal government responsibility. Yeah, I have to go. Actually. Thank you. Thank you very much. I think. See, just wait for a few 2-3 months. They will come to you. Okay? They will come to you.
Can have one drone, no problem. Cost is coming.
No, Government of India, the Government of India provides subsidy, 100% subsidy to agriculture universities, KVKs, and the FEOs. FEOs 100% subsidy for them up to 10 lakhs for the universities, research organizations, KVKs, and 75% subsidy for the FEOs. For the women entrepreneurs, 50% subsidy. For the agriculture graduates, 40% subsidy. And for other actually, this is one. Correct. Second thing actually, the government will come to you in another 2 months. You wait actually. I don't want to tell that because it's still in the pre-plan. It's evolving stage. In 2 to 3 months, it will come to your Grama Panchayat. And the cost, you see, I said, the cell phone was cost, one mobile call in 2000 I had actually mobile phone. It was costing for 1 minute 6 rupees. Today it is free. See, as the technology evolves, of course, the drone cannot be free. It will be. See, what you do actually, Ganesh Raj is more educated than me. He will answer. I have some other meeting actually. Online meeting is there actually. I have to go.
Please, yeah.
Last question. And good afternoon.
Sir, in future, if this will happen, it will be common sense. So it can't be misused. Like everyone can transport anything.
No. There is a restriction of strategic areas.
Not basically delivery items,
Delivery of items.
Like yesterday.
No,
Punjab, they found 2.26 kg heroin in the drone. No, I'm telling you, that cannot be totally controlled.
No, very actually. Like for example, whenever you give the blue dot thing, you have to declare what.
No, he still blue dot.
Individual
owning.
Drone
Like I own and I sell something to him.
No, that is not allowed. See, for example, if you are taken for the agricultural purpose, you cannot have it for.
No, there will be some, see, there's a regulation, monitor, there will be, everything will be there. Some things will happen. You can't 100% it will be on. It's very difficult.
Then control we can make. Still, if somebody shoots you, what is that we can do? All that illegal thing can happen actually. Thank you so much.
I think Gowda is in a hurry. So we thank him with a big applause. All the best. Thank you.
Thank you very much, sir, for your interactive and interesting lecture.
My only emphasis
I request.
Please don't use this, whatever the pictures which are shown. It is all actually copyright actually. That's the reason.
I request Ganesh Raj sir to present a plant as a token of our respect. I request Dr. Ramesh sir to present a plant into Ganesh Raj sir as a token of respect. I request Ramesh sir to present Dr. Harish sir to plant as a token of respect. Without a tea break, we will continue this another last talk, and then we will have a tea break, and then we can continue with the cultural program after this talk.
presentation ಅದೇ ಕ್ಲೈಮೇಟ್ ಚೇಂಜ್ ಇದೆ ನೋಡಿ, ಹಾಕ್ಕೊಂಡ್ರ ಮೇಲೆ ಇದೆ ಮೇಲೆ ಶ್ರೀನಿವಾಸ ಇಲ್ಲ ನಾನೇ ಶುರು ಮಾಡ್ಬಿಡ್ಲ? ಇಲ್ಲ ಇಲ್ಲ
So I request all the participants, please come front side, and we will start soon. So good afternoon and welcome back once again. I request today's chairperson, Professor Jagdish sir, and Ramkrishna sir and Lingdal sir to please come on to the stage. Today we have Dr. Chandrakant Lingdal sir as a co-chair, Professor Jagdish sir as a chairperson for this session. Dr. Chandrakant Lingdal sir is my teacher in College of Fisheries. I am really happy to introduce him. Dr. Lingdal sir did BFSc, MFSc and PhD from College of Fisheries, Mangalore. Now it is a Karnataka Veterinary, Animal and Fisheries University. He is a recipient of US Gold Medal during PhD program. Worked as research scientist at CSIR and post officer and associate professor. At presently working as associate professor at KVK Ankola, and sir also working as head Fisheries Research and Information Center, Marine at Ankola for the 10 years. So sir also remote sensing expert. He was working before joining that KVK as a scientist at Karnataka State Remote Sensing Application Center. Sir has published several research papers both in national and international journals. With his brief introduction, thank you very much sir for co-chairing this session. I request you to introduce the chairperson of this session. Over to you sir.
Good afternoon to everybody. So let me introduce my chairman, Dr. S.L. Jagdish sir. So Dr. S.L. Jagdish has started his career in 1997 as Assistant Professor of Post-Harvest Technology at KRC College of Horticulture and WS Dharwad since October 2021. He is heading the Regional Horticulture Research and Extension Center, UHS Campus, Bengaluru, as a Associate Director of Research and Extension. Dr. S.L. Jagdish sir has got a postdoctoral fellow from McGill University, Canada in 2007. He has also obtained an additional MSc degree in Bioresources Engineering from McGill University, Canada. Besides, he has got exposure to the international training on food industry, agribusiness in Wageningen University of Netherlands in 2008. Last year, August 2020, he visited Cameroon, Central West Africa as a part of trilateral cooperation, India, Germany and Cameroon project on potato seed tuber production. He has released a jackfruit variety by name Maharaja. He is responsible for training, quality control of branding of jackfruit pepper, Kadamba, released and marketed by Kadamba Sovarda Marketing Society, SC. The product is widely sold across the state. Sir has developed 9 technologies in post-harvest technology in past 10 years. He guided 23 MSc students and 5 PhD students, served on advisory committee more than 70 students. So he handled project valued more than 9 crore and also has associated with international project under Canadian International Development Agency. He published more than 100 research papers and 50 research notes and abstract and 6 books. He is instrumental in establishing Post-Harvest Technology Center at KRC College of Horticulture, Arabami in 2010, Horticulture Produce Processing Center at VHS main campus in 2016. So sir has also got recipient of Best Research Scientist Award from University of Artificial Sciences for year 2018. He has attended many national and international conferences, notably one in the United States and 4 in Canada. So he has got many awards. Notable one is received Best Writers Award from book entitled Modern Cashew Cultivation in Canada from Karnataka Science and Technology Academy, Science Technology Department of the Government of Karnataka, 2012. So this is a brief biodata.
Thank you so much, my dear coach, the presenter of the today's evening, the distinguished dignitaries and the participants. It's indeed an opportunity, great opportunity given by the KSTA to chair this session. In fact, next 2 days, all of you will be learning about the climate change and various aspects related to climate change will be discussed in the national seminar over here. In fact, when we just think about a 1 degree rise in temperature, 2 degrees rise in temperature, or a rise in the sea level, it all sometimes appear as remote issues for most of us. All of us, we feel that they are not very much associated with us. So it is happening around us. In fact, if most of you are from Bangalore, you must have experienced the summer this year. It was very hot, and Bangalore is known as a garden city, and everyone had thought that there is no need for AC in Bangalore, but this summer everyone felt the summer was very hot. And another thing is there is a variation with respect to the rainfall quantum and the distribution, both. So in fact, to just figure out, Bangalore has received record rainfall last year. So average rainfall in Bangalore is 970 millimeter per year, but last year it received more than 1,700 mm. It was really the distribution pattern was also not even, not really as normal. And this year it is just opposite. So June, July, August, which are all the rainy months, we notice a deficit of rain. So this is one part. And another thing is, because of this variation in the temperature and the climate, there is emergence of the diseases, not just in humans, even the plant diseases, animals also. One example that I can make you impress is about the tomato price that has happened this year in the month of August. So it went up to 200 rupees per kg. And after 2 months again it came to less than 8 rupees a kg. So this has happened because of the non-rainy months in which the tomato crop was standing in the field. The rise in temperature has led to the increase in the sucking pests in the field, emergence of the sucking pests in huge population that has led to the transmission of the viral diseases that has caused tomato crop to get affected with the disease and producing no yield, and that is the reason why actually tomato price has gone up to 200 rupees. So in fact a committee had come from Delhi, Central Ministry of Agriculture, and I was also a part of the committee to visualize the situation in tomato growing regions of Karnataka. So these are two examples that I gave about how actually the climate change is not a remote issue, it's affecting all of us. So with this brief introduction about the topic of the day, I would like to introduce the speaker of the evening.
Already done. No,
done.
Already done.
Okay. So then with this, I hand over the mic to the speaker.
Good afternoon to all of you. I'm not sure why I have been called here. I'm not a climate scientist. I'm basically a taxonomist. I love to be a taxonomist as my subject. But fortunately enough, I was in James Cook University at Australia, working on the Great Barrier Reef, on the coral bleaching. And also on the basis of the experiment that we have carried out at Australia, we have developed a regional and research center at Port Blair in Andaman, Coral Reef Research Center. So probably maybe the reason that I've been invited to speak on a subject because I'm from the marine ecosystem studies. That is my primary subject. Friends, it gives me a great pleasure to introduce you three important aspects here. One is the impact, second one is the climate change, and third one is the marine ecosystem. So there are three. I don't want to take a much introductory part of it. Enough has flown in the morning hours. So I'll just directly go into the subject because the time is quite short also. Now I will take you back to 4.6 billion years ago when the Earth was in the molten state. It solidified. I do not want to go into how the origin of the Earth took place, where is the meteorite has joined and collided and formed an Earth, or various theories of Earth formation is there. So I will not go into the detail, but the Earth belongs somewhere around 4.6 billion years ago. It was in a molten state. It solidified. And solidified, there are at that particular time, there was only gases, nitrate, water vapor, carbon dioxide, like that. So this entire thing, the water vapor condensed into what is known as the oceans. So life originated in ocean. The life originated in ocean, and they say that the earliest life formation is in the ocean, the marine ecosystem. Then I will go back to I'll quickly go back. Then a question really arises, whether the Earth has remained same since 4.6 billion years ago. And what was the situation of the Earth at that particular period? Look at this one. The entire Earth, the topmost part is what you call the Earth crust. Then we have got a mantle, then core and other things. The Earth crust is made up of several plates. In fact, it is made up of about 10 or 12 plates. It depends. 157 is the smallest plates if all taken together. Nearly about 157 plates are there. But I do not go into the smaller plates, but there are 10 to 12 plates are there. And this entire Earth is what we call it as the supercontinent, or what is known as the Pangea. The entire Earth is made up of plates, and the entire thing was a single one, that is known as the Pangea, or the supercontinent. That is about 4.6 billion years ago to 3.5 million years ago. So that was the situation at that particular period. Now you know that one, the entire continent was a single unit. Then just like our cell division in the mitosis, one has become two. So do look at this one. This is the Pangea. The Pangea divided into two parts, the northern part and the southern part. The northern part is what you call the Laurasia. The second part is known as the Gondwana. The larger part, the northern part, Laurasia, the plates of the Laurasia differentiated into North and South America. So the north part has become what we call the North and South America. The rest of the world is what we call as the Gondwana line. The India belongs to Gondwana system, Gondwana. So that is about 100 million years ago. Then later, all the plates, smaller plates, started moving in different directions, and that is what we call as continental drift theory or plate tectonic theory. Way back in 1932, Alfred Wegener, one of the greatest scientists, said Earth is made up of plates, started moving in different directions, and the present day continent is mainly because of the movement of these plates. So nobody believed him till 1960. Only in 1960, yes, he was correct. That is what we call the plate tectonics are there. The plates started moving in different directions, form the present day scenario of what we call it as the present day Earth. I'm sorry. present Earth. You can see this one. If you look at particularly Indian map, the India was inside a sea. The sea is what is known as the Tethys Sea. It was once upon a time, 100 million years ago, it was attached with the African continent. Then with the Madagascar, it started moving away from the Madagascar. It started moving over Seychelles. Seychelles is again a small island. And then it moved into the north and northeast and collided with the Asia component, and a new set of mountain was formed. That mountain is what you call the Himalayan mountain. The youngest chain of mountain is the Himalayan mountain that was formed about 10 million years ago. So that is the situation. This is what is known as the continental drift veil. So there was a change at that particular 4.6 billion years ago. When it was in a molten state, it solidified. So climate change is not a new one. Climate change has started already way back in 4.6 billion years ago. And then I will go back again. Life was formed about 350 billion years ago from a single, simple, what you call the protein, by uniting the amino acids. Amino acids joined together to form the protein. And this protein became the nucleic acid, the DNA, RNA. I do not go into the detail about whether the DNA is formed first or the RNA is formed first. So there are various theories are again there. Then ultimately there is an evolution of the life. From a single cell animal, single cell plant into the present day situation, there were 5 extinctions, such extinction. You can see this one. Okay, I'll tell you in the next slide. You can see here, the first extinction takes place at about 440 million years ago. The second one about 374 million years ago. The third one is Permian extinction was 250 million years ago. The fourth one is Jurassic, and the recent one is the Cretaceous. So Earth has 4 extinctions, 5 extinctions already taken place. 1, 2, 3, and 4. In the entire history of the extinction, you can see this one, large number of plants and animals that died. You can see about 95% of the existing were lost. 80% of the existing were lost, or 76% like that one. A large number of plants and animals were lost in the entire course of geological history. This is known as what we call the extinction. So speciation and extinction goes hand in hand. This is one of the important aspects that you have to know. So what we come across during this one, the first extinction, you can see this one, Ordovician or a mass extinction. The first one, what you call the trilobite. The primitive, what is on the arthropods. The primitive arthropods were lost. The second one, look at this one, Devonian extinction. It is known as the age of fishes. Some of the fishes completely lost today, no more available. If you look at the third one, amphibians were lost. The fourth one, the major extinction. This was on the Triassic and Jurassic extinction. It is about what we call the reptiles. The snakes and lizards and crocodiles and turtles were lost in a large scale. And most of these extinctions, you can see, is volcanic activity. It may also due to the flooding, global climate change, and changing in the pH and sea level at the oceans. So these are some of the facts. So that means to say the extinction has taken place, and it is happened the entire geological history. If you look at this particularly, there were 900 species of dinosaurs. 900 species of dinosaurs completely wiped out on the earth. This is during the Cretaceous period, Jurassic period. So you can see the mass extinction. Now what we see today is our what we call it as what we are seeing is today is the 6th extinction. So we are in the process of 6th extinction. So between one extinction to other extinction, from first to second, second to third, third to fourth, and fourth to fifth, there was a huge period of time. But in this particular aspect of it, 6th extinction, the rate of extinction, the rate of loss of plants and animals have increased substantially. You can say that when scientists are estimated 75% of the species inhabiting Earth will go to extinct, will not be available at all for the human being. So this is the situation. We are in the process of extinction. Now, if you look at the sixth extinction, look at this one. Each one is 100 species. The red one is on the verge of extinction. There are large number of plants and animals, amphibians, reptiles, mammals, and various groups are likely to be extinct in the years to come. Or what we call the rate of extinction has substantially increased. You see, 41% of the amphibians are likely to be lost. 26% of the mammals are likely to be lost. 14% of the birds, sharks and rays. Look at the reef, coral reef, and crustaceans. So we are likely to lose large number of plants and animals in the process of time. This is mainly because of the human activity. And also you can see this one, 1 in 10,000. You can see I have given it, 1 in 10,000 are in the verge of extinction, are likely to lose. So this is the situation or the scenario. Now, if you take this one, the date of extinction into one account, are likely to be extinction rate. So you look at this one, before 1600, there were only six animals were lost. If you come to 1900 to 2000, the number of animals and plants are about 63 recorded ones. Now, if all the critically endangered, and the vulnerable is taken, it may lead to 2,200 species are completely likely to be lost in the process. So the rate of extinction is likely to be increased, and this is mainly because the human activity. Mass extinction is caused by man. And this is what we call it as Holocene extinction or Anthropocene extinction. So man is completely involved in losing all the plants and animals on the earth. Now look at this one. There is a human population also. There is a graph showing the human population and the rate of extinction also. The rate of extinction has increased because of the human population. And then you can see 37,400 scientists are involved in this biodiversity crisis. So they are finding out what exactly the reason for loss of life, the loss of human beings, the loss of animals and plants over the earth. This is what is going on in this one. Look at this one. There is a World Wildlife Fund, WWF. They are working upon the vertebrate groups. Look at this one. What was the reason for this extinction? One of the reasons is, you can see, habitat degradation, change in the habitat. So it is about 31%, and 37% is because we are exploiting more than what is needed. 37% is mainly we are losing it, and 7% is mainly because of the climate change. Climate change is also responsible for the loss of lives of this one, and habitat loss and others are there. If you take 100% returns. If you just look at this one, if you take 100 population index in 1970 as 100, now we have come to 62% now. Population has decreased, especially species diversity has come down like anything. Now, whether it may be terrestrial, whether it may be freshwater or marine, all animal species are coming down and down. This is the situation, and this is one part of this one is what we call as the climate change is responsible. Now, this is mainly because of what we call the biodiversity crisis. That's the crisis of the animals and plants. This is normally called it as the biodiversity crisis. This biodiversity crisis is mainly because of the 5 important factors or drivers. The first one is the change in the habit or habitat loss. The loss of habitat is one of the important. The second one is species coming from the outside, invasive alien species. Species are plants and animals coming from the other country. For example, you have heard of lantana. You have heard of Eichhornia. They are not ours. They have come to our place and spoiled the entire scenario. So you can see the lantana throughout India. It has brought as an ornamental plant. Now it has spread throughout because this is a tropical country which is congenial for the plants and animals to survive. So that is how we have come. The third one is we are exploiting more than what is required. That is what we call the overexploitation. The fourth one is the pollution, what may be land pollution, water pollution, or the air pollution is also responsible. And the last one is what we call the climate change. 7% is mainly because of the climate change. So let me speak on the climate change. So these are the drivers. So what will happen? And the entire economic activity or the economic GDP is going to come down. We are likely to lose 2 to 5 trillion euros if this continues. And look at this one. What are ecosystem, species extinction, ecological communities, biomass, nature of indigenous people, all are affected because of this extinction rate. The rate of extinction has increased substantially over the years. Now, this is the reason why we are looking for climate change or the global warming. What exactly the climate change and global warming? I'll just give you a small introduction about that one. Before that, I want to tell you two important organizations, two important world bodies, or two important WHO or what is known as the United Nations organizations are responsible for taking care of this climate change. The one is Convention on Biodiversity, CBD, which I have held in 1992 at Rio de Janeiro in Brazil. So there are three important points in that one. The first one is the biological diversity. We have to conserve them. The second important point is we have to use them in a way that is sustainable utilization. The third one is whatever benefit you get from that one has to be shared with all, fair and equitable sharing of the resources. And lastly, the fourth one is access to genetics resources is yet another one, and appropriate transfer of relevant technologies, because we are underdeveloped. We are likely to be developed into a developed country. So there are some technologies that have to come from developed countries to the underdeveloped countries. So this is yet another important thing that is. And we know that one, this entire Convention of Biological Diversity is related with the climate. So there is a relation between climate change and the biological diversity. And this convention, you know what is a convention and an act? An act is the one which is passed by a parliament with a 2/3 majority. Wildlife Protection Act, Air Act, Water Act, Environmental Protection Act. So these are the acts that has been passed by the parliament with a 2/3 majority. Whereas convention is the one, is an understanding, is an agreement between two or more countries. Unilateral, bilateral, trilateral, quadrilateral, or multilateral agreements. So agreement between the different countries is known as multilateral agreement. 195 countries have agreed. That is, we need to protect biodiversity. We need to take up the important facts about the biodiversity. But unfortunately, look at all this one, is yet the United States of America has not signed for this biodiversity agreement, because they want all the benefits, but they don't want to commit anything about biodiversity. This is the unfortunate part of it. Is you can see that 196 countries have agreed as on today. Everyone has agreed except this Alaska part and the United States of America. This is a very unfortunate part. So that is the same reason I'll go and give you the other one. So look at this one. How much money we are losing by losing the biodiversity. You can see them in terms of billions of dollars. You can see them how much genetic variability has affected. You can see them how much what is known as soil quality and retention has affected. You can also see them how much estimated US producers, and you can see them in terms of the billions. So this is what we call as the biodiversity loss. So this is because of what is one part of it is the climate change. Now if you look at the climate change was established in 1988. So I am going to the preliminary one only. I'm not going to the higher level of this one. So 1988 was the first when climate change was formed, or WMO under United Nations Environmental Program. So it was in 2005, 1995. Subsequently, 2005, there was an agreement. This agreement is normally known as the Kyoto Protocol, or what we call it as the Paris Agreement. The Paris Agreement or the Protocol. And there was subsequently then the Intergovernmental Panel of Climate Change. IPCC was formed in 2005. So this is how so you may ask me what exactly the Paris Agreement. The Paris Agreement is nothing but we need to contain the temperature less than 1.5 degrees centigrade. Now the change over the 100 years is not more than 0.8 to 1 degree centigrade. If it can happen, if it can change to such an extent, devastating extent, if it goes beyond 1.5 or 2 degrees centigrade, you can imagine what will happen. So that is the reason why we need to contain the temperature of the Earth less than 1.5 in the 1900 program. So this is what we call the agreement. Again, look at this one. Look at this one. Again, everybody has agreed. Again, Australia and United States of America has, as on today, has not signed for the climate change agreement. So they want to benefit because the highest polluters are in the United States of America. So as on today, you can see that one. These are the red ones, not signed or ratified or declined. They have declined. You can imagine, this is United Nations Framework for the Climate Change, UNFCCC. So as on today, they are the highest polluters in the world are the United States of America. And as on today, they have not ratified or agreed for the principle of IPCC. Now, what exactly is that one? Number one is we have to keep it below 1.5 degrees centigrade. The change over the 100 years is only 0.8 to 1.2 degrees centigrade. So we need to keep the temperature below 1.5 degrees centigrade above that normals. And then not only temperature, we need to keep sea level rise. There is 0.4 millimeter rise in the sea level every year. And I'll come back to that one, more about that one at a later stage. So this is how the Kyoto Protocol or the Paris Agreement. Look at this one. If it increases to 4 degrees centigrade, what will happen? This is 2 to 4 billion costs, 7 billion deaths. And you can see that one is about the deaths, diseases, due to diseases, it will be 250,000 deaths if it increases to 4 degrees centigrade. So vector diseases, vector-prone diseases will increase substantially if there is a rise in the temperature of this one. So it is for this reason we need to keep the temperature intact. Cell ಹೋಗಿದೆ ಅದು ಅಲ್ಲಿ ಹೋಗ್ಬೇಕು ಅದು ಹೋಗ್ತಲ್ಲ Now that is in 2022, Honorable Prime Minister visited the Paris, and they have made an agreement wherein the scientific evidence is unequivocal that the climate change, which is unequivocal, climate change is a threat to the human well-being and to the health of the planet also. This is what has happened, and this is the IPCC has given a clear indication that the climate change is responsible for the entire loss of life and the entire human scenario. There are a lot of hue and cry throughout the world. Somebody wanted to have a climate change format. Somebody did not want, especially American, did not like to have the climate change. Higgs signed this climate change agreement. So there was a lot of, you can see the Guardian and other this one. So lot of plus and minus, for and against of the climate change has happened. Now, what exactly this IPCC? Now look at this. The function is they have to, objective is to open a transparent basis for the scientific, technical, and socio-economic information relevant to the understanding the scientific basis of the risk human-induced climate change, its potential impact, and the options for adaptation and mitigation. And that is the most important, what is one of the objective of the IPCC. This is the objective of the IPCC. Now, the next one comes climate. We usually call climate. What exactly is climate? The climate is exactly made up of 4 factors. One is the humidity, the second one is light intensity, third one is the precipitation and rainfall, and the fourth one is the temperature. So these are the basic factors about the climate, and this in turn is dependent upon various other factors, the slope and other factors. These are the most important factors about the climate. Now this climate, there is a modeling, the Hadley modeling at the United Kingdom. So they make models, and this is what we call the climate change models. And in this climate change models, first in 1975, they have taken what exactly was the atmosphere has taken as a single unit. Subsequently, in the various years, you can see in 1985, 92, 93, and recently, all these factors of atmospheric chemistry, carbon cycle, non-sulfate, sulfur, aerosol, ocean and sea, land surface, everything has been taken and a climate change model has been come. So what we say about 100 years is based upon these factors. Originally it was only one, subsequently all were added, and the climate change is mainly based upon these factors. Now this is how it has happened. Now, in the 6th in 2022, when they want to find out the sea level change, not only from the aerial with the satellite technology, there is a ground truth data also has been taken. Look at the places where they have assessed. It is not just only sitting in their lab and then continuing it. So they have taken assessment throughout the world in the coastal area. How much, whether it has risen, whether it has come down. So these are some of the important aspects by NASA and various other groups of organizations have taken into account about the climate change. This is about the sea level change. Now, you also need to understand between there is a difference. Normally we speak about the climate change with global warming. The global warming refers usually to the temperature, average increase in the average temperature, whereas the climate change is temperature, humidity, rainfall, and weather pattern. And it is not 1 or 2 years. This year is very hot, next year is very slow, very cold. It is taken in a very long average of minimum 50 years. It could be 100 years also, or minimum 50 years is the most important thing. So there is a definition for a climate change. This is the definition what a climate change is. I will not go, please read yourself. Now, what are the factors that has affected throughout? The first one is temperature. The temperature is affected. Now, you can look at the temperature anomaly here between 1880 to 2020. 2022 also has come up. Now you can see this one, it has risen to the extent of 0.8 degree to 1 degree centigrade. 0.8 to 1 degree. It has not increased more than that one. So within 100 years, 1880 to 2000, no, only about 0.8 degree increase in the temperature. This is the total increase in the temperature, average temperature of the world. And Next one. You can see this one. In between 2016 to 2020, there was a very small variation also. This is how the climate temperature has been calculated from 1951 or 1880 to the 2020. Subsequent has not come up, so it will come up in the next 2023. After 2023, it will come up because they are calculating up to 2022. So you can see this is all data coming from the NRSA or NASA and other organizations. Now, at the same time, there's an increase in the temperature of the ocean also. Sea surface temperature, SST. So it has also increased substantially to the extent of 1 degree to 1.2 degrees. So sea surface temperature has also increased substantially between 0.8 to 1.2 degrees centigrade throughout about 180, 120 degree, 120 years. Now you can see this temperature over the years, how it was in 1880 and 2020. You can see again it is somewhere around 1 degree centigrade. 1.2 degrees centigrade has increased substantially even in the sea surface temperature and from the normal average that has been calculated. Now you can see this one. The next one is the carbon dioxide. The increase in the carbon dioxide, morning he has said it was in, you can see that one 1990 it was about 380, now it has become about 450 milligrams. So carbon dioxide has increased substantially. Now this has got an effect especially in the marine ecosystem. I'll come back to you at a later stage about this one. Now you can see this one again in China, followed by United States of America, Europe, and India is about 2,622. This is how the amount of carbon dioxide is increased over the years in this one. Now the next one is greenhouse gases. It may be carbon dioxide, methane, nitrous oxide, or fluorinated gases. It has increased substantially over the years. So these are responsible for the climate change. Now you can see this one. There is, look at this China, world's largest emitter of the greenhouse gases, is yet to submit their report. We have already submitted, India has already submitted in advance. We are containing our carbon dioxide level. We are containing our greenhouse gases level, whereas China and the United States of America is yet to submit, and these are the gases, and that is how we have status report of India has already gone to United Nations. Now, the next one is, look at this one. Increase in the sea level. It is mainly because of 28 trillion tons of ice in 23 years has completely melted. And because of this melting of the ice in the glaciers, we have increased the level of the sea rise. There is a sea level rise increased to about 4 centimeters. And if it continues to a larger extent, you can see at a later stage also, you can see this one. In 2023, the global mean sea level is 101.2 millimeters, that is 4 inches above 1993. So this is how the sea level rise has increased substantially over the years. So this has got an impact at a later stage, I will tell you. Now you can see this one. What are these ones? The first one is China is going to be affected, followed by India, Bangladesh, Vietnam. These are the 10 countries which are likely to be affected above the sea level. Especially the Bangladesh is likely to be affected because it is at a low level. And India especially, I will show you my next slide. You can see this one, Bangladesh. This is the entire Sundarban area of the West Bengal. As a result of the sea level change, you can see this one, entire mangrove. The mangrove in the entire area is completely lost. You can see the mangrove level in the various stages. The mangrove has completely changed, and as a result of the sea level change, and many of the smaller islands is likely to be submerged in future. You see, people are affected. Lot of people are affected, and they have become what we call as the climate refugees. They have become climate refugees. You can see this one. They have become climate refugees in their own place. They have lost their identity, and you can see the number of deaths also. Disasters in 2019. You can see this one also. So there's a large number of deaths is mainly because of the sea level change and cyclones and all the other climate factors. So There's a report, UN report. This is the only one tiger in the entire world living in a mangrove area, in a marshy area, and we are likely to lose by 2050 if this climate change continues. Because most of the islands, because they hop from one island to another island for collecting the food material. So if it submerges, then we are likely to lose this particular Royal Bengal tiger. This is the situation if the climate change continues. And how about the other areas? This is the Gulf of Kutch, which is it may be Poshitra, it may be Gulf of Kutch or Narara and other places. GS Foundation has given me this one. You can see large number of areas, and most of the corals in that particular Gulf of Kutch has completely inundated and lost. Now we are translocating the Gulf of Kutch corals. We have taken a project on translocating the Gulf, that is the corals in the Gulf of Kutch. So this is what happens if there is an increase in the sea level or a change in the sea surface temperature also. Now how about Maharashtra? Look at the Maharashtra. The amount of fishes that is caught has come down, mainly because of the what is the climate change. You can see this one, nearly about 4.5% has come down, 50% decline in their annual fish catch. It is mainly because of the climate change. Now, all of us know the South India, especially the Gulf of Mannar, Tamil Nadu, that is Rameshwaram area. It is made up of about 21 islands, smaller islands, 21 islands. Now there are only 19 islands. We have lost 2 islands already. Now you can see this one, the level it was in 1969, it was 20.08 hectares. And when you come down to this one, in 20, it is 3.6 hectares. That means we have lost all the area, mainly because of the increase in the height or what is sea level change. So this is what happens. And then the entire plants and animals in that area is completely lost. So vulnerability index has been calculated, and you can see this red form, and all these are vulnerable, especially in the west coast. We are safe. West coast is comparatively safe than the eastern coast, and the most vulnerable area is the what is called the West Bengal and the Bangladesh, and some parts of Andhra Pradesh also. This is what happens when there is a climate change. And now, look at the other one important is acidification. The carbon dioxide is increased substantially. Carbon dioxide reacts with the water. It becomes a weak acid, namely carbonic acid, H2CO3. Again H2CO3, again it becomes hydrogen ions and carbonate ions. And these bicarbonate ions acts on the seashells, especially the crustaceans and mollusks, and that has comparatively. In addition to that one, you can see that 8.18 was the pH at one particular time in 1880. Now you can see that it has come down to about 8.06. The pH level has comparatively come down because of the acidification of the oceans. And this has got a lot of impact on the marine ecosystem, the animals and plants, especially the ascidians and the corals and all the shelled animals has completely impacted, mainly because of the climate change. Now, you can see that seashells, lot of seashells, it has become thinner and thinner. And mainly because there is what is known as the carbonic acid there. And you can see that one, about 33% of the corals are in danger. So this is one of the important, if you go to Southeast Asia, this is the oyster shell, which fetches you a lot of material. Now the oyster shell has come down, and now our economy of the fishermen has completely come down, mainly because of this one also. Now you can see this one, you can see the molluscan production has comparatively come down in recent years, mainly because of the acidification of the water, and this one has been given by various organizations also. Now, the entire, if you look at the scenario of the Indian export performance, though it has increased to $7,759.58 million, now many of them, especially the mollusks, the number of mollusks that is caught in that one has really come down in recent years. It is mainly because of the climate change. Now, you can see the other one important factor that affects the climate change is the current inside the ocean. This is what we call the ocean current, and this ocean current is responsible. That's the current movement of the current going up and down, upwelling and downwelling of this current, and this is also responsible
because of the climate change, change in the climate. Now you can see this one, the uneven heating of the earth causes the convection current to create the prevailing winds of the ocean currents. So as a result of it, there is a current change or the ocean current change, and these are the impact of ocean current change. Now, to give you more important, these are some of the important on the marine life, how the current changes. Ocean current has impacted also. You can see upwelling and downwelling. As a result of it, the nutrients will come up, and some of the nutrients will go down. Hydrogen sulfide will come up because the carbon dioxide has increased H2S, free hydrogen ions will meet with the sulfur, becomes H2S, and that will be more dangerous for the animals. So the number of plants and animals, because of the upwelling and downwelling of these gases, there will be a lot of changes that are going to occur. There is a phytoplankton and zooplankton, smaller organisms like smaller animals and plants. This is likely to be affected. When these are affected, the fish population is completely disappearing. It mainly depends, many of them are dependent upon the phytoplankton and zooplankton. When once it moves away from that place, people have to go to a larger area to cover and collect the fishes. So this is one of the important. As a result of movement of the larger area, you are spending a lot of money on your diesel. You are spending a lot of money on your diesel. And because of the diesel, and also getting lesser number of fishes, and we are likely to have a large number of impacts also. This is yet another impact that we can see. The third one is phosphate, nitrate, and other things. There will be a change in the phosphate, nitrate content of the ocean because of the climate change. And because these climate change, these are nutrients have changed, the phytoplankton and zooplankton variations has been occurred, which affect indirectly with the fish population. So this is yet another important aspect of the climate change. Now look at, there are some toxic gases are released. Because of the toxic gases, fishes are dead. Fishes are dying. Large number of fishes you have seen in the lakes, and you have seen in the lakes during the summer period. Large number of fishes are dying. It's mainly because of the toxic gases. These toxic gases are not released from down. It's also released from down, especially from the algal blooms, the green algae. What this happens is, these green algae covers the gill rakers, the gills, and they cannot respire at all. Because of the absence of the respiration, the fishes will die. So especially because of the climate change, we are observing many of these ones, especially the toxic algae. Now, that's what I said also. This is the Gulf of Mannar near Rameshwaram. There are 21 islands, and some of the islands have completely lost. There is a lethal spread of also an algae, that is Tepaphysius invasive seaweed. So this has completely created a condition, and that is the reason why we are having the climate change studies in this particular area. So ocean current, you can look at this in ocean current, the impact of the ocean current on various organisms. Now look, they are moving, people are moving away from their place to collect fishes. So this is one of the important is the fish catch has completely come down. That is the reason why in the morning of us I said that one, what is known as the poverty alleviation. This is mainly because of the climate change. Now there's one more thing, you can see this one also, the carbon dioxide, and it has reduced the size. Many of the risers, you can see this one also, many of the fishes have completely lost. Fish has been lost in the market. Important fishes have completely lost in the market, mainly because of the carbon dioxide, or what we call it as acidification. Now, you can see this one, number of fish catch has come down substantially, and number of fishes size also has come down substantially, is mainly because of the acidification of the seawater. Now you can see this one, and you can see the size of the animal has come down substantially because of the acidification of the seawater. And you can see this one, you can completely, this is a part from our own, from Uttara Kannada, Karwar area. You can see the global warming results in the increase in the sea surface temperature. As a result of it, smaller pelagics have increased. Instead of the fisherman goes to the ocean to collect the fishes, instead of collecting the huge size fishes, he collects only the small size fishes, which will yield less amount for him. So this is what has happened mainly because of the climate change. Now, this has been completely proved. This is a golden toad, and in Costa Rica is completely lost, extinct, no more available. And this is mainly, it has been clearly claimed because of the climate change. because of the water quality has completely lost. This is completely, it is over the years. In 2000, it has completely no single animal is available. It is mainly because of the post, what is known as the climate change. Now, if you go to the ocean, there are 7 different types of what is known as the sea turtles. You can see the different type of sea turtles, and this sea turtle develops. Sex determination is by the sex chromosomes, but development is something different. So we have done the experiment on the cooling and the increasing the temperature of the sand, because they lay the eggs inside the soil. Inside the soil, when the temperature decreases, there are more number of what is known as the male. When the temperature 1 degree increase, there are more number of females. So there is a sex ratio has completely altered, mainly because of the increase in the temperature, and this has been attributed mainly because of the climate change. So we have done this experiment also, and you can see that one projected response of the endangered marine turtle population because of the climate change. There will be more number of females rather than males. Sex determination is conducted, but this is mainly because of what we call the climate change. Now, you can see this one, more number of females coming out in the area. There is an area in Orissa where millions and millions and billions of turtles come, olive ridleys will come, and then some of them will go to Thailand and Costa Rica also. So it travels. You can see this one. It travels how much? 7,000 miles into 1.6 cubic kilometers. You can imagine how much kilometer they travel. So they travel so much kilometers in the entire from South America, or even from Costa Rica, or from some other what is on West Indies. It comes to breed in India. It breeds in what is known as the Andaman Islands. It breeds in Malaysia. It breeds in some of the Southeast Asian. So it travels to the extent of 7,000 miles. So you can see how much of them are lost because of the climate change. Now you can see this is the olive ridleys. This is one which comes from, you can see, we have calculated by satellite tracking, the zoological survey which I am working. We have got a group of scientists who are working upon by tagging them and satellite tracking them. It comes to about 9,417 kilometers it has traveled. We have caught some of them in what we call it as Sri Lanka. We have caught them back in their own place. So it travels. So we have found them in Orissa. And some of them even Karnataka also. Very rarely it comes, very we come across the olive ridleys. So this is how. If you look at the birds, the bird migration, all of you know about the bird migration. There are different types of migration. There are 8 different types of migration. We have got what we call as the Asian, here is India. We have got what is known as Central Asia migration. So because of the climate change in the Himalayan belt, it is affected. So the migration of the species is completely affected. So this is, you can see another example. It is not our Indians. This is because of the climate change. The breeding season has completely changed. Now you can see that one, 24 days has been advanced. In 5 years, we have seen that one. That's the reason the breeding has been completely affected, mainly because of the climate change. There are 9 species of birds in the United States of America has been affected because of the spring season, early springs. Spring is coming much earlier than that one. Because of that one, it has been affected, and this is one of the impacts. So there is a lot of, in about a few days back, May 15 and October 14, we always have World Migratory Bird Day in 2023, and wherein we refer water is the most important aspect. We need to conserve them, we need to protect them. So many of the mammals also, there are many mammals which are affected because of the climate change. Now, yet another factor of the climate change is the ozone hole. I will not go into the detail about the ozone hole. It takes again a long time. So you can see this one, various years, the ozone layers in the Antarctica, because we regularly, every year or every alternate year, we send people from our own organization to Antarctica to study the animals there. So we have found out the ozone hole there. So we have found out there are a lot of changes in the ozone hole. Because of that ozone hole, the entire animal scenario has completely changed in the East one. So what has happened is none other than United Nations Secretary General, 5th September 2008, the impact of the climate change are devastating. And we need climate action. We need climate action to prevent ever greater crisis. We must act with a greater ambition and urgency. The new climate economy report shows how. That means in 2022, they have given how we can act upon that one. So what are that one changes that has occurred? You see, air temperature has increased. You can see that the increase in the air temperature, increase in the sea level rise, sea surface temperature, ocean heat content. You can see the decreased polar ice, and you can see the net decrease in the global ice content, increase in the water vapor, increase in the atmospheric temperature. These are the changes that we have seen because of the climate change. So, at what level this climate change occurs? It can occur at a genetic level, it can occur at a species level, it can affect at the ecosystem level. There are 3 levels in which the climate change can occur: at the genetic level, the species level, and the ecosystem level. Now, we have found out in the 21st century ecological sensitivity of the entire area, and there are various changes that have occurred because of the climate change. That is what we call it as ecosystem changes, is mainly because of the climate change. Now, you can ask me a question, what exactly an ecosystem? Ecosystem is nothing but an interaction between the plants, animals, or living and non-living organisms, and with the entire interaction as a functional unit. This is the definition of an ecosystem. And this we have different type of ecosystem. We have different type of forest ecosystem, freshwater ecosystem, marine ecosystem, grassland ecosystem, desert ecosystem, mountain ecosystem, wetland, estuaries, mangroves, all are affected mainly because of the climate change. All systems, ecosystems, name any ecosystem India has got. From the high altitudes of Himalaya down to Kanyakumari, we have all types of ecosystem. All are affected mainly because of the climate change. Now, these are the services that the ecosystem gives. The one is on the provisioning, second one is the regulating, the cultural is the third one. And this is the most important. The regulating, the climate change is the regulating aspect of it. So that affects the basic material for good or life, and indirectly affects the freedom and choice of the human being. So this is how the climate change has affected. So the entire thing, if there is agitation and ecosystem services, climate change, all are interrelated, and these are mainly because of the human impact, anthropocentric changes that affect. I'll come back to lastly, I'll come back to within a few slides about the marine ecosystem, because this is where I work. This is the marine ecosystem. This is a natural capital. Here are the list of items that marine ecosystem help. It may be ecological services or the economic services. These are the marine ecosystem. It's the capital for a marine system. Now there are something like that one. The most important thing is, you can see 20% of the human population live around the marine ecosystem, seas and oceans. 20% of the human population live within the 30 kilometers of the sea, and nearly double the number and 100-kilometer range. So large number of people are related with the human or living around the ecosystem, especially the marine ecosystem. And that acts as a recreation. It helps in recreation, tourism, and medium of transport, respiratory for the genetic and biological information, and sinks for the waste. This is an important aspect of a marine ecosystem. And you can see that one, Earth's surface, it covers about 70% of the Earth's surface is covered by what we call the marine ecosystem. You can see how much people are living around the coastal zones. You can see how many people are living around the coastal zone. So if there is any change in the marine ecosystem, these people are affected. And most important, you can see that Bangladesh is likely to be affected because it's almost a flat. It's almost sea level. It's almost in the sea level than Cambodia, China, and India. India is almost on the 4th stage. So this is how our entire ecosystem is affected. Now, in the marine ecosystem, there are subdivisions like coral reef, mangroves, seaweeds, and seagrass. In the marine ecosystem also, we have subdivisions like the seagrass ecosystem, seaweed ecosystem, and the mangrove ecosystem, and the coral reef ecosystem. These are the ecosystems that are prevalent in the marine area. Now, look at this one. These are the area that is covered by 9 states and 4 union territories in our marine area or coastal India. These are affected mainly because of that one. And this is the entire group of animals that are found. Nearly about 21,663 animals, species. This is not the number, this is the species number. So you can see that one, species of biological diversity, especially animals I am telling you, not the plants. I am mainly concerned with the animals. So this is mainly about 22,000 species of animals are living inside our area. So this is the diversity what we have got will be affected mainly because of the sun. Now, I was working upon the Andaman and Nicobar Islands. You can see that one way back in 2010, we have calculated only 9,600 species are present. But now, last week only, I compiled another one, given another this one. Now it has come to 1,04,000. Andaman is about 11,000 species of animals are present. So that means that we have increased mainly because we did not know much about it. We again recalculated. We found out where our loopholes are there, and we increased. So we can see that one, the most important area is the Andaman and Nicobar. Now, in this Andaman and Nicobar, you can see the seagrass ecosystem. Or the entire area, you can see the seagrass ecosystem. This is most important area. It acts as a carbon sink. It attracts all the carbon. It acts as a carbon sink. There are about 7 genera, 6 families, nearly about 114 species, out of which Andaman Nicobar has got nearly about 10 species of this one. Now you can see this one. These are the number of species that are present around that India. I have marked that one. So, see, 70 million years old, we have got a terrestrial tree grass which has migrated. So normally there is a migration from the marine to freshwater to terrestrial. But this is a reverse that has happened. From the terrestrial, it has gone to the freshwater to the marine ecosystem. So we have got a 70 billion years history about them. And then is a crucial role in combating the climate change, enduring the food security, protecting the coastal line, and enhancing the biodiversity. This is one of the important aspects of the seagrass ecosystem. And you can see this is a major sink, carbon sink. It attracts all the carbon there. And it is an area wherein the largest, namely the dugongs, largest mammals, dugongs are there. And we have got a dugong survey with millions and millions of dollars have been poured into this one to find out how many dugongs are there, where they are distributed around Gulf of Mannar, Andaman Nicobar Island. We have got a project on this one also. So we are working upon this one, the dugongs, the marine mammals. So large number of marine mammals feed upon the grass. That is the seagrass ecosystem. This is one of the important aspects of it. Now, other one is some of the what we call as holothurians, sea cucumbers. Sea cucumbers, many of you may not be knowing it. There was a project given to me way back in 2006 to 2007. There is a large number of sea cucumbers are collected and sent to Southeast Asia. They are sent to Southeast Asia. If you go to Southeast Asia like Thailand, Singapore and other, even including China, Vietnam and other places, 1 cup of soup from this sea cucumber will cost you nearly about $80 to $100. $80 to $100. So it was taken away from us. So I was given a project to see whether it is sustainable or non-sustainable. We went inside the ocean, dived inside the water, and found out whether it's how many sea cucumbers are there. We have taken a grid analysis. We have made 1 meter by 1 meter. We have found out how many are there, and then we have given a representation to the government of India. It is not sustainable at all. We cannot use it at all. So, and then government of India has completely banned now. No more sea cucumbers are exported from India outside the country, collected at all. So this is how there is a large number of sea cucumbers, and you can see that one, the number of species are present in that particular area. So you can imagine how much it will be affected if there is a change either in the carbon dioxide, acidification, or nutrient cycling, or various sea surface temperatures. The second one is on seaweed. The second system is known as seaweed. There are a large number of seaweeds which belongs to a group of algae. What is known as, it could be a brown algae, red algae, or a green algae. Theophyceae, rhodophyceae, chlorophyceae. So these are different type of an algae that are present. So these are algae that the glacial area or this one. There are a large number of species of algae that are present in our sea also, and that will be affected. Now this is, you can see this one. This is one, if you go to south, what we call it as our Rameshwaram area, this has substantially increased recently, mainly the Kappa facies. You can see this one, and this is what has happened. So the number of algae has increased. Kappa facies has increased substantially. It is a green algae, so it has increased substantially. It is mainly, it is not our country. It is an alien species coming from the other country. It has an alien species that has increased substantially over the years, mainly because of the climate change. So these are some of the important aspects of it. These algae, these are the functions of many of these algae, what exactly it does it, and how they are used medicinally also. Many of these algae are important medicinally also, so that is happened. The next important aspect in the sea ecosystem is the mangroves. Most of you are well aware of the mangroves. Mangrove ecosystem. Mangroves is a group of plants which are salt-tolerating plants. It can withstand the various salinity gradients from 0.5 or 5 milligrams per liter to 34 milligrams or 35 milligrams per liter. So there is a variation in the salt content in the coastal area, especially where the rivers meet the sea. Estuarine area, we call them estuarine area. There, for example, if you go to Pavanje in Mangalore area or Uttar Kannada and Dakshina Kannada, so we have large number of areas. Or if you go to Sundarban, it is the largest mangroves in the world. Sundarban is the largest mangroves in the world, including Bangladesh and India, largest mangroves in the world. So we have got a mangrove ecosystem. And these are, if it is known, this is always known as what was the roots of the sea. Now this is a very important ecosystem. You can see this one, it protects the shores. These ecosystem, it breaks the water current. It cuts the water current, and this is how it winds and waves of the water currents are cut. It protects the soil. Soil erosion is protected. You can see the coral reefs are helped, and supply of the wood, many of the wood material, and also what is known as the medicinal properties are there. So they are all from the, what we call it as the mangrove ecosystem. And you can see how nature-based engineering, a review on reducing the coastal impact, is mainly because of the mangrove ecosystem. Now, you can see that mangrove ecosystem in Florida, you can see how much they earn also, and from this one, from this mangroves, and what are the uses. You can see that it helps in fisheries, it helps in cleaning the water, carbon store, coastal protection, and ecotourism. So we go to what is known as the Sundarbans, mainly to see that entire area. So coastal tourism is one of the important aspects. They allow it also. Now, there are different type of mangroves. Some of them are salt tolerant. Some of them are salt absorbent. Some of them are salt removal from them. So there are various salt accumulators, and salt nematophores are there. Shooting the roots are there, and roots will come out with a lot of salt content. If the salt content is excess, they remove the salt from them and throw out. So these are some of the important aspects, and you can see the adaptations of these mangroves. So you can see this one. We have got, these are the areas where we come across, starting from Andhra Pradesh, and the highest is in West Bengal. Mangroves is the highest in West Bengal, followed by Gujarat, and then by the Andaman and Nicobar. You can see the Gujarat is 1117, there are 616 square kilometers is what we call it as in West Andaman and Nicobar Islands. So everywhere there is a disappearing of mangroves, except India. India, it has increased substantially in recent years by 1.2% in India. This is what we have seen in the mangrove ecosystem. And these are various animals that are present along the mangroves. I will not go into the detail about it. So you can see some of the animals, and these are the number of species that are present in the mangrove area, nearly about 11 species. So you can see. Now I am relating this mangrove area into the cyclone. There are super cyclones. You can see cyclones during 1770 or 1839 or 1999. How many people have died? And wherever mangroves were there, the number of people, death of the mangrove people has comparatively come down, because it breaks the current, it breaks the wind, it breaks the what is known as the cyclonic storm. So because of that one, you can see this one also, how many people are affected, and what are the dates in which they were affected. You can see 1935 in Calcutta were affected. And because of the mangroves, people were completely this one. And I hope you know that one about 2004, 26th of December, there was what is known as a tsunami. 2004, December 26th, early morning, and there was a tsunami, and the entire coast was devastated. Large number of people died in Madras area, Chennai area, and down south also. 118,000 people were died. Nearly, that is a recorded one. How many unknown deaths, we do not know about it. And wherever mangroves were there, they were protected. Even in Andaman and Nicobar also, immediately after the cyclonic storm or tsunami, I went to Andaman and Nicobar by a special flight because the government of India has arranged for a special flight for all of us. And we made a survey of that entire area, covering what has happened to the entire animal and the people also. We have found that one, wherever there are mangroves, people survive. In 2002 also, there was super cyclone in Orissa, and the people survived because of that mangroves. So wherever mangroves, so that is the reason Honorable the late Chief Minister of Tamil Nadu, Jayalalitha, said, why don't you grow mangroves all along? It's impossible. We cannot grow mangroves all along. Wherever there is an estuarine area, wherever an area where the water, fresh water meets the ocean, then only we can grow that one, and nowhere else we can grow. So we cannot grow mangroves everywhere. We cannot grow mangroves everywhere, and this is what has happened in that area also. So you look at this one, the disaster in 2004 on 26th of December. So a large number of people died. Nearly about 200,000, particularly in North Sumatra area, is completely down because there was no mangrove area in that all. And cyclone or what is tsunami was very close to them also. That's why they have lost their lives. So this is what has happened. Mangroves have an important agent to reduce the speed or current and thus devastating. So that is the reason we call mangroves as bioshields. We call mangroves as a shield that protect the human being. So you can see them mangrove area, and this we call it as a bioshield for tsunami or when a cyclone affected area. Now the next one, the last one, is the coral reefs. Corals, hope you know, most of you, these are present only in some areas, not in all the areas. They are present in the coral reef, and they are known as the Indonesia, Australia as the largest, and you can see the India comes on the 4th position. So India is about 5,590 kilometers of the coral reef. That is 2% of the total of the entire area is this one. Now you also know that one, about 33% of the corals are endangered species, and that is the reason why we are, whenever you go to seashore, you are not allowed to collect any coral. We have put them under the schedule, Wildlife Schedule Act. Nobody can collect a coral there. Nobody can collect and bring it them. If you are caught, you will be charged with 25,000 to 3 lakh rupees with a 3 years imprisonment. So don't bring any coral from anywhere. If you go to what is on the Andaman and Nicobar Islands or anywhere in the seashore, sometimes they may give it also, but don't collect it. If you are caught, then you are legally punishable for that one. This is because we have kept them. Similarly, there is one. There are 5 species. There are 5 species in the world that is known as a very, very old, 30 million years old animal is there. That is distributed only between the Orissa and West Bengal, nowhere else. 2 species are distributed. So they were coming here, collecting them because it has got bioactive components. And these bioactive components are used for curing cancer. So they used to come and collect. So what we did was, we stopped collecting them. We stopped collecting them, put them on the Wildlife Protection Act. So when once it comes under the Wildlife Protection Act, nobody can touch them. So that is how we make the, since I am a member of a Wildlife Board of India, now at present I am Board of Governor in the Wildlife Institute of India, we take care of these aspects of it, how to protect our own animals and plants and what is known as the protect area network, and we give them a suggestion. We are only an advisory body. We don't act at all. We give suggestions only, and it is only the state government that needs to be implemented. State government has to implement it, and it is only an advisory body. So we give them the entire thing. So these are, you can see them. These are different type of corals. You can see the different type of corals. This is the largest coral in Andaman and Nicobar. You can see the largest coral. There are flat bottom vessels, glass vessels. You can see them and see the, either you can snorkel, go inside, deep inside, or you can see them in a glass bottle. If you go to what we call it as the coral reef in Australia, there is a boat which will take you inside the water, where you can see the large number of corals and coral associates, plants and animals are there. So you can see them. This is the largest coral that is present in Andaman and Nicobar Island. So there are only 4 areas in India which we have got coral reef. One is Andaman and Nicobar, second one is Lakshadweep, third one is Gulf of Kutch in Gujarat, and fourth is Tamil Nadu Gulf of Mannar. These are the 4 areas where we have coral reef. But we also identified some area in Malvan coast in Maharashtra, Orissa coast also we have identified, and recently we know that one, of course quite a long back it was known earlier, but we have made an investigation, and very close to Karwar, there is an island, Netrani Island, and around the Netrani Island we have got a large number of people are coming, and it has become an ecotourism spot, mainly because it's a coral area. A very large, a limited number of corals are there. Nearly about 484 species are distributed in India. There are about 40 species are only there in Netrani Island. So we have found that one in the Karnataka also, this coral reef. So this is how the coral reef are present. One is Andaman and Nicobar Island. This is Lakshadweep. The entire Lakshadweep is formed from the corals. It's a coral island. The entire island itself is based upon the corals. Coral is nothing but a group of animals, and they secrete calcium carbonate below. So that becomes a very big one and becomes an island, and this is how Lakshadweep is formed. And Gulf of Kutch, if you look at the entire scenario of the world, there is a range, the northern range and the southern range. The highest range is the Gulf of Kutch, where we can see corals also. So this is the highest range, or the northern range, between the Tropic of Cancer and Tropic of Capricorn that are present between these two, and with the central equatorial region. So this is present, and this is the highest range of the largest, the taller area where we can come across the Gulf of Kutch. So this is how we have got. You can see the Andaman coral reef, and this coral reef. One important thing you need to understand the coral reef is, it is an animal. This animal is associated with a plankton, plant. A coral is an association, what we call it a symbiotic association of plants and animals. What is symbiosis? You know that one. They give food, they give protection, like that one. So this is a symbiotic association. So this is how a coral is formed. Down below you have got calcium carbonate shells, or calcium carbonate. So what happens when the sea surface temperature increases? When the temperature increases, or carbon dioxide with the water, carbonic acid increases, these algae will go away. These algae will be removed from that place, and corals become white. If it is continued, it is going to die. Coral death. So these are the symbiotic corals, or the symbiotic associations of a plant and animals. So this is how, this is now, look here, these animals, these plants have completely lost, and as a result of which it has become white. This is known as the bleaching of the corals. This is known as the bleaching of the corals, mainly because of the acidification of sea surface temperature, increasing sea surface temperature. So you can imagine how much we are going to likely to get from this one. Okay, these are the north and south. I told you about it. This is the equator. That is what is known as the Pacific region. And this is down below. So they are all present along the equator only. The coral reef is actually present along the equator. Now you can see these have become white in color, or what is known as the coral bleach has occurred. This is an example from Gulf of Mannar, 2014, 15, 16, 17, 18, 2022 also. 2022 is the highest surface temperature. Water surface temperature increased substantially. So we have seen large number of area has become white in color, and sometimes again recolonize also. The plants or the phytoplankton recolonize, they give again become live. They give beautiful colors, and you can see that one. So coral reefs in India have undergone 3 mass bleachings and events since 1982. surprise bleaching spotted in the deeper coral reefs of the Indian Ocean, likely due in 2019 due to warming. So global warming is the most important aspect of it. And we have seen in the various islands of the Andaman, because Rutland Island, Riti Island, Mayabandar Island, and Mahatma Gandhi National Park, and this is Rajiv Gandhi National Park also in the Andaman Island. We have seen, you can see them, they have become colorless. This is what we call as the coral bleaching. And you can see that one, what happens and how much we are losing, nearly about 3.4 billion every year we are likely to lose if there is a coral bleaching, because there are large number of ornamental fishes. It is an area where number of ornamental fishes are coming up. So that we are likely to lose if there is a coral bleaching. And this coral bleaching is mainly because of the global warming. So these are the important aspects of the coral reefs. And you can see this one, what has been said by Hoseng Lu, IPCC chair, has said we are at the crossroads. The decisions we make now can secure a livable future. We have tools and know-how required to limit the warming. So we have got necessary tools to reduce the global warming and the other aspects of the climate change. And you know that one, in 2021, the Honorable Prime Minister of India himself went and had a climate interaction with the world people, and thus, except unfortunately United States of India, United States of America have never agreed for this climate change or the Kyoto Protocol or the Paris, this one, and now we are likely to have imagine, this is the change program in India. We have got a program in India, Sustainable Developmental Goal. There are 17 sustainable developmental goals. Out of the 17, this is the 13th one, and this is what is likely to happen. You see, when once we are committed, India is committed for a global change, we are likely to reduce the emissions intensity by 20 to 25% by 2020. We have already achieved 2016 itself, we are likely to achieve this goal. 25% we are likely to achieve by 2025, and we are also likely to reduce emissions by 30 to 35%. So already we have on the way. We are likely to, India is going to achieve the third largest greenhouse effect is we are going to achieve by 6.9%. This is how our commitment, the Indian commitment is. They are likely to achieve much more than what other countries have done it. And now India has a plan, as already said, there's a various national action plans like solar mission, so enhanced energy efficiency, water mission, Himalayan ecosystem, Green India. These are some of the action plans that has been taken by Government of India and has been given to the various state government and NGOs to inculcate. So in addition to that one, all of you know about what is known as the Chandrayaan, but there is also a Samudrayaan also. Many of you are well aware of it. There is a yaan known as Samudrayaan, wherein we have already spent about 1,000 crore rupees. Department of Science and Technology has spent 1,000 crore rupees to send 3 persons about 6,000 meters deep below the oceans and to find out the nodules. The nodules are the golden things. The gold, you can say that one, gold nodules or the mineral nodules what we present has to be seen. So this is how we also, India has already carried out a Matsya, is this one, Samudrayaan, and 6,000 meters below the ocean and going to likely to deep sea. Already it has been established now. Only we have to send people only. There are various ways and protocols. These protocols have been developed in recently, and that's how. And lastly, is nowhere related with the climate change. Yet it is oil spills causing a lot of harm to the biodiversity. There is an oil spill also. So with this one, I would like to say, give us a chance, and thank you all. I think I exceeded my time. If there is any questions, I am here today, tomorrow, day after tomorrow, I am there. Any questions you can ask me later. I will be there only because there is another program also likely to come up, and that is the reason. And I convey my sincere thanks to the Karnataka Science and Technology Academy, Dr. Ramesh, Dr. Srinivas, and Dr. Anand, and all the groups of people who are associated with the development of a program, as technology program here. And I sincerely thank you all for your patient hearing. Thank you. Thank you.
Students, please take your seats, don't go. We have a cultural program after this session, and also a model competition is there. You please go and visit the working models. So don't go, please. Please bear for another 10-20 minutes here. And afterwards, we will start cultural program.
So, sir has a very vast lecture he has given, and starting from phytoplankton to mammals. So, how the extinction has been taken place, and he has also shown us how this climate change has happened, and he told that there is major countries are not following the polluter pay principle. So, who is polluting is not paying and he is not coming to the conventions and signing it, then it's very difficult to achieve the goals. So, with his vast experience, given us a very vast knowledge regarding the starting phytoplankton to mammals and how they are the marine ecosystem. Startingly he told why they were called for marine. So he has covered very extensively marine ecosystem, how they are actually affecting and including fisheries. So I, on behalf of my chair, he has got emergency work, he has left Dr. Jagdish sir. So take this opportunity to thank Computer sir, and on behalf of all the participants, thank you very much sir for your vast exhaustive lecture. And as sir told, if you have any questions, now 1 or 2 questions you can ask, or he is there for 3 days here, you can clarify with him also. Any questions, please?
There will be many questions, but we can be 1-to-1.
1-to-1, okay, that's better. So he is here only, we can directly interact with him and clarify your doubts. That's what madam is.
Yeah, sir is available for you for another 2 days. You can interact at any time during lunch time, whatever, tea break time. So sir is available. Yeah, yeah, very vast experience, sir.
There is the other option also you have. I've given my email address also. You can send me the email address also.
Yeah.
And the second option is that one, you can give a small slip to Srinivas or the organizer here. I will answer all your questions.
You can also organize your answers to them.
Yeah, wherever you want to.
Yeah.
No problem.
Yeah, yes, sir. So thank you very much, sir, for a very much interesting and elaborative talk. And request Ramakrishna sir, please present plant to Dr. Chandrakant Lingdal sir as a token of our respect.
Circular economics and
Thank you, Unandal. We can have a quick 10-15 minutes break for tea, and we can see those who are interested to see science models exhibitions. You can see in our reception room, that meeting room, and after that, please assemble here. We will have a cultural program for 1 hour. Okay.
ಅಲ್ಲ ಅವರು ಟೋಪಿ ಹಾಕೊಂಡಿರಲ್ಲ ಸರ್, ಅಲ್ಲಿ ಪಕ್ಕದಲ್ಲಿ ಇದ್ರಲ್ಲ ಅವ್ರು ಹೇಳೋರು ಅವ್ರು
ಮಾಡ್ತೀರಾ ಸರ್ ಕೇಳಿ, ಅವ್ರು ಶೇರ್ ಮಾಡ್ತಾರೆ, ಮೇಲ್ ಮಾಡ್ತಾರೆ, ಅವ್ರನ್ನ ಆಮೇಲೆ ಮಾಡ್ತಾರಾ ಏನು ಗೊತ್ತಿಲ್ಲ, ಅವ್ರು ಯಾವಾಗ ಮಾಡ್ತಾರೆ ಅಂತ. ಶ್ರೀನಿವಾಸ್ ಸರ್.